Hello everyone. You know, a few days ago I was quite excited to do this. I was looking forward to it. And then last night I was going over the 100 days of SwiftUI documentation and I started to get a little bit worried. I'm going to get through as much of it as I can, as quickly as I can. I know we're starting just like 20 minutes early, but I think... Let me see if music's a little bit loud. It's distracting me. So here's the plan, right? 100 days of SwiftUI. I'm going to follow the rules in this as closely as I can. I have on another view here a little counter in the... So I'm going to try and remember to keep that up to date, because what I want to do is, like, once this is done, create chapters. So that anyone who's coming back to watch it later can just like skip to the particular day. If I remember to update that number, make it a lot easier for me to search through the video. Anyway, so we're going to go over the rules, and it just says that there's 2 here. If you want to make success of this course, there are only 2 rules. Every day you spend... Okay, well, I guess we've already broken that one because we're not doing it every day. We're doing it all in one day, as much as we can. I calculate we only have less than 5 minutes per task. If we go by an 8-hour day, right? I think it's like 4.8 minutes per I don't know, we'll see. If it takes me 20 hours, I don't know. I'm feeling quite burnt out already from this week's work. That's what I mean. Like, earlier on I was very excited about this, but now that's like, it's the weekend's hit and I'm just like, all I want to do kind of is relax. But we're gonna get through it. This is going to be fun. It's going to be a fun day. Every day you post about your progress to the social... We can't do that either. Okay, so these 2 rules are... Okay, we've already broken 2 rules. I've tried to make sure that it takes less than 1 hour to complete each day, but there is a little variation. Okay, so we've got... for example, day 4 is a little shorter because it has less ground to cover. Great. Day 13 is a little longer because there's a few... Okay, fine. The other thing is, this course is awesome, but... I kind of feel a bit bad that I'll be skipping over a lot of the text and probably won't be watching the videos, because some of the videos go for like 10 minutes, right? So we can't do the videos, and some of the text we'll have to go through real quick. The idea is that I'm just going to write all the code that it tells me to write, and then we move on to the next thing. Okay? If you have questions, you can add them to the chat. However, don't distract me, please. Okay, so there's an app we can download that goes through some other... has like some other tasks that we can do, some practice and stuff. We won't be doing that. We probably won't be doing day 0. It's 100 days. We're not going to do day 0. And we start out with the introduction. So this is going to begin with, I guess, the Swift fundamentals, right? Before we actually get to doing anything with iOS, macOS type development, right? So we're starting out with Swift itself, and then we move on to SwiftUI, and it looks like everything from day 16 onwards, kind of like little projects and stuff. So I'm going to do, it does say that we can create separate playgrounds for each of these. I'm just going to use the one, type out the code, delete it, and then just we'll run it, and then, you know, keep progressing that way. Eventually it does tell us, I think we need to do an actual app. So I'll have to create a new project. I'll probably create a new project for each of those, I think. And I'm not going to put these on GitHub, because it's kind of like, well, there's no point, right? Because the code's already here. So I won't be putting any of this stuff up on GitHub. Okay, where are we at? It's 8 AM for me now. I said I was going to start at 8:15, but I think, yeah, we'll probably get started a little bit early. The navigating through this is a little bit tricky to do it quickly. So if we go into like day 1, they're kind of like book chapters. So we have to click on each one, and then there's like at the bottom of the page, we'll have like a next and that, and then we'll have to come all the way back to this screen to pick day 2, day 3, day 4, right? They don't like continue on from each other. At least I haven't found the links on those screens to be able to do that. It'd be really cool if there was like a button at the bottom of the screen. Let's just double check, okay, before I start saying. Yeah, I don't think there's a button at the bottom of the screen that says go to day 2. No. But if you jump into one of these, like the introduction, we scroll down, we have a button down here that says about this course. Okay. Let's just go through maybe a couple of these. We've got let me open up this in a new tab, right? So that we keep this screen on the far left tab. Okay, so why Swift? Let's have a quick look. Relatively young language, yes. So you should learn Swift because you can make a lot of money with it, but also because it does so many things really well. No craft, no confusion, lots of power at your fingertips. What's not to like? Okay. Yeah, me going through this quickly isn't a reflection of the content itself. It's just I'm in the mood to let's do this. How to follow along. Okay, it says there's a lot of code shown off in this book, and I really want to encourage you to try it all for yourself. I'm going to try and do that. Type the code into your computer, run it, see the output, and experiment a little, make sure you understand it. We may do a little bit of experimentation. If I get asked a question along the way about one of these tasks that we're doing, I can maybe do a little bit of experimentation and stuff. But other than that, it's like as soon as it's done, we move on to the next. To run the code in this book, you should have installed Xcode 13. Yes. If I didn't have Xcode 13 installed, this challenge would be a failure immediately because it takes about a day to install it anyway. So it's free, includes everything you need to follow along. Good. We'll be using Swift Playgrounds for all the code in this book. I think what he's saying is all the code in the Swift book, not the SwiftUI parts for 100 days of SwiftUI. So this is the first section, which I've already created one here, right? Playgrounds like little sandboxes where you can try out Swift code easily, seeing the result of your work side by side with the code. Yeah, cool. The first time you run, okay, so let's just set this up and just run this so we get the compiler working. Let me just pull that in just a little bit. Cool. Okay, it's all awake, ready to go. Next screen, we've got how to create variables and constants. Also, usually I stream both YouTube and Twitch. This is just on YouTube today. I didn't really want to deal with the complications of making that all happen, and I found that the software I was using, because I was using the free version of it, it was like lower quality. So I want this to, be done properly, this one. Okay, whenever you build programs, we're gonna have to skip a lot of text. Oh gosh, all right, let's do this. Whenever you build programs, you're going to want to store some data. Maybe it's the username they typed in, maybe it's some news stories you download from the internet, or maybe the result of a complex calculation you just performed. Swift gives us 2 ways of storing data. Depending on whether you want the data to change over time, the option is automatically used whenever you create a new playground because it will contain this line. Yes, hello playground. That's what we've got. Greeting. This creates a new variable called greeting. Because it's a variable, its value can vary. Yeah, cool. It can change as our program runs. Yeah, that's the var keyword, right? Let's keep going. Okay, let's mess around with it. When you make a variable, you can change it over time. Excellent. So instead of greeting, let's go name and Ted. Great. And looks like name. We're not creating it again. We're reassigning it to something else. And name. Whoops. Ooh. Here we go. Better spell it correctly. And we do a run. Cool, and they show up in the right panel here. So this is how we can check our work. All right, this creates a new variable called name and gives us the value Ted. Then we can change it twice. Yes, cool. Now, if we use a let instead, character, and we call it Daphne. Cool. Now we use let. Excellent, which is value that can't change. Swift literally won't let us, and it will show a big error if we try. Okay, so if we could try going character equals Eloise, character equals. All right, let's run that. Oh no, we get errors, obviously, because this is a let. And you can actually go say fix, and it'll change that to a var for us, and then this will work, which is kind of cool. The Xcode has that little thing built in. Okay, again, there are no let keywords in those second and third lines. Yep. Cool, we can do some printing now. Player name. Roy. Cool. Print player name. Why is there got to be 3 of them? Cool, let's run. Yeah, we've managed to change them, and yeah, they print out the name. Okay, cool. So when you're learning Swift, you can ask Xcode to print out any value, the value of any variable. You can also print out the values of basically anything. They don't have to just be variables. You won't use this much in real apps because users can't see what's printed, but it's really helpful as a simple way to seeing what's inside your data. Great. For example, we can print out the value of the variable each time it's set. Try entering. Yep. You can run code in your Code Playground. Yes. You might have noticed that I name a variable player name and not player name or player underscore name or some other alternative. There is a choice. This is a choice. Swift doesn't really care what you name your constants and variables as long as you refer to them the same way everywhere. This isn't a rule. Like, as in, Xcode is not going to get upset at you if you change, like, what you call your things. If you want to use like camel case or whatever. Like when I read this, it kind of just comes across as like, well, it has to be the same throughout the entire app. No, you can make them all different. It's just annoying for other people to read your code if you're one of those sort of people that change the way you type variables and constants and stuff. Pick one and stick with it. So I can't use player name first, then player name later. See, oh, I see what he's saying. Yeah. So you can't just go like reuse the same one, right? But you can declare a new one that's different, right? And this could get annoying and confusing for sure. Anyway, let's keep going. What do we got? Although Swift doesn't care how we name our data, the naming style I'm using is a standard among Swift developers, what we call a convention. Yes, if you're curious, so it's called camel case. Yes, because the second subsequent words in the name style with a little bump. Yeah. Okay. I guess the code's there. We've got to do it. Dog bread. Yes. Oh, some of these words are things that I just never type, so it's like I'm not even. It's like Samoy. The characters in those words aren't in an order that I'm used to typing out, so a bit slower. Man, walk down. Cool, done. Let's run that. Cool. All right. Next one. Is this still day one though? Difficult to tell.
Could you try again?
Oh, quiet, Siri. Be quiet. All right. Where are we going? How to create strings. Is this? Let me take a look. Yes, this is all day one. Oh gosh. We are going, I am going to fail this big time. All right. Let's start again. Actor. So Washington, Swift strings start and end with double quotes, but when you put inside those quotes, it's down to you. You can use short pieces of alphabetic text like this. Yep, you can use punctuation, emoji, and other characters like this. Or the mimic type emoji. File name. Paris.jpg. Great. Let result equal. How do we do this again? Yes. Star. Excellent. Star. You win. Star. Now to open that, I think it's Control Command Space. Yeah. Control Command Space will open up the emoji picker. You use other double quotes inside your string as long as you're careful to put a backslash before them so that, yeah, okay. So if we go let's run this, make sure it compiles. Yep, looks good, looks good. Let's go for another one down here. Let quote equal, then he tap a sign saying we've got to escape the quotes, right? Because otherwise it'll think that we've put a stop, an end to the text, and walked away. Cool. Don't worry, if you miss off the backslash, Swift will be sure to shout loudly the code isn't quite right. Yes. Alright. There's no realistic limit to the length of these strings, meaning you could use a string to store something very long, such as works to Shakespeare. However, what you find is Swift doesn't like line breaks and strings, so this kind of code isn't allowed. Let movie day in the life of an Apple engineer. And then we've got a day in, and we hit enter Apple engineer, enter. Right, and this will not compile, right? So what we have to do is go through and new line here. This is a bit of a weird syntax for me. But it took me a little while to like kind of work out what you had to do. You had to have like these quotes, I think on a line by themselves. I don't think you could have it like, you know, let's experiment, right? Yeah. So this, it doesn't let you do that. You have to have like, and while this is super useful, I think it looks kind of ugly like that. Especially if you got like really long lines of text and a couple of paragraphs in there, you're better off just throwing it into a different file and then reading it from the file. It's cleaner anyway. These multi-line strings aren't used terribly often, yeah, but at least you can see how it's done. The triple quotes at the start and end are on their own line with your string in between. Yeah. Once first you can read the length of string by writing count after it. Cool. So if we go, oh, hang on a second, because I deleted the code up here. Cool. Scroll down. We go print. We go actor count. 17. Yeah, I think it includes spaces. Of course it would. Because actor has the text in the Washington, they'll print 17. One of each letter name plus the space in the middle. Yep. You don't need to print the length of the string directly. If you don't want to, you can assign it to another constant like this. Let name length equal actor dot count, and then we go name length. Cool. The second useful piece of functionality is uppercase. Oh yeah, let's do that. Oh, hold up. Where's result coming from? Where's result? Oh, we can't continue. That's it. We're done for the day. It's broken. I think the whole point is to just go not name length. Unless I've missed something. Oh, there's result. Okay, I'm an idiot. Okay, here we go. Let's do that. Print result uppercase. Yes. Oh, there we go. It's interesting that there's a new line there. Does it say anything about that? Yes, the open close parentheses are needed here, but aren't needed with count. Oh yeah. The reason for this will become clear as you learn. Yes, because it's a function. The last piece of helpful string functionality is called has prefix and lets us know whether a string starts with some letters. Cool. And then we'll do another one. Let's go print. Is this going to give us a boolean? Movie has prefix a day. Let's run that. True, yes. Where have we got a new line there? Oh, because oh yeah, then that makes sense because when you print to the console, it gives you a new line after. Yeah. I'm not having a very good morning. Hopefully, I get into things. File name has suffix .jpg. Still print. True. Okay, cool. Important strings are case sensitive in Swift, which means using file name has suffix JPEG return false because the letters in the string are lowercase. Yep. Strings are really powerful in Swift, and we've only really sacrificed. Okay, cool. So we've only, yeah, okay. How to store whole numbers. Let's keep going. Do we delete these? Yeah, let's delete these. Let's go up. Excellent. All right, let's scroll down here. We got let score equals 10. Cool. Making your integer work just like making a string. Use let or var depending on. Excellent. Integers can be really big, past billions, past trillions, past quadrillions, and well into quintillions, but they can be really small too. When you're writing out numbers by hand, it can be hard to see quite what's going on. For example, what number is this? Really big equal, oh gosh. 1, 2, 3, 1, 2, 3, 1, 2. Well, we don't know. Let's run these. Cool. If we're running out that by hand, we probably write, okay, yeah, 100 million. At which point it's clear that the number is 100 million. Swift has something similar. You can use underscores. Yep. So we will change our previous code to this. Yes. And let's go again. Still shows up the same result. It looks like, I think Swift ignores these. Swift doesn't actually care. Okay, let's do 1 there, 2 there. What am I doing? 2, 2. Is it the same number? Did I do it right? Yeah. Awesome. Okay, so the end result is the same. Really big gets set to an integer with a value of 100 million. Of course, you can also create integers from other integers using all kinds of arithmetic operations. Let's do that. Lower score equals score minus 2. Let highest, whoops, gotta do it properly. Score equals score plus 10, right? Let doubled score equals score times 2. Let score squared score equals score times score. Halved score equals score divided by 2. Print score. Yeah, score should still be the same, right? Yeah. 8, what do we got? Oh, it doesn't tell us what the answers are. 8, 20, 20, 100. 5. Yeah. These are all correct. Cool. Rather than making new constants each time, Swift has some special operations that adjust an integer somehow and assigns the result back to the original number. Cool. For example, this creates a counter variable to 10, then adds 5 more to it. Yep. Rather than writing counter equals counter plus 5, you can use a shorthand operator plus equals, which adds a number directly to the integer in question. Counter plus equals 5. Yes, let's run. Yay, we're up to 20 now. Oh, we got to do a print. Okay. That does exactly the same thing with just less typing. We call these compound assignment operators. I did not know that. And they come in other forms. I have immediately forgotten what these things are called. Counter times equals 2. Print counter minus equals 10. Print counter divide by equals 2. Print counter. What do we got? 40, 30. I guess that, yeah, divide by 2. Yeah, cool. Before we're done with integers, I want to mention one last thing. Like strings, integers have its music functionality attached. So we could ask whether, yeah, how long have we been at this for? Half an hour. And I'm on day 1. This isn't going to happen. So we could ask whether, okay, we need to get through. I'm going to have to change tactics at some point throughout the stream, I think. And just, I'll figure something out. I got to get through these quicker. So we could ask whether 120 is a multiple of 3 like this. Okay, cool. Yeah, let number equals 120. Print number is multiple of. I didn't know about this. I didn't know about that little function there. Oh, you can do it this way. Is multiple. I knew about this. You can do functions directly on numbers. Okay. True. Excellent. Next. Come on, let's go. When you're working with decimal numbers, yeah. Okay, I cannot stop. 0.1 plus 0.2. Print number. Run. Oh, we got a little weird 4 at the end there. Yeah, when it runs, it won't print 0.3 instead of print 0.3 That's 0.3, 15 zeros and 4. Well, like I said, it's complex. Yes. First, we floating point number. Swift considers it to be a double. That's short for double precision floating point number, which I realize is a strange name. The way of handle floating. My oven just went off. I gotta put some bread in a second. So, oh, I believe in you, lol. Hello. Yeah, thanks. Let A equal 1. Let B equal 2.0. Oh yeah, it's gonna show us an error, I think. Yeah, a binary operator plus cannot be applied to operands of type int and double. Yeah, they don't work together. Yes, we can see that B is really just integer 2 masquerading as a decimal. But Swift still won't allow that code to run. This is called type safety. Yay. Okay, so what do we do here? We gotta wrap the B in an int. Man, this is a lot of what you do when you're working with numbers is this sort of stuff. Or treat the int. Oh yeah. Okay, I guess we'll do it the other way too. I can see myself cheating at this thing later on in the day. Okay, so here we go. 3.1, let double 2 equal, oh man, 3131. Cool, let int 1 equal 3. What are we doing here? Combine that with type save. This means that once Swift has decided what data type a constant or variable holds, it must always hold that same data type. That means this code is fine. Okay. Just give me some shorter names. Why do this to me? Yes, we can change the name. Awesome. Alright, name. Oh, okay, we need to change this. Let's come up here. Go name equals 57, and we should get a compile error. Store a string. Yes, we're telling Swift to store a string, and then we change it to an integer, and it just says no, you can't do that. Okay, I think we need to delete that. Alright, what have we done here? Many older AP... Oh yeah, finally decimal numbers have the same range of operators and companion assignment operators as integers. Excellent. Many older APIs are used slightly different way of storing decimal numbers called CG float. Unfortunately, Swift lets us use regular double numbers everywhere. A CG float is expected, so although... this is like absolutely true. I remember seeing the release of this and everyone saying this is really, really good, so we can... But for some reason, in some places, I've found that that's not the case. I don't know why, because it's a Swift level thing. It shouldn't be... I've just had situations where I've like gone to try and use a double, where like pass a double to a CG float or the other way around or something, and it's just been like, nah, can't do that, and I've had to wrap it. But it should be working for everything. That's correct. Okay, let's delete. Let's keep going. We're still on day 1. Let file name. Wait. Oh, okay. This is new stuff. Jog. I don't know what file type that is. JPEG. Oh gosh. Print file name has suffix. So we had, this was earlier. So is the goal to speedrun 100 days of Swift or to streamathon until you're done? Kind of both. I don't have like a proper speedrun timer, you know, and then like each day it's this is how long it took you for this part of the level and that, not like a regular speedrun. But yeah, I'm gonna stream until I'm finished, I hope. And at this point, I did budget for 8 hours, but I think it's gonna take me up 20. Probably. What are we at? 30 minutes, right? So if we do a little calculation, and if it's this is generous. No, I did that wrong. I'm gonna waste half the day doing a simple calculation. That's 3,000 minutes, right? That's 50 hours. Okay, well, you know, we'll see. All right, here we go. Yes, great. Both has suffix and is multiple of return a new value based on their check. Either the string, yep. Make boolean is just making the other data type. It's just like making the other data type specific. Okay, so we go let good dogs equals true. Let game over equals false. I think things will get a little bit quicker once we get through all these, right? I hope. Unlike the other types of data, booleans don't have arithmetic operators such as plus and minus. After all, would true plus true equal? However, booleans do have one special operator, which means not. Okay, yeah, so we go var is authenticated equals false. Oh, come on. Is authenticated. Cool, so we just toggled is authenticated. So we go print is authenticated, and then we go is authenticated equals is authenticated print. Oh no, come on. Come on, yes. I don't know if I can have time to check my work over this. So we go var game over equals false. I think we need to get rid of that one. Just a redeclaration of that print. Game over. Yeah, so we can do a toggle here. I think that's fairly new, the toggle. I think we got that with SwiftUI. I can't remember. I think we did. True, false, true. Excellent. Next. Yeah, if you're watching this to like learn Swift, don't. Go through the thing yourself because I am like not going to be explaining much. You're just watching some dude type. That's basically it. Let's second part equal world. Let greeting equal first part plus second part. Great. We'll just put those two strings together. Oh, look at that. Hello world. All right. Let people equal haters. Oh, come on. Let action equal hate. Oh, I don't like this one. Excellent. Haters gonna hate. Yes. Big fan of Taylor Swift. Okay. And I think her lyrics make a natural fit for territorial Swift programming. Excellent. Do we have to do all these numbers? Oh, okay. All right, let's do this. Add all those numbers together. 1, 2. Oh no. 3. Can't count. Excellent. Quote. What are we doing with this quote? Then he tapped a sign saying, right, we did this before. IEBE. And walked away. Cool. Interpolation, yes. This is one of the coolest things when you're learning to program, like in Swift. This, where you can just drop these variables inside a string. Like, to me anyway, when I first started doing all this, I was like, oh, this is really, really cool. You can do that. It kind of like opens up. It's like the first time that it starts to sort of open up things for you, like programs you can write. Yeah, that's all there. You still haven't got like user import or anything like that yet, but it's kind of cool. You can do stuff with this now. Good luck on the rest of the stream. It's midnight where I am, so I'm ahead of bed. So just pop in to show support. Thank you. I'll probably be here when you wake up. So be sure to check back in and I'll say good morning to you. Landed on the moon. Okay, mission message. Oh, hold up. What have I done wrong here? Oh, okay. It's supposed to be wrong. Help if I read the supporting documentation around that. Okay, here we go. It is still... what do we got? Print. 5 by 5 is 5 times 5. Let's put some quotes around that. Let's go. Yeah. All right. Simple data. Let's do it. Scroll. No, I keep... Well, oh, is this one we don't have to write any code? Skip it. Checkpoint 1. You already know enough to start running first useful code. Yeah, that's what I said. Fairly simply, we're going to convert temperatures from Celsius to Fahrenheit. Goal is to write Swift Playground. Hold up. Swift type. Wait, have we gone past this already? Oh, okay. There is a button at the bottom that lets you go to the next day. Okay, so I have gone... Okay, hang on. Where are we at? We've got... Have we? String of... Yeah. We're up to checkpoint 1. So that's day 2. Okay, so when I add chapters to this, I'm going to have to remember to... Day 1 was a bit of a mess up. So we've got... Let me finish checkpoint 1, and then I'll set the little thing in the bottom right to day 3, okay? Okay, you got us right. A Swift Playground. That creates constant holding any temperature... Any temperature in Celsius. Okay. I don't know. Well, today's supposed to get to 37 or something, I think. Converts Fahrenheit by multiplying by 9 divided by 5. Then... That's 32. There we go. Prints the result. Okay. Print in... That means in Fahrenheit, okay? In F. I'm trying to... Yeah, okay, we got it. You already know everything you need to solve the problem, but if you like some hints. How to store order. Okay, hang on. Let me go back to my little text thing. We're up to day 3, okay? We did day 2. We just, how to store ordered data in arrays. Okay, cool. All right, let's start with some simple examples of creating arrays. Hi, how long you already write code with Swift? Oh, you mean today? 40 minutes in my lifetime since Swift was released. Before that, I was an Objective-C developer. Oh, I do have to put something in the oven before we do much more. Okay, so I'm gonna have to pause for a second. I'll get through this one first, and then I'll just run. It'll only take me like, I don't know, 30 seconds. Because I got made some bread last night and it needs to be baked. 4, 8, 15, 16, 23, 42. Temperatures. 0.3, 28.2, 26.4. All right, what am I doing with these? These are just, this is just an example, right? They're just showing us. Yeah, what an array is. When it comes to reading values out from an array, we ask for values by the position they appear in the array. Position of an item in an array is commonly called its index. Excellent. So we can go print Beatles 0. Print numbers. Whoops, 1, and print temperatures 2. All right. Oh yeah, that works. Yep. First, 1 should be 8. 2 should be 26.4. Yeah. Make sure an item exists at the index you're asking for, otherwise your code will crash. Your app will just stop working. If your array is variable, you can modify it after creating it. For example, you can use append. Yeah. What am I doing there? Beatles append. That's not a beetle. There he is on the end there. Append. You can also do insert and stuff, so you can add it like at a particular position. Nothing stopping you from adding more items more than once. Oh gosh. All right. Alan. We're doing Adrian again, are we? I'll have to watch this stream back, but just want to say congrats on 1K subs and hope you have a good stream. Oh, thank you so much. Thank you so much. I'll be here when you come back probably, so yeah. If you come back. Yeah, thank you. Thanks for the support. This all looks good. I think we've done well with that. So let's go temperatures. Chris. Oh yeah, this is gonna be like, hey, hang on, you can't do that. No exact matches to call matches in call to instant method append. What's really cool is that this error is kind of like different. You know when we tried to do like a string and a integer and it was just like, oh no, the types don't match, you can't make that work. This is like no exact matches in the call, so that means there's no function that accepts a string on an array of integers. So what this means is you could make an extension for, I know anyone new watching this is going to be confused by it. Anyone who's been around for a while will know what I'm talking about. If you can create an extension on a collection, array, or sequence or something like that that contains integers, and you could have it so that you pass in a string, and that's allowed. But obviously you won't be able to put the string into the array unless you did like a returned like a mixed type array or something. So this is possible if you create an extension on it, which is kind of cool. That's the cool thing about programming in general and stuff like that. And depending on the language you're working with, you can change it to do the things you want it to do. Okay, this applies to reading data out of the array. Swift knows that the Beatles array contains strings. And what I mean by that is like just going back on it real quick. If you create an array of type any. Like I think we can get away with what have we got? Temperatures. So you don't even need to do an extension, I don't think. I think this should work. Yeah, so we can just add we can add the string in there now because we have an array of type any. I wonder if he'll go into... Let's not go too far. I'll lose my spot. Yeah, that's kind of cool, right? Okay, so this is an error type, so let's delete that. We can't continue if that's still there. Let first beetle equal... This is a long one. Just scrolling down that page, I'm just a little bit worried. First number equals numbers 0. Yep. Let not allowed equal first beetle plus first number. This is definitely not allowed. But like I said, you could create your own little plus. What is it called? Operator overload, operator, something like that. You can create your own plus that allows you to add numbers and strings and stuff like that together. Yeah, so this is an error. This is type safety. Just like how Swift won't let us mix integers and decimals, except it's taken to a deeper level. Yes, all beetles and numbers are both arrays, but they are specialized types of arrays. One is an array of strings, and one is an array of integers. Yeah, Swift knows that this value here is going to be a string, and this value here is going to be like an integer, because they came from that array, which is really, really clever. You can see this more clearly when you want to start with an empty array and add items to it one by one. This is done with very precise syntax. Oh, we better delete that. Var scores equals array int. You know what's funny? Like there's this way of doing it. I'm not. I think I'm a fairly experienced developer, right? But I don't know really what the difference is between this or having. Maybe there is no difference between them, right? Maybe this is a preference thing. I know that like code completion and stuff in Swift prefers this sort of syntax. When it like suggests you to add things, it's like, here, do this. Don't do the... we got 100. Let's keep going. I gotta stopping and talking. Gotta stop stopping. 85. Come on. Print scores 1. Let's go. Yeah, cool. So we start out with an empty array and we can add stuff to it later, but we have to define what that array is at the beginning, right? If you have to. You can't just experimentation, right? It says empty collection literal requires an explicit type, so you have to tell it what's going to be in there. You can do it this way too, like this is what I meant before, not this one, because this doesn't declare it. That it gives it its type, but it doesn't create an instance of it. Sorry. This instantiates it. Anything on the right side of that equals. Anything over here does not. It just tells you what type it is. Okay, so yeah, so this will be an empty array of integers. Excuse me. Okay, so we've covered the last 4 lines already, but that last line shows we have specialized array type. Yes, this is just any array. It's an array that holds integers. Great. This is what allows Swift to know for sure that beetle 0 must always be a string. Yeah, okay. Let's keep going. Albums. Array. So we're doing the same thing, but with the array of strings. You can also have an array of your own types too. You don't have to... It's all the same. Fearless. Cool. Arrays are so common in Swift that there's a special way to create them rather than writing. You can instead write, oh, there we go. That's what I was talking about. I feel like this would have been just jump straight to this rather than talk about the other ways of doing it. I don't know. Just seems simpler. Can we just not? Is that cheating? Same outcome, right? Swift's type safety means that it must always know what type of data array is storing. That might mean being explicit by saying albums and array string. But if you provide some initial values, Swift can figure out for itself. Great. So we can just grab this here. and throw that in there, and then I think that's it. Yes. Excellent. Before we're done, I want to mention some useful functionality that comes with arrays. First, you can use .count to read how many. Okay, let's do that. And this works on strings too, because strings are arrays, right? Well, they were. And then they got changed to whatever. Second, you can remove items from an array by using either remove at or remove one item specific index, or remove all to remove everything. Oh, okay, here we go. Characters. Who's in here? Sterling, right here. Print. Characters. Count. Let's just give that a little bit of a run. Yep, 4. Yeah, I count 4. Characters. Remove at 2. And we're doing a little print, and we go characters.count. Should have 3. Yep, we do. Characters. Remove all. Print characters count, and we should have 0. Okay, that will print 4, then 3, then 0 as characters are removed. Yep. You can check back 430. Yeah. Okay, we see what if something is in an array, we can do the contains function. You can do this manually as well, just by looping over it. This makes it so much easier. And I think there's some, like using this contains, I think there might be some sort of secrets in there too, rather than just using, like, because you could do it manually with a loop, right? But I think some of these functions give you some extra performance improvements and stuff, depending on, like, I think it determines, like, if the array is really big, it'll use a different search algorithm than if it was like a smaller one or something. I don't know. I'm probably making stuff up there, but from what I remember, when it comes to like the sort algorithms in Swift, I'm pretty sure it uses a different one depending on, like, it's smart about which one to use, I think. It is not a, yeah, false. We got false. Okay, fourth, you can sort an array using sorted. Cities sorted. Look at that. Let's do it. Run that. What do we got? Sorted by. That looks alphabetical to me. Okay. Okay. Returns a new array with the items listed in sorted in ascending order. Yeah. So you get like a whole new array out of this, right? I don't think. Let's just quickly check this out, right? So we print cities just on its own without sorted, and then it has the original ordering from before, yeah? So this doesn't sort this array, because it's a let anyway, right? So this, calling sorted on it doesn't change this order. It gives you a new array with the new order. I think there is a way to sort in place in Swift, but yeah. So we've got let presidents equal Bush, Obama, Trump, Biden, assuming that's all that's there. Yep, cool. Reverse presidents. And we take a look here. We've got, oh my gosh. Bush, Obama, Trump, Biden. It doesn't actually do the work of rearranging all the items, but instead just remembers to itself that you want the items to be reversed. So when you print out reverse presents, don't be surprised to see that it's just a simple array anymore. Yeah. Arrays are extremely common in Swift, and you have lots of... Yeah, we got like reversed collection, which is a different type altogether, I guess. Bush, Obama, Trump, Biden. Bush, Obama, Trump, Biden. It's a bit weird how they're not... They're in this, like, they're in the same order, but I think they'll I don't know. It's a bit weird, isn't it? It should be reversed. Huh. Okay, let's keep going. How to store, find data in dictionaries. All right, let's just double check and make sure, like, this could be day 4, right? Raise dictionaries. Oh my gosh. Okay. No, it's not. It's still day 3. Oh, this isn't good. All right, I'll be back in 1 second. How do I do this? Snack time. Yeah. Okay, hang on. I'm not going to turn my mic off, but I'll be back in a second. I just got to throw some bread in the oven. It'll take me, what, a minute. Don't go anywhere. Okay, I'm back. Right. 30 minutes, I'll have to go back out. So, it's all good. Let's keep going. Var employee. Cool. Okay, I've told you that data is about an employee, so you might be able to guess what the various parts do. Yeah, so let's print. Whew, name. I noticed that the checkpoint was really quick, so if I can get through the checkpoints faster, we may, like, I don't know. We'll see how complex these get. Like I said, I haven't done 100 days of Swift or 100 days of SwiftUI before, so I don't know what's coming up. Some of you may know, and they're just sort of waiting for me to realize how bad this is going to be. I mean, if you like that sort of entertainment, then sure. Here we go. Yeah. Oh. Everyone else saw that but me. Okay, so yeah, let's rerun. Taylor Swift, singer, Nashville. Yeah, cool. Alright, yeah, but that has a couple of problems. First, you can't really be sure that employee 2 has their location. Maybe that's their password. Second, there's no guarantee that item 2 is even there, particularly because we made the array a variable. Yes. So we need to set like titles and keys on these things, right? So what do we got? So we just go on the same thing. We just go employee, move at 1. And I think we're going to have a problem here, aren't we? Yeah, we're going to error. Yes, that now prints Nashville as the job title, which is wrong, and will cause our code to crash when it reads employee 2, which is just bad. Cool. So let's, I think we can delete this safely. It's not going to get us to employee 2. Name. Taylor Swift. Excellent. what do we call it? Job? Job. I don't think she's not just a singer. Singer-songwriter. Okay. Potentially a business owner, right? Okay, so we've got job, singer, locate. Yeah, so these are, I think we'll have these in different order every time almost. Yeah, cool. Okay, we split that into individual lines. We get a better idea of what the code does. Oh yeah, I usually do this anyway because it can be difficult to read if they're in a big list, in a long string like that. Okay, so as you can see, we're now being really clear. The name is Taylor Swift, the job is singer, and then, yep. So if we go print again and we go employee 2, and we can, instead of going by the index, we go by its key. Print employee 2, and then we go location. Okay. We should get, yep, Taylor Swift singer Nashville. Excellent. Yeah, that's fine. If you try that in the playground, you see the Xcode throws up various warnings on the lines of expression implicitly coerced from a string to any. Worse, if you look at the output, yeah, you got these optionals in there that get thrown in. If you've ever seen an app, you've downloaded an app and then you've seen like this text in the in the UI or anything like that, this optional stuff, we're about to explain why. Well, think about this, right? All of that is valid Swift code, but we're trying to read a dictionary keys that don't have a value attached to them. Yes, sure, Swift could just crash here, just like it will crash if you read an array index that doesn't exist, but that would make it very hard to work with. At least if you have an array with 10 items, you know it's safe to read indices 0 through 9. Indices, just plural form of index, in case you weren't sure. Cool. So Swift provides an alternative. When you access data inside dictionary, it will tell us you might get a value back, but you might get back nothing at all. Swift calls these optionals because the existence of data is optional. It might be there, it might not be. Yeah, so like optional is like a different type on its own, right? So optional is it an enum? I can't remember. But it's a type, and it will contain a value or it won't contain a value, and that's why we get this wrapped around it, because we're not actually getting the string, right? We're not printing the string, we're printing the optional. Swift will even warn you that when you write the code, yeah, expression implicitly coerced from string to any. But it will really mean that this data might not actually be there. Are you sure you want to print it? Yes. Okay, so optional is a pretty complex issue that we'll be covering detail later on, but for now I'll show a simple approach. When reading from dictionary, you can provide a default value to use if the key doesn't exist. This is something that I did not know, which is cool. I guess this is one good way of getting rid of the optional. Or you can unwrap it, but I'm assuming we're going to get that to that stage soon. Isn't unknown such a weird word? It's got like NKN next to each other. I don't know. It's not something I've ever noticed. How would you pronounce that as a non-English speaker, I guess? I don't know. Has graduated. Yes, we are moving on. Eric. False. Maeve. True. Otis. False. Okay, we put a little comma at the end there too. Okay, yeah, so all examples use strings for both keys and values, but you can use other data types for either of them. For example, we could track the students graduating, yeah, or we could track years when Olympics took place along with their locations. Cool. Let Olympics. Got. Yeah, you can use integers as keys. I think you can use any type as a key, I think, as long as it's hashable, right? Someone correct me if I'm wrong on that one. At least with Swift dictionaries. I think if you create your very own dictionary, you can probably do whatever you wanted with it. Tokyo. That's all good? Yes. Print. We can do a little print down here. Print Olympics 2012 default unknown. Okay. What do we got here? London. Excellent. Let's have a little play around. Let's go, I don't know, 2013, right? No Olympics that year. We get unknown. Yeah, because I couldn't find one in this dictionary. Okay, heights. String, int. Now we're setting the actual types for this. Which means I think when we go on to doing a print, we should not have the optional anymore, I don't think, because what you could do is you could throw this in as being an optional and then you'd still get the same result we did earlier. But I think like saying that has to be value there, we might be okay. Let's find out together. Man, these names, he's making me type out. 2216. I've got to practice typing. Okay, yeah, notice how we need to write that. Yep. Now, to mean a dictionary with strings for its keys and integers for its values, because each dictionary item must exist one specific key. Dictionaries don't allow duplicate keys to exist. Instead, if you set a value for a key that exists, if I write whatever, yeah. Okay, let's keep going. I'll do a run. Yep, cool. Enemies. It's very like inspiring going through this sort of stuff. Just, I don't know, there's something about just the content that we're doing, like arch enemies, we got heights and stuff. It just makes you think of the kind of apps you could build. Like imagine like a cool comic book app or something where you have like profiles of all these guys. So what are we doing here? Oh yeah, strings. We got string one going on. Okay, so if your friend disagrees that Joker is Batman's arch enemy, you can just rewrite the value by. And this would be incorrect, obviously. Joker is the number one. Penguin. All right. How to use sets for fast lookup? Okay, what are we up to now? Sets and enums. Oh man, day 3 is massive. Where are we at? We're an hour in and we're up to day 3. We're hour 10 up to day 3. We almost finished day 3, so that's giving us like a third of an hour for each. Oh man, yeah. We got a long way to go. Use sets for fast data lookup. Yes. Okay, let people equals set. It's interesting we're using sets already. I guess like it makes sense to bundle it in with all the other collections and stuff. I guess my point with it was just that they're a little bit more, I don't know. They're still used a lot, obviously, but I think when you're just starting out, I would argue like maybe introduce them a little bit later. I don't know. Cut back on the confusion a little bit. Notice how that actually creates an array first, then puts that array into a set. Oh yes, I noticed that. Yeah. That's intentional, and it's the standard way of creating a set from fixed data. Remember, the set will automatically remove any duplicate values, and it won't remember the exact order that it was used in the array. If you're curious how the set has ordered the data, just try printing it out. You might see the names in the original order, but you might also get completely different. Yeah, so if we do a little run through, it's just, it jumbles them up. It's different every time. They're kind of like a dictionary, I guess, in a way. You might see the names in the original order, but you might also the second important difference when adding items to a set is visible. You can add the items individually. Here's the code. People. Oh, okay. So we just, you know what? We'll just change. We're doing the exact same thing. So yeah. And this time I think it looks like we're changing. We'd have to change to a var. So we've got string people insert. And it's not append because there's no particular order, so we just say insert. People insert. Do you know what'd be really cool is if it threw in the quotes automatically. It's like, well, this is a string, so you're gonna want quotes. Although maybe not, because you'll be passing through could be passing in a variable. Okay, yes, inserted, true. These all worked. There we go. Cool. Using insert, we added items by calling append, but that name doesn't make sense here. Yes, yeah, when we had an array, we added items calling append. Yeah, cool. Okay, next. An enum, short for enumeration, yes. Okay, var selected equals Monday. Later on in your code, you can change it like so. Yeah, selected equals Tuesday. Excellent. We know all this. Well, what might work well in very simple programs? Take a look at this code. Yes. Take a look at it. We get a real close look at it. We'll have to type it out. January. Yeah, that's not going to work. It's not a day of the week. Oops, you accidentally typed in a month rather than a day. What will your code do? Well, you might be lucky enough to have a colleague spot the error as a review code, but how about this? Oh no. There's a space. All right, so we could rewrite our weekday into a new enum like this. Let's rewrite. Enum weekday Monday. I'll do it as it's typed. Tuesday, Wednesday, Thursday, Friday. Cool. This calls new enum weekday and provides 5 cases to handle 5 weekdays. Cool. Now we can go var day equals weekday Monday, and then we can go day equals I'll do it properly. Because I have a guess that it's going to tell us. He's going to tell us that we can omit these. Okay. Let's go print. Well, run Monday, Tuesday, Friday. Yeah, cool. Okay, excellent. With that exchange, you can't accidentally use Friday. Yep. Swift offers possible solution. We type weekday dot because it knows you're going to select one. Swift does 2 things that make enums a little easier to use. First, when you have many cases in enum, you can write case once and then separate each with a comma. Let's do that. Oops. That works okay up to an extent, right? Otherwise, if you get too many in there, if you got to scroll. Okay, and then here we can do the same thing, right? We just delete these. Not the same thing, but clean things up. Okay, cool. How to use type annotations. Where are we at? Type annotations, day 4. Okay, cool. We're up to day 4. And checkpoint 2. Excellent. Oh, okay. Sorry. All right. Here we go. So far, we've been making constants variables like this. Surname equal lasso. Var score equal 0. Yes. Type inference. Swift infers that surname is a string because, yep, they're signing next to a type annotation list. Be explicit about what data types we want and look like this. This also speeds things up a little bit in the compiler too. I don't know if it changes things at runtime. Probably not. But these get applied anyway. Behind the scenes, it can take Swift a little while to work out what you're talking about if you don't have this on there. And sometimes if you've got like really slow compile times, throwing these in can help with that. I don't think it's as much of a problem now as it used to be. It used to be pretty bad. They've gotten, they made improvements. For example, maybe score is decimal because the user can get half points. Oh yeah, okay. Fair enough. Without the double part, Swift will infer to be an integer, yes. We've looked at a few types of data so far. It's important that you know the name so you can use the right type of annotation when needed. String holds text. Alright, here we go. Oh, come on. String. Great. Lucky number. Int. Okay. Let pi double equal 3.14 1 5 6 5. Is that right? You could also just go pi. Oh, here we go. Var is authenticated. Cool. Equals true. Cool. Let's just do a little run so we can see all these. Yeah, 3.15. Oh, I was wrong. Wait, 3.141592. There we go. 6.5. That's the 6.5 I was looking for. 141592. Okay. Okay, anyway, let's keep going. Albums. There's some weird, not weird, I guess. The fact, like with pi, this is a tangent. You only need like 5 or 6 decimal places or something for most calculations. I don't know what number it is, but it's like somewhere around. You get to around here, and you can like measure the circumference of the Earth or something to the nearest inch or something. Once you just get to here, and the universe is like, I don't know, 15 decimal places or something. It's like really close. Anyway, you don't need millions of those decimal places to do really accurate calculations. Oh, okay, so we got red, fearless, yes. Array holds lots of different values, yes. So we set it up as album. Oh yeah, okay, we got it. Okay, so we go var user. Yeah, it takes me a little bit to get back on track if I get distracted with my own thoughts. ID 2 straws. 2 straws. Cool. Let's do a little. What have we done? Oh, okay. Incorrect. It's the dictionary. We gotta put the little colon. Yep, that's working well. Set holds lots of different values. Yes. We set this up. I think this is the only place where you have to use this kind of notation with these little arrows when it comes to a set. Like you have to use that. Everything else has its own. So like square. The set uses these. And then over this side, do you have to do it this way? Let's do a little experiment in this case as well, right? So I'll show you what I'm getting at in a second. Lowest I. We got foundation. Okay, so we run that. Good. Can we get away with just doing this, I wonder? Yes, we can. We don't have to have set. That's why, yeah. Once you've declared it here, you can use like the regular array sort of syntax there. String. What are we doing here? Coke. Pepsi. Okay, what do we, knowing all these types is important. For example, this creates an array of strings. Okay, yep. Type annotation isn't needed there because Swift can see you're assigning an array of strings. However, if you wanted to create an empty array of strings, you need to know the type. Yeah. It says some people prefer to use type annotation than assign an empty array like this. Yes, so we can go like that. Ah, cool. That's for cities, and then we can change to clues. Then we can go, we can remove this and just go string. There's various ways of doing it, right? Okay, in UI style, light, dark, system. Cool, and we go var style equals UI style light. Swift to remove the anonymous name for future assignments. So we can write style equals dark. It knows any new value for style must be, yeah. So what it's saying is you can go like style equals dot dark. Okay, here we go. Let username string username. Do I have to type? Lots of complex logic. Let's do it properly. Lots more complex logic. Print username. Oh, this is for, what are we doing? You see, Swift is really clever. You can create a constant that doesn't have a value just yet. Later on, provide that value. Yeah. Sometimes this means doing something similar. Double. Okay. The code is legal, saying username will contain a string at some point. Provide username. Kind of code requires a type annotation because without initial value. Yeah. Oh yeah. So up until this point, we've been putting the assignment on the same line as the creation, right? This is different. Swift will give you an error if you don't end up doing this at all in your code. I think if you just go, yeah, so constant username used before being initialized. There is no initialization. You're just doing like a little declaration thing there. It needs to be initialized. So the compiler's smart enough to know that you haven't actually set anything up yet. If instead you were to make it optional, I don't think we've gotten optionals yet. No. It will be constant username used before being initialized. I think you still need to initialize it. You'd have to set it to nil. Yeah. Okay. But yeah, it's smart enough to know whether you've put a value there or not. And so sometimes you might have like if thing, you want to set it to this, right? Else you'll set it to, yeah, and then it's still if true. Let's just go if true. And this is fine too because the compiler's smart enough to know, like, yeah, it even says like this will never be executed. It knows that you've got like this if statement there, and at some point this is going to be set, right? Which is kind of cool. All right, what do we got down here? Regardless of whether you use type inference or type annotation, there is one golden rule. Swift must at all times know what data types your constants and variables contain. This is the core of being a type-safe language and stops us doing nonsense things like 5+ true or similar. Okay, for example, this is not allowed. Let score int equals 0. All right. Unlike JavaScript, where you can get away with this sort of thing. Redeclaration of, yeah, okay, cool, excellent. What do we got? Summary, complex data. Where are we at here? Still doing this, I guess. Still day 4. Okay, we've gone beyond simple data types now and started looking at ways to group them together and even create our own using enum. So let's recap. Arrays let us store lots of values in one place and then read them out. Okay. Oh, okay, we can't do it. We can't do that. I gotta keep going. Okay, so what's this? I'll provide some hints below. Okay, so what do we need to do? Still here. Okay, no hints, no hints. Now that you've met arrays dictionary sets, I want to pause for a moment and give you a chance to solve a small coding challenge. It's not designed to trip you up, instead encourage you to stop for a while and think about what you've learned. This time the challenge is to create an array of strings and then write some code that prints the number of items in the array and also the number of unique items in the array. Oh, okay, cool. So, hello, this is an array of strings. We need to put a duplicate in there so we can make this work, right? Let's just go with hello again. So we got hello in there twice. And so what we need to do is, what does it say? Print strings dot count, and that gives us 8 values. And then if we go print set, and we go strings, and we print the count of items in the set, we should get 7. Yeah, okay, so yeah, when you create a set, add this array with the duplicates into the set, it strips out the duplicates and we've got 1 less because we have hello twice. Yay, are we done? Oh, I think we're done. Check if the condition is true or false. If switch ternary operator. Okay, we're up to day 5. Okie dokie. Oh man, alright, here we go. Let me just, day 5, 95 more to go. 95 more to go, and we're 5% in, and nearly what, a quarter of the way through the day. This isn't gonna happen. If statements, which let's check run code, if they look like this. Yeah, cool. I don't think we have to type this because we haven't been given what some condition is, right? So the condition starts with if, which signals Swift. Yeah, we know. I know how to do this. Okay, if some condition. Okay, oh, you know what? Let's do it. Let's go. Let's say let some condition equals true, right? And then I'll go if some condition print do, because it's true, we're going to print do something. If we set this to false, we get nothing. Cool. Everyone happy with that? Is that good enough to complete this? I think so. Little symbols called braces. Yes, if some condition, let's go say do something. Let's fix that. Print do something else. Print do a third thing. Cool. Print out. Cool. Let's score. Let's do this. Let score equals 85. If score is larger than 80. We haven't even done these yet, have we? I guess we're doing them now. Great job. Print. Excellent. Yes, this value is larger than this one, and that's how we get that. Okay, let's try this out. Let speed equal 88. Let percentage equal 85. Let age equal 18. If speed is larger than or equal to 88. Print where we're going, we don't need roads. You know what's funny? Like when this sentence starts, I don't think of Back to the Future. I think of Event Horizon. Where we're going, we don't need eyes. Can't believe I watched that movie as a kid. It's terrifying. You failed the test. Okay. If age is larger than or equal to 18, print you're eligible L. Vote. Alright. Sorry, oh, what do we got? Less than 85. Okay. So we've got these two have printed out. This one not. If we set, I think if we set this to equals, we'll get it out. Yeah, cool. And I think that's the purpose of this, right? Let's keep going. I gotta keep going. I can't keep reading everything. Our name. If our name is wrong way, friend name. Oh, how does this work? You can do a comparison here. Well, let's try to say, okay, maybe I will read this. If the user entered a name that comes after their friend's name alphabetically. Oh, yeah, that makes sense. It's alphabetical. Print. It's our name versus friend name. Okay. Well, there goes the oven. I need to run out and remove the bread from the pot that's in there. Our name is larger than friend name. Print its friend name versus our name. Okay, let's run that. What do we get? What do we get? Okay, so the first one doesn't go through. This one does. So what we're doing is just swapping these around, I guess. Yeah, Arnold is going to come before Dave in the alphabet. Okay, so let's keep going. How many more? I'll be back in a second. Don't go anywhere. Just one sec. Okay. Oh gosh. All right. Another 20 minutes or so. I gotta go back out and it's all done. Okay. Oh gosh. Just checking some notifications. All right. Excuse me. Okay. Where are we at? Numbers. Numbers. 1, 2, 3. Good. 3. Numbers. Append. 4. Right. If numbers count is larger than 3. Numbers remove 0. Print numbers. Let's print them up here as well, so we can see the before and after. Right, 1 2 3 4, 2 3 4. Cool, because we removed the item at the first index. Cool. Keep going. Let country Canada. If country equals Australia. Ooh, that's where I'm from. Print. Good day. Most people don't say that. I think if you're like over 50, that's the thing that people say. I don't say good day. I don't even say mate. It feels weird. Maybe that's the American influence. I think towards the end of the day, I'm going to be mistyping a lot. Okay, well, yeah, if it does not equal anonymous, if it does equal, so these are two different little little comparator things we can use. Okay, I think we can also use, we'll say up here, just is equal to, where would you say that? Is not equal to. So you can do things like, am I thinking of a different, I'm thinking about tests, XC tests and stuff. Don't worry. Okay, so we've done that. Let's keep going. Var username Taylor Swift 13. If username is equal to, oh, if it's empty, is he going to show us that though? Is empty? Because that's something we can do. Moose. Oh gosh. We need to mix this up a bit. These if else and stuff like that is starting to have me make mistakes. Yep, so this doesn't happen because it's not set to nothing. You can also do is empty. And that'll do a nice little check as well for you. This is really great if because a lot of people will do like count, if count is larger than 0 to see if there's anything actually in there. And I think this is not as performant as asking is empty. I think this will actually like count the number of items in the array or in the string. I don't think it keeps track of how many there are at all times. I'm not sure, but I've from what I've heard and what I've read, don't use count if you're checking for 0. You just use is empty. Okay, that is an empty string. We'll start by yeah. Cool. Okay, username dot count is equal to 0. He's gonna say yeah, it's empty down here. Yeah, cool. All right. Username is equal to anonymous, which doesn't run obviously. And then we can do the same thing here. We just go is empty. And this will not run either. Oh, is empty equals true. We can do it that way, I guess. And then we can delete it. Then we can delete it. Okay, cool. Okay, we're done. How to check multiple conditions. Where are we at? Switch and ternary operators. We are still on day 5. Yes. Okay. All right. Let's delete. Let's keep going. Let age equals 16 if age is larger than or equal to 18. Print you can vote in the next election. Ooh, I don't know about. Oh yeah, that is correct. If age is less than 18, print sorry, you're too young to vote. Okay, here we go. We're gonna just reuse what we've got, right? So yeah, we can do an else here. So we've got the same code there, and then we can delete this and it will have the same output. Cool. And if we set this to 18, this one runs. Excellent. Okay, now SwiftUI needs to check age once. It's greater than or equal to yes. If some condition, this will be run. This is an example. I'm not going to type this out. There's an even more advanced condition called else if, which will let you set a new check. Yeah, cool. So I think it's safe to delete this. In the previous examples, I tried deleting it and I had to rewrite it again. I think we're okay. We moved on. Cool. It's true if a print code to run if A is true, else if B. Print code to run if A is false but B is true. I'm assuming that's what it says. Else print code to run if both A and B are false. Yeah. I think we get this one. Yes. Cool. Keep going. Let's go. Let temp equal 25 if temp is larger than 20. If temp is less than 30. I think we can do a range for this kind of thing, and I think that's where this is headed. It's a nice day. Cool. Oh yeah, here we go. So what we can do is rewrite this. We can go if temp is larger than 20 and temp is less than 30, print it's a nice day. Yeah. I'm assuming this is Celsius. Yeah, and has a counterpart that has two pipe symbols. Yeah. Anytime I do this, I kind of think of like logic gates and stuff, and or that sort of stuff. 14. Let has parental consent equals true. If user age is larger than or equal to 18, has parental consent equals true. Yes. Where are we going with this? Print you can buy the game. Print you can buy the game. By the way, if anyone wants to learn more about like computers and sort of like how they work, I can recommend this book. It's just got its second edition, has just come out. And I think the first edition was written like 20 years ago. And this has come out just last year. It's called Code. It may not have heard of it. So basically, I know this is a sidetrack, but I love this book. It's so good because it starts out with like explaining stuff like circuits and Morse code and things like that. And then like, see if we can get this to... This isn't going to work, is it? Oh, you can't see that. Oh, let's go back a bit. Sorry, I bumped the microphone there. Yeah. So you see that? You can see like the circuit diagram there. So that starts out of that, and then eventually you get to stuff like like diagrams of multiple switches. You know, you turn one on, turn one off, and then the light bulb has different behavior. And then eventually you start getting into like signals. You see that? Yeah. And then you keep going and keep going, and eventually you have like over here we got RAM. It tells you, explains to you exactly how RAM works, right? And then like you could, with this book, you could make your own computer, right? So you could like get a little breadboard out and you could create like an 8-bit computer. But when you finished reading this entire thing, even tells you how to do like, it goes to the point of programming, like writing programs and storing the programs in the memory, different addresses and stuff, writing different bits. Anyway, a little side thing, but I thought it was pretty important. Awesome book. Okay, so back to it. Oh, we're getting close to my face there. Let's go back down. All right. Where are we at? User age. Yes. Okay, so here, this will print you can buy the game. Yes. Because although the first half of our condition fails, the user is not at least 18. The second half passes because they do have parental consent. Yeah. So we can go... We don't need this anymore because We don't need to, check if it's true or whatever, because it does that for us automatically. Rerun, and then we get you can buy the game. To finish up checking multiple conditions, let's try a more complex example. It combines if, else, and an or all at the same time, and even shows off how to enums fit into conditions. Alrighty, let's go back to the beginning. This one, enum transport option case airplane helicopter. Okay, someone's rich, or maybe not. Bicycle, car, scooter. Scooter. Let transport equal transport option. We got airplane. Cool. If transport equals airplane or transport equals helicopter. Any more? Nope. Print. Let's fly. Else if transport equals bicycle. Print. I hope there's a bike path. Else if transport equals car. Print. Time to get stuck in traffic. Else print. I'm going to hire a scooter now. Okay. Cool. Let's go. We've got airplane selected, so I should say let's fly. Yes, I like to pick out a few parts of the code. Oh, okay. How to use switch statements to check multiple conditions. All right. Where are we at? Still here. Still on day 5. Oh no. Okay. Oh, enum. Weather. Why are you doing this challenge? Aren't you experienced with the Swift language already? Yes. Why not? Thought it'd be interesting to see if it could be done. Is it a stupid idea? Yes, probably. And also, I guess it's also sort of like a question of why do people try and hold their breath for as long as they can, or things like that, you know? This is about an extreme of a sport I can do as a programmer. If forecast. I'll probably do more challenges like this in the future too. So like the other week we did a full app creation and submission in one day, which was kind of cool. I'd like to do that one again, but maybe with a different sort of app in mind. So that day we did we used OpenAI, so GPT-3 to build an app, a crossword solving app, cryptic crossword solving app. I think it took about 10 hours all up to build, do all the screenshots and everything, upload to the App Store, and we used some AI to help with creating the app description and things like that. I think I tried to use AI to create an app icon, and it didn't work out too well, so I had to do that manually, but anyway. Oh, and we had in-app purchases too, so I think it's called Typo Online 9. Oh, yeah. That's the one I fixed before, I think. Thanks. Generator is broken. I could blame talking the reason for the typo, but I make them all the time anyway, so what have we got wrong here? Oh, hang on. Line 9. Oh, my dog's going off. I just got to mute for a I think we might have a problem here. I've done something wrong? I think a little delay in the stream. You already need to fix the date. Okay, yeah. I think I'm having a bit of an issue here with the playground. I might have to close this and reopen. So, give me 1 second. I guess that can happen sometimes. Yeah. Okay. Cool. All right, we're back. I just had to restart Xcode. Yeah, it should be a nice day because we got it set to sun. Excellent. Oh man, that took forever. So we can replace all those if and else if checks with this. Yes, we can do all the case. Yeah, okay. So what we do is we do a switch, right? Forecast, sun. We can do all the same stuff. I wonder if I can make this quicker. Case. This is going to be probably slower than typing it all out, actually. No, I think I've got it. And unknown. Yeah, we have unknown. Case. Unknown. Realign everything. Does this look right? Let's see. What have I got? Case is already handled. Oh, I've already got rain. Hang on. Snow. There we go. Can you save this stream, please? Yeah, it'll be on YouTube. Forever. Probably. Longer than me. Okay, so what do we got? Should be a nice day. Excellent. If we change this to snow. Switch so much more nice to the eyes. Yeah, instantly better, right? Alright, let's break that down. Let's not. I'm sorry. We need to keep going. Okay. Oh, we gotta do this all over again. Alright. Oh, yeah. Okay, so you can do switches on almost anything. You don't actually need to have an enum to make that work, right? Metropolis. Yes, there we go. Place. We can go Gotham. I hope we get to do case let, if case let, and all that sort of stuff. That'd be kind of cool. I use those quite often, actually. You're Batman. You know, all this simple sort of like this starting, you know, learning Swift and all that, all these kind of examples that we're doing. I know I mentioned before, but like this is starting to make me think. I feel very much like this is a quiz, like a BuzzFeed quiz. I wonder if we get to make one of those. Default. Who are you? What do you got? Metropolis. Well, okay, I spelled something incorrect. No, this is correct. This would be what? Is this Superman? Metropolis? Am I wrong? I don't know my comic books. Here we go. Let's go again. Learning by doing. Yeah. I've already learned a couple of things that I didn't know. Like there's some a couple of methods that I haven't used before, and I've forgotten what they are. So you know, that's what happens when you try and go through it really quickly, I guess. Case 5. Yeah, you can do the same with enums. 5 golden rings. Okay, so we've got 4. You can see how I just put that dot there. I'm so used to, like, as soon as you type the word case, I'm so used to typing dot immediately after. Yep, there we go again. Three French hens, capitalized FF. 2 print 2 doves. Oh, we got default. A partridge in a pear tree. All right, let's go. 5 gold rings. We got 5 up there. Excellent. We can use fall through to get exact. Okay, so we better read this bit. That will print 5 golden rings, which isn't quite right. On day 1, only a partridge in a pear tree should be printed. On day 2, it should be 2 total doves. 5, 4, 3, 2, 5. Two total doves, a partridge in a pear tree. Okay, yeah, we can use fall through to get that exact behavior. Okay, so we get the idea. So yeah, I think we need to. These all need to be like one after the other when they're printed out, right? So if we go fall through on this, and we do a run. 5 golden rings, 4 calling birds. See how we got both of them this time? And we go fall through again. And we just keep going. This is something that I didn't know about. I'd never used it before. And I think that will come in use. Yeah. So if we set this to like 2, right, and we run it again, we should just get these last 2. 2 total doves, partridge in a pear tree. Yeah, cool. All right, next. Use the ternary condition operate. All right. Ternaries. Awesome. Let age equals 18. Let can vote equals age larger than. Oh, we're doing the voting thing again. Yes. Who else gets these mixed up, right? Like, some days I switch these, the question mark and the colon. What have I done? Oh. The oven just went off. I will be back in a second. 45 seconds or so. Don't go anywhere. Don't go anywhere. Don't go anywhere. I'm gonna mute. Okay. I'm back. Did anyone leave? No, everyone's still here. All right. That should be good for another half hour, and then I got to take the lid off the thing, then let it go crunchy with the bread, and then I've got 20 minutes after I got to take that, and then I'm done. And at some point, I'm going to have lunch, and I guess we can just sit and chat for a little bit while that's happening. It'll be like a little quick snack or something. I've got so much to get through. Okay. Let's we got yes. Yeah, let age 18, can vote, age larger than or equal to 18. Yeah, okay, that checks out. I'm not going to explain anything. Let's just keep going. Print hour less than 12. It's before noon. I'm going to shower, maybe come back, maybe go to sleep. Midnight. Oh, it's midnight for everyone almost. Gosh, I'm sure Australia. So right now it is just about almost 10 a.m. It's afternoon. So I'll probably still be here when you get back. It's afternoon. Yes, well, it's not really. It's like nighttime, but there we go. Notice how that doesn't assign the result anyway. Either the true or false case just gets printed depending on the value of hour. Yes. Or here's one that reads the count of an array as part of its condition. Let's do this. More specifically, I'm from Melbourne. Kaylee. Mal. Let crew count. Anyway, the goal is to just keep going until I pass out, or you know, whatever, or I finish. Whatever happens, we'll see what goes on. If emergency pops up, I'll probably have to run off, but that's unlikely to happen. It is a Saturday here at the moment. Names count. People. What have we got? 3 people. Oh yeah, if it's empty, there's no one. Netherlands. Oh, all right. Way north. Opposite side. Opposite side of the world. Okay. Enum theme. That's pretty cool. I love like this is just it's just awesome that this stuff exists. You know, we can share things with people across the world. Dark. Let background equal theme dark or white print background. So for this one here, we are using this little enum and we're doing a bit of a ternary on that. The equals theme equals. Yeah, usually a bit the folks find hard to read, but remember to break it down. Yeah, it is a little bit weird because we're doing an assignment here at the same time. We are assigning depending on whether the theme is equal to dark. So, okay, why is it useful when we have regular if-else conditions available? I realize it's not a great answer, but you have to trust me on this. There are sometimes people with SwiftUI when we have no choice and must use a ternary. You can see roughly what the problem is with it. Well, I'd love to see what this example is. What do we got? Let's go. I think we're safe to delete all that. 23. Print. Oh, I guess. Because I don't think you can do an if else and brackets and everything like braces and stuff inside this print. So that's probably what they're getting at. What he's getting at. I don't know. We'll see. Yeah, hang on. Invalid code. Yeah, exactly. All I needed to do was just look a little bit lower and I would have. Yeah. So you can't do this. If we wanted to write that out using if else, we'd need to write this invalid code. Yeah, so this can't be passed through into the print or run print twice like this. Yeah, we'll probably skip over this a little bit because to me this is more of an example than like you must write this code out. And this is just the stuff from what we had before, right? It's afternoon. Oh, let's just add that back in. Yeah. Everyone happy with that? Everyone okay with that? I can skip these ones. This just won't compile. And then if hour is less than 12, print is before noon else. Yeah, or run print twice like this. Yeah. I wonder if there's any other examples because yeah, there's probably more places that you can't put if. Yes. So a lot of the time I'll use a ternary if I'm passing values through to a function. So like if I've got, And I want to skip that to save time, but now I'm just adding more. All right, so some function string or something, and then I want to put something in, I want to put this in here, right? And that's sort of like my function. I might do something like this, rather than like if else and then having the same function called twice. All right, let's keep going. We've got how to use a for loop to repeat work. Oh, hang on, are we loops? Yes, day 6. All right, let's do it. Day 6. Okay, I have a feeling we're only going to get to like day 20. That's my feel on it anyway. Let platforms. We'll see how we go once we get to SwiftUI stuff. It might be quicker. We'll see. Mac OS. I might be able to make some shortcuts with SwiftUI if rather than like going through and typing each thing out line by line, what we're doing now. I'm hoping that SwiftUI will be more like, okay, today we're gonna build this view or use a VStack and put a text thing in it. And I can just do that and then move on rather than like looking back and forth between these. Yeah, because the biggest time sink here is just going back over to this view and copying it. Print. And these descriptive texts is just too much. All these print statements. Gosh, Swift works great on OS. Full stop. 4 times. Let's just drop this open. Can we see what's in there? SwiftWorks. Can we see SwiftWorks great on? It doesn't matter. It makes code more readable when using the operator when building views. For example, item, image, progress view. Yeah. Yeah, for sure. Yeah, 100% agree with that. I think it's also something we had to. So early days of SwiftUI was used a little more heavily as well. Okay, let's keep going. Let's keep going. For name in platforms, print. Oh, it's the same thing. Swift works great on name. We'll run that again. Oh, I'm so hungry. Or even this. Oh, don't make me do it again. If you do decide to go, like anyone watching decides to go along and do the 100 days of Swift UI for themselves, I do recommend like typing everything out. Just reading it and then moving on isn't sort of how it's meant to be done. Cool. And we can do this with for I in 1.12. Print 5. Oops. We got 5 times I is 5 times I. All right. 12 times. And we got a little print. Well, so they're all down here. Haven't gone anywhere. Fix that a little bit. Cool. Okay, next we've got for I in 1.12. Oh, we'll just reuse what we've got here. Print the I times table. You can build an educational app with this. 4j in 1.12. Yeah, so we got nested for loops here. I think that's what this is showing off. How many spaces? We've got a couple of spaces there, and then we've got j times I is j times I. Print. Why are we just doing a? Oh, okay. We're just printing a line, right? Yeah, cool. So we've got, 1 times 12 is 12, 2 times 12 is 24, 12 times 12 is 144. Yeah, that checks out. Shows off a couple of other new things. Let's pause a little closer. Let's not. Let's keep going. We got. Can we delete this and start again? For I in 1 5 print. Counting from 1 through 5. Print. What have I done? Whoops. Counting from 1 through 5. Yeah, 1, 2, 3, 4, 5. Cool. For I in 1. And then we don't include the last number in this one. We've got the little, this little arrow here. Counting 1 up to 5 I. Let's go. Counting 1 up to 5. 1, 2, 3, 4. Yep. Oh, through. Okay, cool. Let's keep going. Oh, we're at the end of this one. Lyric equals haters gonna 4, and then we're not assigning anything here, so we're not using the index or anything like that. So that's why we've got that underscore thing. And we go lyric plus equals hate print lyric, and what we're doing is we are making changes to this lyric variable. Previously we just print in each, in the for loop, every single time it just goes through one iteration, we do a print. Here we're adding them all up and then printing them at the end. Yeah, cool. All right, how to use a while loop to repeat work. Where are we at? Loops, still in loops, still on day 6. All right. This is intense. Countdown equals 10, while countdown is larger than 0. While loops are so dangerous, right? Like if you don't have an exit strategy for these things, they'll go forever and they'll crash your app or your device. Print countdown 1. If you got like a playground that auto runs, it can get stuck. Blast off. I think there might be a mechanism now in playgrounds that stop that though. Do we want to test it? See what happens. No, it'll just keep going. Let's start again. Okay. Oh no. Oh no, come on. Okay, cool. 10, 9, 8, 7, 6, 5, 30. 1 blast off. Yay. All right. Let's go with another example. Let ID random in 1 1000. Yes, a random number between 1 and 1000. In this case, a random decimal between 0 and 1. Oh yeah. So we can go let double dot random in 0 1, and you can also, I think you can also go double and then remove that. Oh, what have we got? Missing that there. Yeah, cool. And we just keep rerunning this code and it'll just give us something different every time. Okay, var roll. So you can make a dice app. While roll does not equal 20, null equals int dot random in 20, print I rolled a roll, print critical hit. Yeah, D&D. Gosh, anyone else been following the news about D&D lately? How disappointing. We can run this again. And yeah, we get different amount of times before it hits that 20. Excellent. Let's keep going. Let's keep going. How to skip loops, items with breaks and continues. Cool, cool, cool. Okay. For let file names me.jpg JPEG work.text I can smell toast. It's making me so hungry. For file name in file names, if file name has suffix JPEG equals false. Okay, and then we got continue. So this will just keep going through the loop. And the reason for why we want that is because if we've got like some extra code in here, like where this print statement's going now, that takes a long time to run. You kind of don't want to run that unless you found the item that you're looking for, right? Because if you're like doing something fancy down here, some complex code, it will slow down your loop. Okay, we've got found picture, yay. We find it like instantly, right? I think because it's the first one in the array. Okay, let's keep going. Let number 1 equal 4. Let number 2 equal 14. Bar multiples equals int for I in 1, 3, 100. I wonder if we get to do Fibonacci. Is multiple of number 1 and I is multiple of number 2. Is this like the fizzbang? What is it called? Fizz buzz? Is that what it is? Is that what we're doing right now? Kind of like that. Oh, almost. Multiples append I. If multiples dot count equals 10, break multiples, print multiples. 28, 56, 84. Yep. Excellent. I think that's right. I'm not going to do the math on that. Yes, next page. Conditions and loops. Oh, let's keep. Oh, okay. Wait. Maybe we should just do a quick little skim through this. If we use if statements to check conditions true, yep. You can add an else block and or multiple if else blocks to check other conditions. Cool. If one of your switch cases uses fall through, it means Swift will execute the following case afterwards. This is not used commonly. Yeah, that's like no one knows about. I didn't know about it. I didn't read enough about it either when we did it to know whether will it force it to go through the next or no. It'll do a check. It'll do a check on each one. The ternary condition operates. Let us check what true, false. Yeah. Okay, this is just a recap. Checkpoint 3. Okay, so checkpoint 3. We got day 6. We just got to finish this last checkpoint, which is going to get us to do some code, and these are usually pretty quick. Oh, fizzbars. Here we go. Okay, the problem is called fizzbars and has been used in job interviews, university entrance tests, and more as long as I can remember. Your goal is to loop through 1 through 100, and after each number, if it is multiple 3, okay, let number 1 equals 3. Let number 2 equal 5. Let... Oh man, I haven't done this in so long. For I in through 100. If if I is multiple of 3, print. No, we got to go the other way around, don't we? So like we got to go if I is multiple of is multiple of 3 and I is multiple of not 3. We could do number 1, number 2, Move this over just a little bit. Probably don't need that panel there at all. That's annoying. Okay, so it's multiple of 2. We print. There are multiple ways of solving this, okay? So don't, like, you know, in the comments or in the chat, just be like, oh, you know, you could have done it if you just like did a ternary here or that, or you could have done this in a single line. Else if I is multiple of 3, print fizz. Else if I is multiple of 5. I think this is correct, right? Buzz. People get really picky about when it comes to doing these like code golf thing. This isn't code golf. I can make this as long as I want. You know, it's my stream. But yeah, people get really like, no, it's got to be done this way. That's not the point of this. The point to get something working, right? Oh, hang on. So here's the examples you should have when your code runs. One should print 1, 2. Yeah, so else we go print I, right? I think that's what we were trying to aim for here. So if we go scroll up, 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 15 is fizz, buzz. I think I did it. Okay, where are we at? Day 7. All right. Oh, cancel. Unsaved changes. Discard. Okay, day 7. So OBS is giving me problems. Okay. Day 7. Oh my gosh. All right, functions. I feel like I'm gonna sneeze. Hang on. All right. Nope. Sort of sneezed. How to reuse code with functions. Ooh, does this work? What? This is cool. Wow. Okay, cool. All right, do we have a little button down here to go next? No, we don't. So we have to click on one of these. How to reuse code with functions. These are all optional. Should we skip the optionals? It's giving us optional things to do. Should we skip them? If I don't, I'm not going to get this done. I'm not going to get it done anyway. Oh, let's just have a look. Let's have a look at what we're dealing with here. The most common time is when you want the same function in many places. Oh, okay. So this is just how many parameters should a function accept. Yeah, let's drop this. So we'll just go through them because these are just what's the return keyword not needed. Okay, so we use a return keyword to send back values from functions in Swift. There's one specific case where it isn't needed when our function contains only a single expression. Yes, or this. Yes, cool. These lines of code get resolved with a single value. Even some longer code will resolve with a single value. For example, okay. And this line of code will resolve to a single value. I probably didn't need to type this one out, honestly. True is editing enabled, or is admin equals true. Oh, this true. Yeah, cool. That would be true because even though is owner is false, is admin is true, so the whole expression becomes true. Yeah. So lots of code we write can be resolved in a single value, but there's a lot of code that you can't be resolved in a single value. For example, what's the value here? Okay, no, that creates a constant, but it doesn't become a value in its own right. We couldn't write return let name equals otis. Similarly, we write. Oh yeah, that's true. You can't return a like an assignment thing. Like maybe. If name equals maybe, yes, hello. Similarly, write conditions like this. Yep. Can't become a single value because of the condition in there. Yeah, cool. All right, now we remember that because there's a test coming up, right? All this matters because Swift lets us skip using the return keyword when we have only one expression in our function, so these two functions do the same thing. Yeah. So this was like a fairly recent addition, I think, to Swift. It's kind of cool. That's why we've got Xcode 14.2 here rather than the 13 that was said in the very beginning of the course. Okay, if we wanted to remove the return state, okay, wait. I don't think we're going to write it. We're not going to write that out. To demonstrate this, consider the following function. Yeah, so let's do this. Greet name string, right? And then here we go, if name equals Taylor Swift, return, oh wow, I guess we're starstruck or something, is that right? Return hello name. If we wanted to remove the return statements in there, we could not write this. Yeah, that makes sense. That isn't allowed because we have actual statements in there, if and else. However, we could use the ternary operator like this. Oh yeah, cool. So we can go name equals, so this, hang on, let's just run this real quick. So this is valid code, right? Let's go with, let's call this function. All right. And you should say hello. Yeah. And then what we can do is we can change this to this code here, and we just go equals Taylor Swift, return that. And we run it again. And we don't have a return in there, that return keyword, that's gone, but everything still works. That's what that's all about. And so when the function runs effectively, it boils down to this. Yes. Okay, cool. So that, oh, well, if we add Taylor Swift in there, we'll get, oh, wow, which is exactly this. Cool. Let's keep going. How can you return two or more values from a function? Oh, okay. So what have we got here? We've got functions, parameters, and return values. If I just open up another. Throwing functions and checkpoint 4. How to return multiple values, how to customize parameter labels. I think this is all in the one day, right? Yeah. All right. Sorry, I just got confused because at the start, day 1 was like, I skipped over day 2 because of we were in the same book that had multiple days in it. Okay. Let's keep going. We've got functions, parameters, and return values. Let's jump back to this. I'll drop out of this one. Okay, so let's what have we got? Function get user. We return string, and we've got Taylor. We've got Swift, right? Cool. And if we go let user equals get user. Print user. My oven just went off again, and then I'll go and remove the thing, and then so I'm making 2 loaves of bread. Taylor. So this is correct. All right, I'll be back in a second. Just don't go anywhere. Don't go anywhere. Don't go anywhere. Okay, I'm back. I'm back. All right. I just got a message. All right, just things you got to deal with when you have life. Okay, so here we go. All right, get user string tell Swift. Yeah, we've done that. This sends back an array. Yes, it does send back an array, and then we grab the first item from that. Cool, and this is great because we can do the same thing again. User last name, and then we can go get user, and we go print user. I guess it doesn't really matter. We can just go print user one as well. So what I was trying to do there was demonstrate reusing code by using functions, but that was a bad example. Let's just keep moving on. I'm sure we'll get to that point at some, who we got? String. We got dictionary thing going on here on this next one. So we've got first, and then we've got, I think this will be last. Yes, last. First, last, user, get user, and then instead of this number, we have the word first, and that will be the key. And that works. I wonder why. Oh yeah, because there might not be a key with that value. Yeah. Okay, this solution isn't ideal. Yeah, we'll need to look at the values of strings first. Okay, so what we can do here is tuples can solve the problem by letting us be specific. So tuples are a thing that I've never really used. Hey, I've used them. I seem to only really use tuples when I'm writing bad code. I'm not saying tuples are bad code. I'm just saying whenever I'm writing bad code, trying to get something done quick, and I don't feel like creating a type. So in this case, in most cases, instead of a tuple, I would create a type, right? I would create a user, and then have the first name here. I would almost always do that. I'll use a tuple if I cannot be stuffed doing that. So let's change this code. So we've got first, let's put the parentheses there. First string, last string, and then here we go. First, Taylor, last, Swift, get user, and then we can just go first. And then I think cannot find. Oh, sorry, we've got to do these little parentheses here too. Okay, yeah, and then we don't have that weird optional thing here because we know that there's going to be a value present there. We can also set last there too. This is pretty much exactly the same as just having your own, creating your own type for it, right? Like the example I gave before. Okay. Next, what does Swift use parameter labels? Why does Swift? Many programming languages either do not use parameter labels, make them optional. Swift is unusual in that it uses them extensively, and it even lets us differentiate between external parameter names and internal parameter names. It's unusual to look at why labels are used. Consider the code like this: set reactor status true, true, false. Yes, perfectly normal code in many languages, but you will rarely, if ever, see that in Swift because we prefer to give out parameters names, so we write out a function like this. Yeah, you can remove them. I'm sure we'll get to that. Since this is kind of just like example, I think we won't write this because we're not doing anything with it, right? We're not printing anything. So set reactor status primary active true, backup active true is emergency false. Yeah, I actually prefer, this is sort of my preference, even when I'm using other programming languages that don't have this feature. It's kind of annoying because sometimes a lot of the time those other programming languages you can use them, like you generally use them like in a text editor or something like. They can be used in an IDE, right, which makes this easier. But in a text editor, you don't get documentation, so all you'll see is this, and you'll be like, okay, which one was where? And I'm just typing in the regular text editor. You don't know what they are. If you're doing, if you have these set up, it's a little bit easier to know what's supposed to be in those, especially if you're copying and pasting code, right, from somewhere online. They'll be forced to put these in, so you will know what they are for. It's like documentation in a way. As a result, Swift will require those booleans to be used when calling the function like this. Yes. And now our code becomes much clearer. We know exactly what each value does when we call the function, rather than having to remember everything, whether its emergency comes first or last. Yes, of course, Swift makes this in verb by letting us write our own labels twice like this. Yeah, I like this format of doing things as well. So let's just, since we got the print statement in there, let's go through and write this. For person string to value int, and then we do a print and we say person is now value, and of course we have to call it set age for, and see how we get like this, not this one. We can use person internally, we use for externally. Me to 100. There we go. Let's fix that typo. Now 100. Excellent. See, we can also do things like replace it with nothing, and then set age. Although in this case, I'll probably swap these two around. I'd say set age 100 to set it on like on me as the user or something. Yeah, so we've got that. We just did that. Set age person. If we had only used the person value prop labels, we have to write this instead. Yeah, so if we had just gone like this, you would have to write person there, and then you'd have to write value. We keep going, and then if we do it the other way, we have 4 and 2, set age 4, 2. Yeah, the 4 is the start of a loop. Yeah, so there's some reserved keywords that you can't use. When should you omit a parameter label? The main reason for skipping parameter labels is when your function name is a verb and the first parameter is a noun the verb is acting on. For example, greeting a person will be greet Taylor. Yeah, rather than greet person Taylor. Yeah. That's how I use it as well. I'll drop this. We still need that there, but I'll set it as that when I don't need it. It doesn't make sense to have it there. Cool. When you use default parameters for functions, where are we at? Functions, parameters, return values, default values. I think we're on day 8, right? Okay, cool. Oh, I think my music has stopped coming through. One second here. What have I done? I don't know, maybe it's working. It's just, sorry if you don't have any, put your own music on at this point, I'd say. All right, where are we at? The Swift developers use default parameters very commonly because they're less focused on the point. Yeah, cool. So let's type this one out. I think this one's important. Directions from string to string. Does this return anything? Route. Oh my gosh. Route equals fast. You can see that we're doing an assignment here. Fastest. Avoid highways. Bool equals false. Yeah, and then we can say find directions from, and then you can see that it's just automatically stripped out the ones we've preset up here. So what you would do is you'd have to hold down, it says hold down option. So you go option enter, it'll give you the entire function there. So you can come through and type all that in. I don't know why that is error type. Oh, probably because this was in the way when it tried to do its thing. Let's try again. No, it's still there. Interesting, because that's a... Hold up, what have I done here? String. That's why. Let's go again. For completion's sake. Yeah, so we got string, bool. If we don't hold down option, we just get these two because these are already preset as defaults. Cool. When to use variadic functions. Oh, variadic function. I haven't used these in a long time. Okay, so the power of variadic parameters is that we can treat them as if they weren't variadic most of the time. For example, if you had an open function that opened a file, editing preview, text edit, or whatever was the correct program, you might call it like this. Yes. And then, but the same function could take a variadic parameter. All this does is remove braces, right? Like if at the call site you've got, which is this photo.jpg, that's what this would really be. So you could just pass through an array instead of a variadic. But this just makes it a little slightly more convenient, right? And you can add or remove as many. You can have one, or you can have as many pass through as you want. Right, so by making variadic, we can open a whole range of additional functionality without having to change the way the function is called. It's really useful. Yeah, as for when you should use them, chances are you won't use them that much while you're learning because you're going to be focused on very specific problems that are usually very small, but just, yeah. You'll find that you can change your existing functions to make them variadic without breaking any of your code. You can add functionality without changing what you already have. Yeah. When should you write throwing functions? Alrighty. Oh, should we go through this? We're just getting started. We recommend you avoid using throw functions most of the time. You can handle the errors inside the function. Yeah, so when you have a throwing function when you want to put the error outside the function, right? You want the person calling the function to handle the error. But generally try and handle the error within the function, because dealing with like do catch and stuff is kind of annoying. Why does Swift make us use try before every throwing function? Which just indicates that it is a function that throws. It's for readability, I would say, right? Using Swift throwing function relies on 3 unique keywords. Do try catch. Yes, we know all 3 to be able to call a throwing function, which is unusual. Most other languages use only 2 because they don't need to write try before every throwing function. The reason for Swift is different is fairly simple. By forcing us to use try before every throwing function with explicitly acknowledging which part of a code calls. Yeah, so it's for like readability, right? So you can look at it and go, oh, this must throw. As soon as you see it at a glance, rather than holding down option and clicking and seeing, oh, this is a throwing function. And more specifically, like, you can tell which ones are throwing. You have a do catch block, right? You want to make sure that you specify which ones at a glance that another developer comes along and goes, okay, this one's throwing, this one's not. I know which ones I must still remain in here, which ones I can remove and put somewhere else. Like maybe you move this out and put it outside the block. When should you use in-out parameters? Yeah, in-out parameters. I've used these a couple of times. It's just it's similar to it will make a modification. It makes a modification to the parameter, and then it returns it through that same input, right? It doesn't return it out at the other end, like here, right? So how common are they? Well, all of Swift's operators are actually implemented as functions behind the scenes. Things like plus, minus, and so on. Yes, they're really just functions behind the scenes. You can imagine a bit like this. Yep. So when writing 5 plus 3, we're actually calling a function called plus. It takes an integer on the left, 5, and an integer on the right, 3, and returns the integer containing the result. Now think about the plus equals operator. Yes, in out. We probably won't go write this out. This is interesting. This is very, like, I feel like there could probably be more to this. Like get us to do a couple of examples, you know? so we can understand. I get why we're not, because it's just like, oh, here's an extra thing you could know about. Maybe go look it up. It's just so for completeness, but it's not something you need to know at this stage anyway. So yeah, I get the idea of just like giving a brief introduction, but not actually saying, hey, okay, let's learn this. Let's try and memorize it, and yeah. Let's go next. What the heck are closures and why? Swift, where are we at? 8 default values, throwing functions, and checkpoint 4. Throwing functions, checkpoint 4. We're almost finished day 8. This one was a little bit quicker, which is great. What the heck are closures and why does Swift love them so much? Yes. One of the most common reasons for closures in Swift is to store functionality. If you say, here's some work. Yeah, closures are great because they're functions you can pass around. That's basically what it is. It's a block of code you can save and then call it at another time, or you can pass closures into other functions. You can pass functions into other functions. Why are Swift closure parameters inside the braces? Good question. Both closures and functions can take parameters, but the way they take parameters is very different. Here's a function that accepts a string and an integer. I'm getting a headache. Pay user string amount. Yes, that's a function. And then we can. Here's exactly the same thing written as a closure. As you can see, the parameters have moved inside the braces, and in the keyword is there to mark the end of the parameter list and the start of the closure body itself. Closures take the parameters inside the brace to avoid confusing Swift. If we had written let payment equals user string amount, then it would look like we were trying to create a tuple, not a closure, which would be strange. Yeah. Cool. How do you return a value from a closure that takes no parameters? Yes, let's do this. Let payment equals user string in. We say print paying user. And then I think we should call that, right? Payment. Payment, we need to pass through an argument. So we pass through the string, which will be, let's say me. We should get paying me. Yeah, cool. Oh, let's put my name there. There we go. So it's kind of like, it's funny because we've created this and we can call it. It's just like a function, right? That's exactly what it is. It's a function. Now here's a closure that accepts one parameter and returns a boolean. Okay, so we need to return bool. Print paying user return true. And then we can say print, and this should give us true. Yeah, there we go. If you want to return a value without accepting any parameters, we can do the same thing. We just go remove this. And we don't use that. Paying a person, return true. This accepts nothing, so that won't work. Paying a person, excellent. Now we can keep going. Why would you want to use closures as parameters? Oh, big thing of text here. This is important to read, but we don't have time for that. I think basically what I'll probably say is that good luck on the challenge and greetings from Germany. Oh, hello. Hello. Yes, thank you. Oh, day 8 and we're 3 hours in. I don't think I'm going to make it, but we'll see. Why does Swift? Okay, yeah. So this is so that we can save a function and then we can call it later, as in waiting for a bit of work to be done. And that's why we want to do closures as parameters, right? You might want to run some other code when something happens. So what does Swift have? Why does Swift have trailing closure syntax? Trailing closure syntax is designed to make Swift code easier to read, although some prefer to avoid it. Let's start with a simple example first. Here's a function that accepts a double and then a closure full of changes to make. All right, we got a little print in there. I guess we better write this one out. Animate duration double animations void Okay, print starting a duration. Man, there's so much faster if I could just like copy and paste it. Animation, and then I think, oh, I've done something wrong. There we go. And animations. So we are calling this function that's been passed through. Not going to work because we need to actually run some code, and this looks like that's it here. Animation. So once the animation is completed, we go fade out the image. Cool. We run this. Starting a 3 second duration. It's starting a duration. Well, it's starting a 3. I read both at the same time. Starting a 3 second animation. Fade out the image. Yeah. So this is called after this runs. Okay. So sometimes you could actually put a timer in here or something, and this will take a time, and then the code in here gets called. Separate them a little bit more. Code in here will get called after some time has passed. and the way this works is maybe you want to do some code here in this section. You run the animation, and then under here you have some other code. This will run. It'll jump into this. And if this is running on a different thread, it'll just skip over and just keep running stuff here, and then it'll jump back and run this when it's completed. And what we can do, trailing closures allows us to clean that up. Okay, so yeah, what we can call that function without trailing closure like this. Cool, that's very common. Most people don't use trailing closures, and that's okay. But many more Swift developers look at the, at the end of the wind's a little isn't pleasant. Yeah, oh, I've actually done exactly this. This is much cleaner, right? This versus this. These do the exact same thing. Okay, next. When would closures with parameters be used as parameters? Where are we at? Closures. Oh, we're up to day 9, aren't we? No, we'll keep it. Sorry, we'll keep it 8 because I'm gonna, like I said, I'm gonna set timestamps. If I change it to 9 now in the incorrect spot and I see it and I'll go back to when that was changed, it's gonna mess things up because I won't remember that it actually starts a little bit before that. So we'll keep it as 8 and we'll skip to 10. Okay. We'll skip to 10 on the counter that I've got going. Not gonna actually skip to 10. Okay, so we got when would closures with parameters be used as parameters? Where is 10 anyway? We've got structs. Okay, as soon as we see structs, I'll update the counter to 10. Okay, to give you a practical example, imagine you're building a car. The car needs to know what the engine has, what steering wheel it has, how many seats it has, and so on. Sure, the engine could just be a string of information, but really it should be able to actually accelerate and decelerate to a certain speed. So first we might write closure like this one. Let's get to it. Also, I think around day 16 is when we start getting into SwiftUI stuff. Print changing speed to speed kilometers per hour. So first we might write a closure like this one, and now we can create a build car function. Cool. Build car string engine int. What do we got here? What are we returning? Void. Yeah. So this is the closure. And then we build the car. Once you become more comfortable with closures, you'll start to realize the power here is that our closure is effectively sealed box. Yes, we know that will print a message. We're changing speed, but all build car knows is take an integer and returns nothing. Okay. Oh man, I want to run this. Okay, can we build car, my car engine, and then we pass through. Wait, am I doing this right? Yes, but we're not printing anything. Oh, if we go engine and we run it in there, we can make this happen. I think missing argument. Yeah. So we need to set up build car engine I don't know. The speed, it would be the speed, right? So let's just throw something in there. Yeah, change the speed to 5 kilometers an hour. Okay, cool. All right, excellent. Let's move to the next one. When would you use closures to return values as parameters of a function? Swift closures can return values as well as parameters. And give me a sec, I gotta get a drink. Let's skip over that. For example, we want to reduce the array 10, 20, 30. It could work something like this. Variable current, value set to array. It would then start a loop over the items in the array that got passed in using the range 1 dot 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 dot. So it would count from index 1 to the end. It would then call the closure with 10, current value, and then 20. Okay, cool. Just want to make sure we're not reusing anything for the past. No. Okay, cool. This is awesome. Values int using. I just realized that we talked about closures, variadic functions before, but I don't think we were taught how they were created, were we? I don't remember. I only thought about that now because I saw the array. I don't know if you can hear screaming in the background, but that's my wife streaming some horror games. I'm not going to tell you what a channel is because I want you to stay here. Return current. And I think we need to call this. I'm not going to do the comments in there. Oh, what do we got here? What do we got? Expected. What do we got? What have I done wrong? Int. The syntax highlighting is throwing me off. Turn int. Oh, we got return int again. Oh, so many return ints. Yeah, that was loud. Okay. So with that code in place, we now write this. So add up an array of numbers. Yeah, we didn't even go too much in depth into the throwing functions and stuff either, but I'm sure that's going to come later. It was just a little intro, I'm sure. 30. So what do we got? Let sum equals reduce. My oven just went off again as well, so I'll just go out and take that. This is the last loaf I'm taking out, I promise. Running total int next int in. There's a lot going on here. Let's move out of the way. Wait, can we this will be better. Just hit enter there, right? That's much cleaner if we do it this way. This is how I usually have it all set up. So then we go running total plus next, and we go print sum. Cool, 60. Oh gosh. All right. So running total plus next. Yeah. So this adds everything up. Reduce. Then we actually get a function like this. The array or an array has that function anyway. Like Apple Swift has given that to us. Multiplied equals reduce numbers running total today. Total next. Running total times next. Okay, and we can do the same thing, and we get 6,000. Okay, so the other cool thing here is that we can change. I think we can get rid of this. I think. Is that correct? Print multiplied, yeah. And this lets us shorten things up a little bit, right? So maybe we want to put that on a single line. It's pretty cool. So we can get rid of these as well. Oh, really complex stuff. Really advanced Swift. Not really. $1. Don't ask me to explain how this works. The Stanford course goes into explaining this kind of stuff really, really well. But, you know, it's been years since I looked at that. Okay, oh yeah, we can do another little cool thing too. So we can let some equals reduce numbers using plus. Let's get rid of that. Print sum. Pretty cool. So let's read this because it's kind of interesting. So plus takes two numbers and returns a number, and now reduce function expects a closure that takes two numbers and returns a number. That's the same thing. The plus function fulfills the same contract as reduce once it takes the same parameters and returns the same value. So this here, like when you look at this, you go like, what? You're kind of like, why? This doesn't make any sense. But this plus is a function. That's a function in Swift. Like I'm pretty sure you can do like multiplication as well, right? Yeah. This is a function you're passing through, which is what you're doing here. This is a function you're passing this through, right? It's pretty cool. Pretty cool. Okay, let's keep going. When should you use shorthand parameter names? Oh, that's exactly what this is. Can we skip over this? If we've done it. Are there many parameters? If so, shorthand syntax stops being useful and in fact starts being counterproductive. Was it 3 or 4 that you needed to compare against? Yeah, so it's good to have like 1 or 2, but any more than that, nah. How many parameters can a closure take? Let's delete this. What do we got? Is there a limit? So in theory, a closure can take as many parameters as you like, but in practice, the other parameters are examples. You take 0 to 3 parameters. Yeah, I've had functions that have taken like 20. You can see like if you're doing matrix stuff with like graphics software and that, you know, using stuff in Metal, you'll have functions with like 20 parameters. Big deal. Returning closures from functions. Okay, give me 1 sec. I'll be back. I just gotta take this bread out. Yeah, both my loaves are flat because they kind of like, I overproofed them. I had them left out for too long. But anyway, still going to be edible. All right. Oh, maybe I should have brought one in. I'll do it later. I'll show you what they look like later. Okay. That leads to a second method. We can change our mind whenever we want, just by changing the function that creates the random number generator. All the places that call a function won't change because they still make random. Oh, okay. Well, we're returning closures from functions. Functions can return strings, integers, arrays, and more. Swift lets us use closures anywhere. We can also return closures from functions. But why would you want to do this? Is actually a reasonable thing to do. Most common situations figure this. I need a function to call, but I don't know what function that function is. I know how to find out that function. I know what to ask to find the function, but I don't know myself. Huh? For example, I want to generate lots of random numbers, but I don't know what the algorithm use. All I know is that if I call make random generator. Cool. Okay, this behavior means we don't need to know the actual random number generator does or how it was created. That leads to a second method. We can change our mind whenever we want. Okay, so print int random 1 10. Right, let's run that. This will print a random number from 1 to 10. Yep. If we wanted to write a function that returned one random number between 1 and 10, we would write this function get random number. Yeah, this makes sense. Int random 10. Cool. And we can call it like print get random number. Same deal. Now let's go a step further. We're going to make a function that returns a closure that when called will generate a random number from 1 through 10. Whew. Make random generator. Gosh, I've never used this syntax before. Return function. We could just return this as well. And then notice the return type is now yep, which means a closure that takes no parameters and returns an integer. Then some function we create a closure that wraps yes and sends it back. So what we can do is we go to the generator, make random generator, let random1 generator print random1. It's so interesting. I don't think I've ever written code like this before. I wonder if I'm missing out. I can't right now. I can't think of any reason. Like, there's always multiple ways of doing things, right? This is just like another way of, like, why not just call a function? But it's cool. It's cool that you can do this. Why does Swift closures capture values? Yes. One of the most important features of Swift's closures is that they capture values they use. At the same time, one of the most confusing features of Swift is that they capture the values they use. Put simply, value capturing takes place so that your closure always has access to the data it needs to work, which means Swift can run the closure safely. Yeah. So basically, a closure can just be on its own. Like if it's on a class or something and the class disappears, the closure could still be hanging around and getting ready to run. Like I said before, if you're just tuning in, my wife is in the other room screaming because she is playing a horror game on stream. I might need to go tell her to shut up. Let me know if it's distracting. If it is, I'll try and put a blanket up on the wall or something. Okay. What have we got here? We'll start with the initial value of 0 stored in previous value. We'll then create a new variable called new number to store a new random number. We'll use a repeat loop with int dot random int. Yeah, okay. Condition for that loop will be new number equals previous number. Keep the loop going around picking new numbers. Yeah, okay. Man, I'm just reading this and like some of it's not even going in my head. Oh, where are we at? 3 hours. Okay. Almost at number 10. So we're on track for we'll get all this done in 30 hours, I think. Does that math check out on that? 3 hours to get 10, 30 hours? Yeah. Okay, so everything I've done, I'm just going to do 9 more times. Oh man, I don't think I'm going to make it. Okay, so, distracted. Make random number generator. Yeah, I don't have like a torture chamber or something going on in the room next to me. Just in case anyone can hear the screaming. Previous number. New number. Int. Repeat. Whoa, hold up. What the heck's a repeat? Oh, okay, yeah. While syntax. Oh, that's interesting. I haven't used that before either. So I'm learning new things. I've been doing this. Since Swift was first released. There's a lot of new features that I just haven't used, I guess. While new number is equal to previous number. Yeah, I don't mind that. That's pretty cool. Why is this being all weird though? We got missing. Yeah, previous number equals new number, and then we go return return. Okay. We can now take that code for a test drive like this. Excellent. So let generator make random number generator for in 1, 2, 3, 10 print generator. It's gonna be really confusing for people when I do add these chapters to YouTube, and then at the bottom right, it's like, oh, I clicked on chapter 9 and it's showing 8. Why is it doing that? Because I'm an idiot. I'm an idiot. That's why. Okay, so we run through this. What have we got? 2 1 2 2 3 3 3 2 1 1. Random numbers. I love this because you can you create all this and then you just rerun it multiple times. That's so cool. So this lets you keep track of the previous number you've done, and it will. What is it? I was kind of hoping it would be like if the previous number's already been. Oh yeah, no repeating numbers. There we go. That's where this is headed. Chances you see things that can go plan one. Yeah. The problem is here, previous number, new number, int. Yep. That returns the closure we're calling, which means every time we call generator, it creates a new previous number variable. Yes, exactly. So what we need to do is move it out of there. Yeah, this is really cool. Wait, so how does it run over and over again? So we've got, oh, this. This is what gets returned up here, and that's what this is, and this is stuck like this. This is because we're returning this, we're not, it was inside here. So if we run this again, we should not get any repeating numbers. 1 3 1 1 2. That's really cool. That's really cool, because a lot of, okay, so another way to avoid this is to like create a bucket of numbers, and then you kind of like pull out from that bucket and then do another shuffle, put them back in when you run out of numbers, and then that way you don't have like repeats. So I could see this being used for like a Tetris game, you know, so you don't get like the same blocks one after each other. What's the difference between a struct and a tuple? Oh, okay, so are we on structs now? I think we're on structs. All right, let's update. So structs are day 10. Sorry for anyone else watching. Yes, I did forget to update day 9. Oh, we're gonna move this across. There we go. Day 10. Day 10. 3 and 15. 3, 15. All right, let's keep going. Swift tuples let us store different name variable. Yeah, so tuples and structs are basically the same, right? Well, you just learn the difference in simple. Tuple is effectively a struct without a name. That's what I said earlier. var name string. Tuples for lazy people. Me. City string. Okay, well, you just learn the difference in simple. Yeah, and it will do the same thing as the following struct. However, tuples have a problem. While they are great for one-off use, particularly when you want to return several pieces of data from a single function, they can be annoying to use again and again. Think about it. If you have several functions that work with user information, would you rather write this or this? Well, the first one, of course. Think about how hard. Oh, I didn't have to write any of that. Okay, so when should you use a computer property or a stored property? Okay, when's day 11? Access control. Access control. So as soon as we see like private, public, that's when we're on day 11. Okay. Oh, okay. Computer property or store property. Let's go past this. We're just running code today, aren't we? When it comes to dependencies, whether your property's value relies on the value of the other properties, tables of turn. When should use computer property or store property? This is a good question actually to answer. So deciding which to use depends partly on whether your property's value depends on other data, and partly also on performance. The performance part is easy. If you regularly read the property when its value hasn't changed, then using a store property will be much faster than a computer property. Yeah, you don't want to do like math every single time you access the property. Maybe you want to update it elsewhere. Okay, so let's keep going. When should you use property observers? Property observers. I use these all the time. Except I think they look ugly. So I try not to. Let us attach functionality to be run before or after property is changed using will set and did set respectively. Yeah, the annoying thing with Swift at the moment is you kind of need these. And it's an improvement because I think in some other languages you only get set and get. You don't get like will set and did set. I rarely use will set. I use did set almost all the time. It's just nice to have because it's like a single place you can react to a property change. if you need to repeat, reuse code when a property gets set. The most important reason is convenience. Using property observer means your functionality will be executed whenever the property changes. This is just a little lowdown on that. When should you use will set rather than did set? Oh yeah, a good example. So let's see that. Oh, there isn't any. They might be in the text. Both will set and did set did let us attach observers to properties. Meaning, yep. Simple answer to this. Most of the time you'll be using did set because we want to take action after the changes happen, so we can update the user interface to save changes. That doesn't mean will set isn't useful. It's just that in practice, it's significantly less popular than its counterpart. The most common time will set is used is when you need to know the state of your program before a change is made. For example, SwiftUI uses will set in some places to handle animations so that it can take a snapshot of the user interface before a change. Yeah, cool. Yeah, that's a good example. What's the difference between a function and a method? Good question. Swift's functions let us name a piece of functionality and run it repeatedly, and Swift's methods do much the same thing. So what's the difference? What is the difference? Honestly, the real difference is that methods belong to a type, such as structs, enums, and classes, whereas functions do not. That's it. That's the only difference. Yeah. So everything we've been putting in here have been functions. Methods are on a type. But the thing is, they're interchangeable. Like, people use them in both ways. Heck, they're so similar that Swift still uses the func keyword to define a method. Yeah. Could you imagine like having like a struct or class and having to type meth? And that, like, function doesn't work, but meth does. I understand why they didn't do that. Of course, being associated with specific types such as struct means that methods gain one important superpower. They can refer to the other properties and methods inside that type. Yes. Functions can refer to other methods and functions and properties that are at the top level as well, like what we've done here. You know, you can put we can put a property up here, and then we can have the function refer to it, I guess. There is one more advantage to methods, but it's quite subtle. Methods avoid namespace pollution. Yes. The reason for that is because it's my class dot some method. And then that way you can go other class dot some method. You can keep the same name of the functions and they can do completely different things. Whereas if you're using a function at the top level, you can't have multiple of the same, multiple functions with the same name, unless you change the parameters and stuff. That user can get messy quickly, but that can get messy. What do I say? User that can get messy quickly, but by putting functionality into methods, we restrict where those names are available. Wake up isn't a reserved name any more than specifically some user wake up. Yeah, cool. Why do we need to mark some methods as mutating? This is almost access. This is access control, right? Why strings, structs, and Swift? This is this isn't access control, not yet. It's just the thing you put on the start of like maybe your function or on your properties. Sorry. But only if that structure is created as a variable. Of course, it's possible to modify the properties of struct, but only if it's created as a variable. Of course, inside your struct, there's no way of telling whether you'll be working with variable struct or constant struct. So Swift has a simple solution. Anytime a struct method tries to change any properties, you must mark it as mutating. You don't need to do anything else other than mark the method as mutating, but doing that gives Swift enough information to stop that method from being used with constant struct instances. Two important details I find useful. This is the kind of stuff that's probably going to be on that quiz at the end. And if I don't like read at least half of them, I'm probably going to fail this quiz. If we ever get to the quiz. Marking methods as mutating will stop the method from being called on constant structs, even if the method itself doesn't actually change any properties. If you say it changes stuff, Swift believes you. Yeah. A method that is not marked as mutating cannot call a mutating. A method that is not marked as mutating cannot call a mutating function. You must mark them both as mutating. Yeah. Why are strings structs in Why are strings structs in Swift? Many other languages, strings aren't structs. They are just a sequence of letters and nothing more. Swift takes a different approach. Strings are structs. Yeah, I think originally it used to be like an array, I think. And yeah, it is a struct now, but it has a lot of the array functions on it, which is kind of cool. And in fact, some come packed with functionality. Yes, Almost all of Swift's call types are implemented as structs, including strings, integers, arrays, dictionaries, and even booleans. This is an accident. Structs are simple, fast, and efficient in Swift. In Objective-C, they are classes. They're reference types, I think. But yeah, in Swift, they are value types. Which means we can create a string much many without worrying too much about performance. Yes. When things get really complex is how we handle emoji. Yes. Because this string, there's a set amount of characters to make an emoji, not just a single character. Because there are countless variations of skin tone and gender rather than storing each. And emojis, some emojis are made up of other emojis. Yeah, they're not stored as a unique letter. These are often broken down to multiple special letters. For example, the emoji two women holding hands, where the left woman has light skin tone, the right woman has Swift actually stores woman light skin tone. Yeah, so these are multiple emojis that are combined. So we actually use 7 letters to store one emoji in that instance. It's complicated. Yeah, so now you understand some complex strings. Taking a look at these properties and methods. We don't have string. We can't do. We're not going to type that out. As prefix hello. Oh, we can do a little. It's kind of cool. Cool. Why do strings behave differently from arrays in Swift? Well, because they're not anymore. If you think about it, strings are really just lots of individual characters come together to form text. But whereas Swift lets us read array values using myArray3, we can't do the same thing with strings. Is invalid. Yeah. I think we can go first. We can grab the first character out of there. There's some array functions we can do. This goes back to emoji and other similarly complex characters because yeah, if we had an array of emojis, it would give us the first emoji in the a string of emojis would give us the first emoji. It can get really annoying, like if you wanted to do like ranges and things. If anyone's ever tried to use the range to find the range of a string, items in a string, there's like you can't. The Objective-C one, the old NS range, and that seems to be more flexible. Well, it's one that I'm more familiar with, so I'll probably say it's more flexible a bit than the newer one, even though it's probably not. But I guess what I'm getting at is when you're trying to like extract certain characters out of a string and there's emojis and stuff in there, you may like split the emoji down the middle accidentally. So there needs to be, there's obviously Swift is giving us things to help deal with those. Yeah, so you've got regional indicator symbol letter S, which will then put together into the United States flag. Yeah, US. Can't just take part of an emoji because it wouldn't make sense. Yeah, there we go. So that's why this doesn't work. Yeah, before I'm done, I want to add one thing that might not have occurred to you. If you want to check whether a string is empty, you should write this. Yes, we did that earlier, so we're not going to type that out, and not this. First code can return true if the string has any letters, but the second has to count all the letters in the string. That's what I was getting at before, right? If you do this in an array or a string or anything like that, and you have this sort of syntax, you should stop doing that, because if you've got like a million characters in there or something, this slows down. This takes time. How do Swift's member-wise initializers work? Okay, we've got some code I think we can do here. First, if any of your properties have default values, then they'll be incorporated in the initializer as default variable. Okay, let's do this. Struct user. We've got var name string var years active 0. Cool. Then I can create it either of these two ways. Struct employee. And these names, I shouldn't blame the names. I can't even type employee properly. And we can go years active. 5. Oh, that's a long time. Okay, so yeah, so in this case, you don't have to set up an initializer. This is done automatically for you with structs. If you're doing a class, you have to do it, I think. But for structs, not an issue, which is awesome. You know what? I think maybe like Apple doesn't give us this functionality on classes because they want make structs as convenient as possible, and classes a little bit more inconvenient. I don't know, just so that we use them because the structs are way better to use for everything. I mean, we're using them in SwiftUI now, so a view views the structs. Okay, so what do we got here? So the second clever thing Swift does is remove the member-wise initializer if you create an initializer of your own. For example, if I had a custom initializer that created anonymous employees, it would look like this. Yeah, so let's do that. Self.name equals anonymous. Great. And then we go print creating an anonymous employee. And we run that, we get an issue because it doesn't have that initializer it was relying on before. With that in place, I could no longer rely on the member-wise initializer. This would no longer be allowed. Yes, exactly. So what we can do, oh, wow, this is nice. Some deliberate feature, we created an initializer. And if Swift lets member-wise initializer in place, then it might be missing important work. So as soon as you add a custom initializer for your struct, the default member-wise initializer goes away. If you want it to stay, move your, so this is something that I didn't really know about. I didn't know that this, if you move it into an extension, you still get this functionality back, which is like super powerful. Because what I was doing, right, I was leaving this in here, and then I just go, all right, let's create a new one. So that's amazing that works. That's so cool. That's like something I can action now. I can go back to my code and I can actually there's bits of code I can think about. Well, I could replace, you know, drop the ones I created and clean things up a bit. Man, that's awesome. Creating an employee now works. Yes, as set as anon employee. Yeah. Cool. When we use self in method. Okay, struct. Student. I'm gonna have to get some lunch soon, everybody. It looks like it's pretty quiet at the moment on YouTube, so I might be able to get away with that. I'll keep the stream running, obviously. Best friend. Yeah, so we're doing this manually now. Print enrolling name. So you don't get this print statement if you just rely on the automatic initializer. So sometimes you need to create one if you want to do something else. Like maybe you want to do some calculations in here before you set them to the properties as they come in. Yeah, and it's important to do self and stuff here. I don't think do you have to? By far the most common reason you use self inside initial where you likely want parameter names that match the property names you types like this. Yeah, you don't have to use that, of course, but it gets a little clumsy adding some sort of prefix to the parameter names. Yeah, student name, best friend, student. Yeah, I've done this in the past, this kind of thing. But yeah, it's much easier to just go. You just go self. And differentiate it's between the two, right? So you got that one and you got this one and this one. Outside of initialize the main reason for yourself is because we're in a closure and Swift requires yes. When should properties be lazy? What? Lazy property. Let's skip through that. What's the point of static properties and methods in Swift? Static. Oh, this is a good one. One common use for static properties and methods is to store common functionality used across an entire app. For example, I make an app called Unwrap, which is a free iOS app for folks learning Swift. In the app, I want to store some common information, like as the URL for the app on the App Store, so I can reference that anywhere in the app needs it. So I have code like this storing my data. Yes, and it's initializable once, right? It's created once. You don't have to waste CPU cycles recreating it every time. So static. Oh, and this is just an example. So let's skip that one and then do this one down here. That way I can write unwrap.app URL when someone shares something from the app, which helps other folks discover the app. Without the static keyword, I'll need to make a new instance of unwrap struct just to read the fixed app URL, which isn't really necessary. I also use both static property and static method to store some random entropy in the same struct, like this. Yeah, so if we go static var entropy, how many? 1000? Yeah, and so this will only be run once, and this number will always remain the same, right? Static function get entropy int entropy plus equal plus equals 1 return entropy. Random entropy is some randomness collected by software to make random number generation more effective. Static properties may only be declared on a type. Oh, dang. Oh, I can't call the type. Some struct. There we go. And now I guess we can do a print down here, right? So we can go and some struct dot entropy. We can do the same thing for get entropy. Printed, and then we've run this again and we've grabbed that. Yeah, and so this, you can notice that like it's not some other random number in this second one because it's calling this. This has already been set once. Some code does store an entropy integer start with random but increments by 1 every time get entropy is called. So if we go again, 96, yeah. And the reason for this is because we set it up here again. We go plus equals 1 and we increase it every single time it's called. Second, because I have a dedicated get entropy method, I actually ask Swift access to the. This is day 11 stuff. This is, yeah, more access control in the very next chapter. No, you can't do it a chapter before. It's going to mess up my counting. Access control, day 11. Yeah, that'll be the next, the next one. Awesome. Second, because I have a dedicated get entropy method, I actually ask Swift to restrict access to the entropy so that I can't access it from anywhere. This is called access control. Yeah, so if we go private static, this means, check this out, this won't compile now because I'm not allowed to access that because I marked it as private. So I can only get access there. Cool. Okay, 11. Oh gosh, it took 15 minutes. This is all right. Keep going. Allows us to restrict different parts of the code. Yes. Oh, sorry, I just gotta get more comfortable here. Private var, learn sections. Yes, so we set that as private, so it can't be accessed anywhere else. No point doing it in this playground because it's still going to be, it can be accessed by everything else because if you read, it's private, which means that no one can read or write it to it directly. Instead, I provide public methods. Yeah, so wherever this is declared, that class, that object, struct, whatever, can access it, but anything outside the object or struct cannot. Which is why private means nothing in a playground. Why does Swift have both classes and structs? Keep going. Why don't Swift classes have member-wise? What's the next one? What's day 12? Classes, inheritance, and checkpoint 7. Static properties, methods, and checkpoint 6. Okay, so we're going to do checkpoint 6 in a second. Why don't Swift classes have a member-wise initializer? Oh, okay, this will be good because I made assumptions before. Let's read through this real quick. One of the many useful features of Swift struct is that they come with synthesized member-wise initializer, letting us create new instances of the struct just by. By the way, it's a big challenge for YouTube's speech to text thing for the subtitles. I'm going very quickly and slurring my words. Sorry about that. So why don't they have it? The main reason is that classes have inheritance, which would make member-wise initialize difficult to work with. Think about it. Yeah, okay, that's a good point. I didn't think about that, but I will now. Think about it. If I build a class that you inherited from, then added some properties to my class later on, your code would break. All those places you rely on member-wise initialize would suddenly no longer work. That makes perfect sense. So Swift has a simple solution. Rather than automatically generating member-wise initializer, authors of classes must write their own initializer by hand. This way, you can add properties as much as you want without affecting the initializer for your class and affecting it. Okay, good. When would you want to override a method? When you're subclassing, right? The level of customization is really important. It makes our lives easier as developers. Think about it. If someone has designed a brilliant class that you want to use but isn't quite right, wouldn't it be nice to just override one part of its behavior rather than... Yeah, and when you're overriding, you can actually call the previous one that the other person implemented if you like, by doing like super dot whatever the function is. If you use it when it isn't needed because the parent class doesn't declare the same method, then you'll get an error. Swift makes us use the override keyword before overriding functions, which is really helpful. Yeah, if you use it when it isn't needed because the parent class doesn't declare, you get an error. Great. If you don't use it when it is needed, you also get an error. Excellent. Which classes should be declared as final? Anything that's not being subclassed, right? Final classes are the ones that cannot be inherited from, which means it is not possible for users of your code to add functionality. I add final to just about all my classes anyway. You don't have to. But there is something that I think he'll go into the reason here, which is awesome. Remember, anyone who subclasses your class can override your properties and perhaps also your methods, which offers them incredible power. If you do something they don't like, bam, they can just replace that. They might still call your original method as well as their replacement, but they might not. This can be problematic. Perhaps your class does something really important that it mustn't be replaced, or perhaps you have clients on a support contract and you don't want them breaking the way your code works. Much of Apple's own code was written before Swift came along in an earlier language called Objective-C. Objective-C didn't have great support for final classes. Apple usually resorted to large warnings on their site. For example, there's a very important class called AV Player View Controller that is designed to play movies, and its documentation page has a large yellow warning saying subclassing AV Player View Controller and overriding. Typo. And overriding its methods isn't supported and results in undefined behavior. We don't know why, only that we shouldn't do it. There's another class called timer that handles timed events and alarm. The warning is simpler. Do not subclass timer. Yeah. In Swift, it used to be the case that final classes were more performant than non-final classes because we were providing a little bit of information about how code. This hasn't been true for a while. Oh, excellent. So we don't need to do that. Right, but even today, I think many people instinctively declare classes as final to me, and you shouldn't subclass it from this unless I specifically allow it. I certainly do this a lot because it's another way I can help folks understand my code works. Yeah, I add it mainly for that reason, but also I did do it because of the performance reason, but it looks like it's not an issue anymore. Why do copies of a class share the data? Because they're references. These are probably good examples to go through to show the difference between a reference and a value type, reference types, value types. Okay, hang on. Let me have a drink. Gosh, we're almost halfway through a workday, and I'm only at like number 11. Gosh, at this rate, it's going to take 40 hours, not 30. I'm not gonna finish. Okay. Message equals welcome. Var greeting equals message. Great. Greeting equals hello. All right. It's changed. We got it changed. Excellent. When that code runs, message will be set to welcome, but greeting will be set to hello. As Chris Idahoff says, this is so natural it seems like stating the obvious. Yes. But that's how structs behave. The value is wholly contained inside the variable. Yeah, this is like your... this is intuition. Like, this is your how things should intuitively work, right? You make a change. It should change it. But reference type does not do that. So we got welcome, we got hello, because we haven't changed the word message, right? We've only changed greeting. If this was a reference type, changing greeting will change message. They both point to the same value. Okay, oh no, I'm losing my voice. Why do classes have deinitializers and structs don't? One small but important feature of classes is that they can have a deinitializer function counterpart to a init that gets run when the class instance gets destroyed. Structs don't have deinitializers, which means we can't tell when they're destroyed. The job of deinitializers is to tell us when a class instance was destroyed. For structs, this is fairly simple. Struct is destroyed when whatever owns it no longer exists. Because we're keeping a reference to them, it's easy to know when something has been deinitialized. And the method ends, the struct is destroyed. However, classes have complex copying behavior. That means several copies of the class can exist in various parts of your program. All the copies point to the same underlying data, and so it's now much harder to tell what the actual class instance is destroyed when the final variable pointing to it has gone away. Behind the scenes, Swift performs something called automatic reference counting. Yes, value goes up, value goes down, depending on how many references to that class. You put your initializer somewhere you want in your code, anyway you want in your code, but I'll have to quote from Callahan, code should read like sentences, which makes me think my classes should read like chapters. So the deinitializer goes at the end. It's the end of the class. Why can variable properties in constant classes be changed? Oh my gosh, one of the small but important differences between structs and classes is the way they handle mutability of properties. Because you'll be able to change the value. You probably can't change the address where it's the pointer itself, right? Let me see. I simply can't define the number 5 to be 6 because that wouldn't make sense. It would break everything we know. Okay, wait. The reason for this lies in the fundamental difference between a class and a struct. One points to the same data in memory, whereas the other value such as one is the value such as number 5. Because of the, consider code such as this. We can't simply define number 5 to be 6 because that wouldn't make sense. Yeah, mathematics, break everything we know about mathematics. Instead, that code removes the existing value assigned to a number and gives it the number 6 instead. That's how structs work in Swift. When we change one of its properties, we are in fact changing the entire struct. Sure, behind the scenes, Swift can do some optimization so that it isn't really throwing away the whole value every time we change just one part of it. But that's how it is treated from our perspective. So if changing one part of a struct effectively means destroying it, destroying and recreating the entire struct, hopefully you can see why constant structs don't allow the variable properties to be changed. I'm still waiting for... Oh, we're gonna skip another one, aren't we? We've talked about inheritance and classes now. Checkpoint 7. Protocols, extensions. Okay, we're getting there though. We're almost at SwiftUI, so this is gonna be great. I hope things speed up a little bit. Classes don't work this way. You can change any part of their properties without having to destroy and recreate the value. Yeah. Okay, next. Why does Swift need protocols? Protocols let us define how structs, classes, and emails ought to work, what methods they should have, and what properties they should have. Yeah, this is the best feature of any programming language, is like having things like protocols, categories. In code terms, our simple by method that works only with books would look like this. Yeah, let's type this out. It's been a while since we've typed anything. Yeah, we can pass through a book type, and then we go print I'm buying book.name. If we say buy book, let's use the init. Book is called hello. I'm sure there's one out there called that. I'm buying hello. Excellent, yes. To create a more flexible protocol-based approach, we would first create a protocol that declares the basic functionality we need. This might be many methods and properties, but here we're just going to say that we need a name string, which is purchasable. I like this idea. We put it at the top. That way our book can get access to it. Yeah. Not an issue if you're making an app, but in Swift Playgrounds, everything needs to be top down. The structure of the code. Everything after it relies on the code before it. Now we go ahead and define as many structures as we need, with each one conforming to that protocol by having a name. Yeah, so this is really, really cool, right? So we can just go purchasable. If we can run this, if we comment that out and do a run, we'll get an error because this is saying typebook does not conform to protocol, and you can actually go in here and just say fixed, and it'll give it to us, which is really, really cool. So this is like a rule. It says you must have, if you have this, that you must implement these. And the great thing about it is what you can do is you can have an array of purchasables. And what's going on here? So if we grab these real quick, I am copying and pasting, yes, because I just want to try and save some time on this example. It'll probably go into, yeah, there's the example there. But let's say I like the idea of having this as an array. Let's do a little run. Make sure it's all good. Yep, it's empty. And so what we could do is we could have an array of, we could have a movie. Actors. There's no actors in this movie. Let's continue. And we can have car. Oh, let's go back to our, let's go coffee. Is this right? Coffee, and we go, come on, what did I press there? High for coffee. Strength is like 190. I don't know what that means. And we just go play. Come on. What we got? What have I got? What have I done? As any. No, we don't want as any. So we want the types in here to be of type. We have to declare, we have to say purchasable, right? So instead of using as any, where it's like there could be anything in here, we want only purchasable. So what we can do now, because we've got, let's come back up. Where have we got? Let's add that there. Protocol methods must not have, yeah, so we want to do an extension on this. This is getting a little bit more complex, but this is why I love protocols so much, right? So if we go, we add this function to an extension, what we can do is we can say, we can go, we can actually add, we can even like extend array to put a by all function on it, and then we can run this code. So we can go for item in array. So this is, just say this is a shopping cart, right? Let's pretend this is a shopping cart, and we can say item dot buy. Yeah. Oh, it'd be self. Let's remove that because that gets confusing. Item. We go buy item. This will work better. And it says, yeah, I'm buying hello, I'm buying hi. And because with this array, we do not care about, we don't care too much about the, well, we got name. That's all we care about. We don't care if who the strength, manufacturer, actors, or anything like that. All we want is we just want to be able to make a purchase. So on these, maybe we have prices, right? So maybe on purchasable, there'll be a price item. And we'll just set it as an int. And then maybe down here, we want to add all those up. But yeah, this is a great way if you just want to, hello. Hey, hello, welcome to the stream. But yeah, so I'll use protocols just about everywhere I can, and anywhere I can use them, I'll use them, because I just find them so, it for some reason keeps my code so much more clean. And I try to avoid inheritance as much as I can, like using classes and things. I think we've done with that example. Yeah. So when I'm building my apps, I like to scale horizontally, right? With lots of structs, have lots of protocols. Don't go vertically with multiple subclasses and things like that. I wrote a book with a good example of that, where how I implemented a game of life, and I think I used a bunch of structs in that too. A bunch of structs, bunch of protocols and stuff, and how that works. So when should we use protocol inheritance? Where are we at now? Oh my gosh, I feel like, I don't know. Am I missing a, maybe there's a thing saying, somewhere saying this is day whatever, but I can't see it. Okay, let's keep going now. Swift, you finished. Wait. Oh, you finished the whole 100 days of Swift? Did you, how long did it take you? Did it take you 100 days? Or you just finished it today? You did it all in one day as well? Swift lets us build new protocol based on existing protocols, much like the way it uses. Okay, so we are talking about protocols. I think we're up to day 13, right? I'm not gonna update the counter because I'm gonna use this set chapters. I'll do it when I know we've got to a new one. So when we get to optionals, I'll change it. I finished this 100 days and I don't know what to do now. Oh, it should say at the end on the last day what to go next. I think if you finish this whole thing, you should take a look at building your own app. Build like a quiz app. You know, like those BuzzFeed quizzes? You could probably get away with that. Or build like a Magic 8-Ball app. Build a weather app. I'm not sure if this goes through APIs, like doing network calls and stuff. I haven't looked through the entire course yet. So look. Oh, it doesn't say. There's no details. Consolidation, focus on data. Retrieve and store data in our SwiftUI apps. Core data. I wonder if it goes through networking. Probably does. Yeah, build like a weather app. That's usually like one of the first sort of things people do. Okay. Yeah, let's go with this. Protocol computer. It took 5 months. I finished it about 1 month ago. Oh, okay. Oh gosh. Well, I hope this doesn't take me five months. It's taking a lot longer than I thought it would, though. I thought this was just going to be like a really quick set of things on a page, and as soon as I've opened it up, it's like, no, there's so much, so much to do. Maybe I'll make my own course, which is like 100 minutes of Swift. Although I don't think you'd learn much. API days, excellent. Yeah, so it seems like you got all the skills to build a full app then. Why don't you give that a go? Start basic though, like don't go big, and that's what everyone tends to do. My current app that I've been building has been taking me probably over a year because of all the extra features I've been adding in there. I have another stream where I took a whole day, like 10 hours to build an app from start to finish and upload it to the App Store. If you want to check that one out. So bet it's going to get me to rewrite these. Yeah, so we've got... So some duplicates in here. I think what we're going to learn is how we can remove these duplicates. Oh, you already did a weather app. Excellent. I started with combine also. Oh, yeah. Storage int get set. Screen size. Ah, screen size is like a new... We don't have that on the previous protocol. Gosh, what else can you do? Have you got any other ideas? Like, I mean, why did you start learning Swift in the first place? You got anything that you wanted to build? Maybe you can start on that and just do like a portion of it. But you see how much duplication we already have? Yeah. So now imagine working with phones and tablets, more protocols and more duplication. Much simpler and more flexible if we break our protocols up and smaller. Excellent. So we're going to do that. This is why I love protocols. It's my favorite way to program. So we've just got rid of price and weight, right? So we don't need these anymore. But there is something surprised me when I was looking for entry iOS jobs. The majority looking for UIKit, not SwiftUI. Yeah, it depends. That also depends on what country you're from, right? And a lot of the projects, a lot of companies have been around for a little while. Like who have had their apps out for a while will be looking for UIKit people. Especially even if they're converting from UIKit to SwiftUI, they're going to want people who know UIKit so that they can do the maintenance that they need to do between releases, and then also know how to do the transfer over to SwiftUI. And some companies are just not going to change. Honestly, they're probably not, like, as tough as it is finding work this way. Like, you just want to get a job, right? So you can get paid. You don't want to get stuck at a place that's going to be stuck with UIKit and not upgrade. It'd be great to land a job as soon as possible to get into one of those and then look for another one, you know, for people who are a little bit more progressive. But I mean, if you can do that, go ahead. You might even be able to fake your way in if you just learn enough about UIKit. My first thoughts all over the place about this. Sorry. My thoughts about this. So when I first started, I knew very little programming. I did some freelancing on the side just to get my skills up and then earn, you know, like $2 an hour or whatever it was on those freelance websites in the early days before there were too many iOS jobs around. I'm from Iraq, but I was looking at the market globally to know where the market goes. Yeah. But yeah, when I first started out, I had to embellish my resume just a little bit and say that I had like 1 year experience, 2 years experience, when I only really had like 6 months, because I figured I managed to meet every challenge on the way up until that point, and I was fairly confident in my skills where if I got the job, I could look at the code on the computers that I had to work with, take some mental notes as I'm onboarding, because the onboarding period, they accept that you're not going to be very good at it, and then so I would take notes and I would go back home and then I would like practice the stuff that I didn't know, and then come back the next day and then do the work. And eventually, after about a month, I was sort of like up to speed with everything. And I think maybe you could do something similar with UIKit. Spend one. You already took 5 months to learn SwiftUI. Spend another month learning a little bit about UIKit, and then just start applying for those jobs and just say you have more experience than you do. You're not gonna. I don't know what it is like in Iraq, but are you gonna get into trouble, like serious trouble, if you make up stuff on a resume? I don't know what the laws and stuff like that, but here it's, if the worst case that happens is you get fired, and you still get to keep the money you made. I know it's like dishonest and stuff, but there's sometimes you have to do, like if you're like struggling to survive. And the thing is, if someone came on board, like if I was hiring, I don't have a company to hire for, but if because I work on my own now, but if I was hiring and someone came in and they were like really wanted to I just copied the exact same code because I'm talking, I just had to put product up here, and they came to me and they were like still really new and fresh, and I could kind of tell like they're not great at what they, you know, maybe their resume is not the truthful, but they came across as being like they really wanted to learn. It wasn't just a job. I'd probably hire them anyway. What I'm saying is don't get dissuaded. Like you're looking at the job posts, right, and you're going, oh, it says UIKit required. Just apply for it, right? And then when you go in the interview, they'll ask you, they'll say how many years of UIKit, and you just be like, look, I don't have a lot of experience, but I've done all the stuff with SwiftUI. Just go in, and even if you don't get it, it's still practice at interviewing, so you'll get something out of it anyway. And eventually, like, just keep interviewing for these jobs. Don't just be like, I'm not going to send an application because it says it wants me to have 10 years of university experience or something. You just apply. That's the best advice I can give you. I thought of that, but man, I feel it's not right to do that. Not great start. Yeah, I know. I'm not that sort of person either. Like, I feel like I could be a millionaire now if I was like the kind of person who would, set up scams and things, and I just can't. I'm not like, I can't do that. I can't really lie to people, and I don't think. To me, it feels okay to me to do that on a resume if you think you can back it up, right? Like, here's the thing: they're looking for someone who can do the job. If you think you can do the job, then that requirement shouldn't be an issue. You should be able to just, if you can go in there and actually do the job, even though they're saying, oh, they're looking for someone with this certain skills, but you can actually like go home in a weekend and learn those skills. I think that's completely fine. Like you're not stealing from them or anything, right? If you actually give them the outcome they're looking for, I don't think there's anything wrong with that. Does that make sense? Do you agree with that? You're back. Excellent. Wait, did you have a nap? Have you slept already? You said you were having a shower, or you probably got food or something, because it's only been a couple of hours. 4 hours in. We've got to continue with this. Product, computer, product, laptop is a product as well. Oh, laptop is a computer, yeah. So this is almost like inheritance, right? Kind of. Now we can define what a laptop looks like. So we don't actually care about these. CPU and memory. What have I got wrong here? CPU, memory, storage. Oh, yeah. We can get rid of that. I must have missed memory. Yeah, there it is. I missed that on the original. Yeah, so this simplifies the code heaps. That's all we had to do. I thought we were gonna do something cool with it. So if we go laptop, let's do it. Let's create it. Let's call it laptop. Laptop. Oh, it's a. Oh, this is dumb. Okay, the protocols. So we need to. What do we got? I don't know. Asus, I guess. I would have made this a struct, I guess, for this example, but it doesn't matter. And we'll mark it as laptop, right? And if we run this, it's going to say, hey, it doesn't conform to any of these protocols. So we add them in, and then here they all are. It gives us all these immediately for us. And if we delete one of them, we get an error. Applied for a job without experience, but told them how eager I was to learn, and that money was not important to me, so I was earning $1,500 per month. I didn't finish a developer study or something. Yeah. Sometimes, like, companies can be pretty flexible, right? If they are looking for someone like really specific, and they need like, if you're going to be the only iOS developer on a team or in the entire company, they'll probably want someone who's senior, right? For a reason. Like, if you're the only one, you need to be able to manage all that. But if you're going to be put onto a team and they're looking for someone who's like medium senior, they're like, oh, we just need extra pair of hands on this. If you go in and you're like I sort of know my stuff. I'm a little bit, not great in some areas, but I really, really want to learn and get through this. And money doesn't matter. They might say, all right, so the job posting is up for mid-level and it's like 100K a year, but because we've still considered you junior, would you like the job? But we're only going to pay you 50. Then you might say yes. Because here's the thing. With software development, you can switch jobs like every 6 months and get a pay rise. Like, can you imagine, like, you've got your resume, you're saying you've learned SwiftUI, let's say, for example, it took you 5 months, you write on your resume, I've been doing Swift for a year. A little bit of a lie, right? I've been doing it for a year. You get hired as a junior. 6 months later, you write on your resume, oh, I've been doing iOS development for 2 years, even though you've only been doing it for 6 months professionally and you have 5 months of practice. You can keep doing that, and every 6 months when you switch jobs, you'll get a huge pay bump. And that's kind of how I went through my career. I think the longest I ever stayed at a place was 2 years, and that was because I really enjoyed working there. The other places was switching between full-time contracting work, and then now I just have I get bored of the work really quick as well, so I'll switch fairly often. But now that I'm working for myself, I have multiple clients and I can just jump between different projects, and that sort of keeps me fresh and busy. Okay, so what we got? It was a job as a PHP developer, and I worked there for 2 years. Oh, okay. So you were there before they you were already known to them. After that, I learned about iOS and I started looking for iOS development job. Couldn't find junior roles for it. Yeah, I applied to a senior level vacancy and explained to them that I'm not a senior, but again, I wanted to learn and money wasn't important for me, so $800 a month. Actually, you get me excited to learn UI kit, but starting with 100 of Swift UI kit version, I think it would take too long. Do you suggest I look at press course? Now I'm almost finished my software engineering study. There's 100 days of UI kit. Oh man, should I do that as well? Will that take me multiple days to finish? Now I'm almost finished my software engineering study and have almost 3K contract. Yeah, awesome. Yeah, so you just keep jumping from one to the next. Get you excited to learn UI kit. You've already done a lot of hard work, as in you already know Swift, right? Like learning. I don't know if you've done other programming languages before, but yeah, learning a new programming language is probably much harder than learning a framework. And honestly, I would say SwiftUI is a little bit more trickier than UIKit because UIKit comes across as much more it makes more sense, whereas SwiftUI things, you get functions that just don't work on certain view types. They just you can call it, but nothing will happen. Whereas UIKit is more robust and well structured, I would say. If you do something wrong, the compiler will tell you you've done something wrong. Whereas with SwiftUI, it doesn't really do that. It'll let you write code and then something won't happen. Or nav bars are incorrect or things are in the wrong place and it won't tell you why. UIKit, I wouldn't say you'd have to do 5 months of that. Jeez. You know what you should do? Do your weather app in UIKit. Do maybe the first couple of days of that 100 days. Yeah, original 100 days of Swift use UIKit. Yeah, just start with a couple of days of that until you'll know, right? You'll get to the point where okay, I know how to create a view now. I know what a view controller is. Let me go convert my weather app and see what I can do with that. That might be quicker for you. In 3 years, I went from 1,500 to almost 3,000 without a study, just hard work. Yeah, exactly. So that's per month, right? So that sounds that's really really good. Yeah, it's basically doubled in 3 years. How many times did you switch jobs? Was that once? Twice maybe? But it's like you will not get a pay rise if you stay in the same job. You have to switch. The good thing is the market's like at the point now where people don't care if you it's not like other jobs where you're going to get some nasty manager that's like, why are you switching so quick? Sometimes they ask you that and you just be like, look, I just want more money. You're allowed to say that because they're desperate for workers at the moment anyway. So as long as you can show that you can do the work. The other thing is when you're looking for jobs, when you're just starting out like junior and that, you need to have some projects on GitHub that you can show. They'll also get you to do take-home assignments and stuff. I think I'm at the level now where I don't need to do that anymore. It's pretty rare for a client to ask me to do a take-home test. If I'm freelancing, so it's a little bit weird. It's kind of like asking a plumber to fix part of your house or something to prove that they can do the rest of it. It's a bit silly. Switch 4 times, but one job in between was not iOS. Yeah, cool. Yeah, but yeah, that's just how it is. You got to keep switching. But that's why I suggest don't get attached to your first job too much, or the interview process. If someone comes back to you and they're like, "Yeah, we'll come in for an interview," don't be like, "Yes, this is it. I'm going to land this job." Just doesn't matter. You just want to get the work. You want to get started. You want to get the experience. That's all you care about now, is money to survive and some experience. 2 years from now, you can start chasing bigger dollars and the experience won't be as much of an issue. And then eventually you'll have to skill up in other areas like team management and things like that. Running meetings. Oh gosh. Talking to back-end devs, trying to understand their systems and how that stuff works. I didn't know what AWS was for such a long time, embarrassingly long time, when I first started out. Is this live daily? Which time start? Oh no, this is a this is a challenge I'm doing to get through all of them in one day. It was almost daily when I was on holidays, but yesterday I went back to work, so I've got some client work I'm doing. I'm going to try and do this weekdays almost every morning. I'll try and do some sort of stream. So what I usually do is like I'll pick a design off Dribble and try to re-implement that in SwiftUI in like an hour or so. I try to find something interesting that uses techniques that I haven't used in other streams. I've got another one starting up where we talk about, I haven't got any other stuff here, I've moved it all. Working with electronics. So, most of the content out there online for iOS development that doesn't talk about Bluetooth interactions between devices and things, or controlling hardware. So I want to talk about writing code for like embedded systems, just a short maybe stream on that, and then how to write an app that can talk to a device with sensors on it, so you can get like real-time information streaming from the device, like maybe motion or temperature, and it sends it back to your app. That'd be kind of cool. This all in one. Yeah, that's what I'm doing today. Trying to. I'm 4 hours in, and we're only up to like day 14. It's not going to happen. It's not going to happen. We can go to the next. We've written all this out. We can go to the next one. When should you use extensions in Swift? We're talking about extensions. Okay, so we're up to here. Yeah, so I haven't updated the little counter. We've got day 11. I got to change it to... I'll change it, like I said, I'll change it to day 14 when I get there. And I'm going to set chapters on this video when I'm done. We'll see how we go, yeah. I'm going to try and make it to 8 hours at the minimum. And if depending on how, like if things are pick up and they're going much faster once we get into the SwiftUI stuff, I'll try and hang on. I think the maximum I'll do is 20 hours, but we'll see. I don't know what even YouTube lets you do. Like if I go that long, will it just wipe the video when I finish? Don't know. I guess we'll find out. But this was, so I got 1,000 subscribers, and this was my promise to everyone. I said, if I can get there, I'll do a stream where I try and get through 100 days of SwiftUI in that time. That's what's happening today. It's a celebration stream. And it's heating up today. It's supposed to get to almost 40 degrees Celsius, and I'm worried that my camera's going to shut off when it gets too warm, but we'll see. Let's moving on. Oh, let's just text. Conformance grouping means adding protocol conformance to a type as an extension, adding all the required methods inside that extension. This makes it easy to understand. Yeah, I don't really do this very much, but I should be doing it. So in that previous example, what we had before, we would want to implement these in an extension, like maybe so we don't have to, not these so much, but maybe functions. We want to like set up their functionality. Maybe in the protocol extension, maybe one of these or something. Like if we wanted to do like a price conversion or something, right? We wanted to change it to a different currency type. We would put that up here and not on this object. Okay, let's keep going. Yeah, this stuff I should be reading because, like I said, or there's a quiz at the very end, and I may fail if I'm not. There's a lot of changes. A lot of changes that happen to Swift that I'm not completely up to date with on everything. It changes too quickly to be up to date on everything. So when I answer the quiz later, I may answer it the correct answer for what it would have been a couple of years ago. I noticed that on like freelance websites, you can do like certificates for Swift or Objective-C and things like that. And those are usually outdated. So I have the opposite problem. So I'll place in an answer, and then what will happen is it'll be wrong because it's like my answer is more up to date than the one from the quiz that Anyway, impressive. Good luck with that. But actually, the days get harder and harder, especially the challenges. Don't tell me that. Oh, yeah, okay. Thanks. Maybe, look, I'll go as long as I can. It should be entertaining anyway, either way. All right, protocol extensions are used everywhere in Swift, which is why you often see described as protocol-oriented programming language. Yeah, don't fight this stuff either, by the way. Like if you come from a different background, or you're using Objective-C or some other language on some other platform, don't try and like use their architecture and stuff in Swift. You're not gonna have a good time trying to fight the system. For example, Swift arrays have all satisfy method that returns true if all the items in the array pass the test, so we could create an array of numbers and check that they are all even. Yeah. So if we run this, oh, okay, we need to print the output. False, because there is a 15 in there. All right, that's really useful, but wouldn't it be more useful if it all also worked on sets? Sure it would, and that's why it does. I'm not going to copy that. The underlying principle is identical. Pass each item in the array or set through a test you provide, and if that returns true for all items, then the result of the method is true. Cool, how about dictionaries? Can they do this too? Sure they can, and it works identically. Oh, let's do this one. Dictionaries are such a pain to write. Yeah, we got to do it. We got to write it all out. That's the whole point of this. Gosh, I almost copied it. Almost copied it. Okay, I mean it's difficult for my level. Let's put it like that. Oh man, I'm hoping I can pick up some speed when we get to SwiftUI. I said earlier in the stream that the bit that takes me the longest is looking here, then looking over here, then going back and forth and trying to, if I can see like an instruction that's like, do this, I can just sit here and just write it all out and do it. I'm hoping that there's bits like that. Have you done other programming before this? Did I ask that already? Is this your first time? False. Yeah, we were 15. This isn't value. Oh yeah. That's easy. It's not really doing it on a dictionary in a sense. I mean that's on there, but we have to, because we can set this to key as well, and this won't work because it's on integer. But yeah, that's pretty cool. All right, let's drop that. How is my dog's going off? How is protocol-oriented programming different from object-oriented programming? Where are we at now? We still got to do optionals. That's coming up, I'm sure. We can skip this. I don't want to read through that. Why does Swift have optionals? Again, more important information, but gosh. Okay, so we're up to optionals, and that is day 14. So day 14. All right. 2 more, and we're on to SwiftUI. Any data type can be optional in Swift. An integer might be 0 to -1, 500, or any other range of numbers. Optional integer might be all regular integer values, but also might be nil. It might not exist. Yeah, optional is a type, right? Let's say that. Oh my gosh, my dog. Okay, I did Android with Java and working now as QA automation with Robot Framework. Oh, okay. Well, you got experience then. My dog will not shut up. Um, yeah, Android with Java. Yeah, cool. Whoa, Java. All right. So yeah, you've been doing this for a little while. I don't think I have much of a problem finding work, honestly. People are pretty desperate at the moment. Um, and yeah, the lack of there being senior devs around. Most senior devs are in a job that they enjoy, or they're working for themselves, like me, and don't want to do contract work or full time work. Um, so there's going to be a point where companies are going to have to lower their expectations a little bit. Optional user struct could contain all those same properties, none exist at all. Yeah, cool. We know all about these. Why does Swift make us unwrap optionals? Swift optionals can either store values such as 5 or hello, or it might be nothing at all. Yeah, so there are several ways of doing this. Swift, but most common is if let. Yeah, let's do a little get. Still won't get over how weird this looks with without a return in there. Print username is username else print no username. Excellent. Let's run this. Yep, username is Taylor. Great. If we set this to nil, no username. Yay. Excellent. That single if let line combines lots of functionality. Yeah. I can't remember, like early on, did we have this very early on in Swift? I feel like we didn't. Like it was not this convenient back then. Could be wrong. When to use guard let rather than if let. What do we got over here? We've got optionals, nil coalescing, checkpoint 9. All right. Excellent. Next function, get meaning of, whoops, of life. I should reread this book again. The Hitchhiker's Guide to the Galaxy. It's been such a long time. I haven't read much sci-fi for a while. It's been all fantasy books and stuff. Reading Lord of the Rings again and again. Exactly. If you look to junior jobs, the request 3 years of experience for real. Is that considered junior? No. I have a very different opinion on all this stuff than everyone else I chat to on Twitter. I get into arguments about it, like, I think I would class. I don't know. Maybe only because I think because my experience was different. Maybe I was like an outlier. Like I just did really well as far as like picking up things quickly. But other people I've worked with have been juniors. I've been really impressed with some of their stuff. Like why is this guy junior? Is it just because the company wants to pay him less or something? But like I've worked with some people who've been really brilliant. That should not be a junior. And at 3 years, I don't think so. Honestly, I think 3 years is senior. A lot of people will disagree with that, and they'll say, no, you got to be 5 or even 10 years to be a senior. It's like, I was making senior resumes when I was 2 years in, and I don't think I'm like, it's not me being, I don't think I'm particularly clever. Speaking of life, my life depended on it though. Like, I moved away from home into another state, another city, and I had nothing, so I had to kind of like hustle my way. I had to, like, when I finished my work, my day job programming, right, like doing a junior role, I'd come home and continue programming. Like I had to, anything that I did not learn that day, I had to come home and relearn it because I did not want to be in that particular job I was in. It was like, there was like 3 of us in a little studio thing, office somewhere. It was the only job I could get at the time, where they didn't actually do any proper evaluations. And man, we're making like little video game apps for iOS, iPads, like kids games. and just like trying to get them made and put out there so they can make some cash as quick as possible. And yeah, anytime I run into anything that I didn't know, I'd go home and try to learn it, because I wanted to build up those skills so desperately I could get somewhere else and get a better paying job. Sometimes it's funny in life, like if you aren't challenged to do things, you just won't. Sometimes you just won't do them. You get complacent, right? What have we got here? Hang on, let's go through this real quick. But yeah, I reckon you could be a junior just after like 8 months of work. You do a little boot camp or you do this course. That would set you up for junior level for sure. And then yeah, you should be okay to like apply for junior jobs. And don't worry about the time. Everyone learns at different pace too. Like you could have someone who's learning programming for 10 years and they're terrible at it. I don't think a number of years is a good indicator. And then you like you said, like you have people like me who this is all they do, all they did learning, right? Every hour of the day, they're just desperate to make sure they get something, get those skills together so they can get a job as quick as possible. Because if they don't eat. And I would say that those people would get the experience necessary well within 3 years. If we had written that using guard let, it would look like this. Oh yeah, let's do that. And move that out. And what I like to do with these is you do a little return. I wonder when we're getting rid of return there. Surely someone's already put a pitch forward for Swift where it's just like, we don't need that. If there's nothing in there, is what I'm saying. If there's nothing in there, that should be valid code. If anything, this should be valid code. I'm pitching this to the Swift development team right now. This is what we're doing now. No, not even that. Let's get rid of the else as well. We just need the guard. That's it. And this will exit early. Yep, that's my pitch forward. Let's get rid of those curly braces and then return. Oh no, what have I done? So basically you hard worked on yourself. Yeah, I want to ask you about technical iOS interviews. Is it live programming or give you tasks with specific template? Handler usually goes, oh, it depends. I've actually done both in that setting. Like I've given people exams to take away, and then I've given people tests to do in the room during the interview. I think the last couple of times I've done that when I was working for a company and hiring, I didn't even bother with either of those. I just went through their GitHub, like, because I was hiring seniors, right? And so, and most of the people that I hire now or used to hire were people I kind of already knew in the industry, like, because it's quite small. We got like little chat groups going on that we do. Like in Melbourne, there's one available, and there's like, I don't know, a few 100 to 100 of us that are on there, and then you sort of get to know everyone. And then it's like, well, you put a job up and it's just, yeah, you can come work for us. We'll just have a mini interview, make sure that if you got any questions about the place, the culture, things like that, that gets sorted out. But beyond that, it's like, we don't even test the skills. But yeah, when you're starting out, the most common one is the take-home assignment, not the in-person. So they won't do in-person tests. So usually when you get a take-home assignment, you'll get given a weekend to do it. It'll be like an app, or maybe you need to debug an app they've already built. You need to clean up the code. Maybe it's a code review they want you to do. And then you go in, you hand it in, and then you go in for your interview, and then they'll ask you questions about it, about the project you built. Other times, yeah, I have been given a test once, like on paper, like school. Someone's had all these Swift questions and I had to fill them all out. That happened once. Other times it's always been, if there's been no test, it's just been a conversation, and then they just ask technical questions. So nothing written on paper. They just ask me stuff. Like this kind of thing that we're going through now, right? Like all this sort of thing. They'll just be really simple stuff. What's the difference between a reference type and a value type? That kind of stuff. How does memory management work? In live interview, I will 95% less efficient. I will forget everything. Task is better. Yeah, I agree. And early on, I much more enjoyed doing the take-home assignments for apps and stuff. These days, no, because if you are applying for like 50 jobs and they all ask you to do a take-home assignment, you cannot do all of them. It's impossible. And most of the time, they're the same. They're like build a weather app. The exact example that I gave before. Yeah. So these days, if I apply for a job anytime in the future, which I don't think it will be, I'll bid on projects and for clients and stuff and try and get clients that way. But if anyone ever says to me, you got to do a take home assignment, I'll be instantly no, because at the point now I can just sort of make pick between companies and clients at this point. So yeah, I usually say no to those sort of things because at this point they're kind of a waste of time. But when you're starting out as a junior, that's the sort of stuff you kind of have to do. But yeah, to answer your question, you get much more take-home assignments than you do live coding. Live coding I have done once as well in an interview. So questionnaire once, live coding once. Most of them are take-homes. A few of them are technical questions, and I think almost all of them, except for those other two, were technical questions and take home. Right? Now, the worst thing about the hiring situation is that like you apply to a job, and then before even getting to have a conversation with anyone there, they'll be like, okay, cool, got your resume. Here's do this assignment. But what if you don't even like the company? Like, you don't know that until you talk to them, right? So let's say you do the assignment, you spend a weekend doing that, and you go into the interview and you find out you hate the people there. You've just done all that work for nothing. So in those cases, I turn it down as well. I just feel like, no, well, can we have an interview first? Have a chat, at least on the phone. I want to ask some questions first. And then, and if I'm down with it, yeah, give me the assignment. I'll complete it, and then we can have a follow-up interview. I don't know. Okay, so what do we got? What have I done wrong here? I've done nothing wrong. I just need to call print. No, I just got call print meaning of life. There we go. Yeah, live interviews are really difficult though, because yeah, you do tend to forget. Sometimes they ask you questions that aren't even about iOS development. They'll be like, oh, solve this puzzle, this programming puzzle. It's like, how often do you solve programming puzzles in iOS development? Never. How often did you solve them in Android? Like, every day you go to work, there's a bit of a puzzle you gotta solve with your code, and you come up with solutions, but not like some of those tasks that get you to do, which is like on leak code and stuff. It's not a thing. And then they phrase it as like, oh, we need to know that you can like think technically and you can solve problems and stuff. And it's like, I wouldn't be where I am now if I wasn't able to do that. Don't want to make a bad hire. It's like, well, just fire me. If I'm a bad hire, just hire me and see how it goes. I don't know. First, this code creates you. Okay, so we've got optionals. When should you force unwrap optionals? This is URL is a good example of this. For the longest time, I've tried to avoid force unwrapping these, and then I saw that like everyone does it. So I just started doing it too. I'm going into more detail in a moment, but I want to give you some examples of code I'm happy to force unwrap and code that should not be forced unwrapped. Yeah, these examples are drawn from real-world Apple APIs that you might not have met yet, but that's okay. You get the idea. First, this code creates a URL from string. I'm not going to write this out because we're not doing anything with it. Force unwrap. This is a hard type URL and have verified that it's correct. HTTPS. So I think if it's missing the scheme, like if you just put a bunch of characters in there, it would probably fail. URLs are tricky because they can be like a path. Yeah. This one here, this is a hand typed URL. This cannot go wrong at runtime. Yeah, runtime, and there's no scope for surprises. I don't know if it says in the documentation on this what would constitute as a fail. I haven't read it in a long time. But yeah, this is the way to do it if you're typing it all out by hand. I think some parts of Apple's code will tell you if it's safe to force unwrap or if it's not, but it doesn't say that. It doesn't specify everywhere. This is a hand type URL. Yeah. Compare that to using string interpolation. Yeah, so this could be broken. This could have characters in there that aren't valid. This isn't safe and can't be verified, and if given a malformed web address could crash. Yeah. This code creates a closed range from 1 to 10, then picks a random number from that range using the random element. This here, this should be safe. But if you were... Yeah, you can't do it this way. Yeah, that makes sense. Because if you're making changes to what's in this array of items, this could break. Hang on, we got all cases, random element. That's fine. No sensible alternative. For example, if you make an enum conform to the case of a perfect, Swift will generate special all cases property array. So we create a direction enum and pick a random like this. We've defined an enum of all cases and we're asking to pick a random case. Returns an optional because that's how it works, but we know it will always succeed because our enum has cases. Yeah. Right. For example, we could write our own direction enum like this. Yeah. Yep. It's a pretty good way of doing it. With that in place everywhere, we get random direction. No longer need to force unwrap. Yeah. Excellent. It's nice. I like doing these little bits of code. It's super nice to have that scattered around to make the call sites easier. Yeah. Why does Swift need both implicitly unwrapped optionals and regular optionals? Where are we at now? We've got still got to do nil coalescing, and we've got Swift review. Do we get a quiz? Why does Swift need both implicitly unwrapped optionals and regular optionals? Implicitly unwrapped optionals can contain a value or be nil, and regular optionals can also contain a value or nil, but there's a subtle difference. Implicitly unwrapped optionals don't need to be unwrapped to be used. This means if you attempt to use an implicitly unwrapped optional and it's actually nil, your code will just crash. Yes. Oh, I love IUOs. It's just so wordy. Implicitly unwrapped optionals, but won't be empty by the time you want to use it and will stay not empty for the rest of its life. In this situation, they are by definition safe to use without carefully unwrapping because they will always have a value by the time. This whole optional thing was so confusing to me when I first started learning Swift. Yeah, that's going to be on the quiz, and I'm going to get it wrong. When should you use nil coalescing? Oh, this uses all the time. Oh, we can't do that. This doesn't exist. That's another thing. Okay, so for example, if you're working a chat app, wanted to load whatever message draft the user had saved, you might write code like this. Yes. So if load save message returns an optional with a string inside, it will be unwrapped and placed into a saved data. But if the optional is nil, then the Swift will set save data to an empty string. Otherwise, save data will end up being a string and not a string optional. This is one of the things too, when you're checking for errors and stuff, you know, the compiler will be like, oh, you know, string does not equal string question mark or something. It's easy for me to just read quickly and not see this part of it. And then so the compiler's just like, the error saying string is not equal string. And I'm like, yes, it does. String is equal to string. It's the same type. What are you talking about? And it's like, I just missed, I didn't read the little question mark. And it's even worse if you've got like a dictionary or you've got all these nested types and they appear exactly the same, except there's somewhere in the nested type has a question mark and not in the comparison. You can chain nil coalescing if you want to, although I don't think it's common. So this kind of code is valid if you want it. Yeah, I actually do this. Not as common, I would agree. Like if you're comparing this to this, yeah, absolutely not going to be as common. But I use this quite often. Yeah, sometimes I'll have like, Yeah, so like this save data, like the first name, last name, and then yeah, you add nothing or unknown or something. What will attempt to run? It will this that will attempt to run first, and that returns nil. Attempt to run second, and if that returns nil, empty string. Remember, reading a dictionary key will always return an optional. So I might want to use nil coalescing here to ensure you get back a non-optional value. Yeah, we're not going to write this one out. This is pretty self-explanatory. Like, if I was learning, I'd be like, oh yeah, this makes sense. Because it's just like a reiteration of what we're doing up here. Rehash. Re-explanation. This is definitely a matter of taste, but dictionaries offer a slightly different approach. Let's just specify the default value for when keys are found. Yeah, this is something I learned today. I've always done it this way. This is something I learned today, which is kind of cool. This is definitely less wordy. I wonder which case I would do this. Why I would do this, or what the motivation behind doing this was. It's interesting. When reading dictionary, there's values. There's no real difference. Yeah. Why is optional chaining so important? Okay, optional chaining. Optional chaining is so cool. As a simple example, we might have a list of names and want to find where they should be placed. I'm not going to write out all these names. We got to keep moving. Surname, letter, names, Vincent, first, uppercase. Yeah, this. So you got these little optionals. We'll go through it. We'll just do a little quick explanation right as we go. And this is still going to be optional, right? Because we're doing all these chains, this will still be optional. Returning to our surname example, we could automatically return question mark whenever it'll read the first. Yeah, so then you just do a little on the end. Yep. How cool. All right. So you could just keep chaining these things forever, right? Because it's a string, I think you could just keep chaining the exact same because it returns a string. You go uppercase, uppercase, uppercase if you wanted to. Okay, when should you use optional try? This I use a lot. I shouldn't, but I use it because I'm lazy. Yeah, which is exactly this. So you write your do catch. Using optional try means you don't have to worry about any of this. And I generally write the code like this if I'm doing like let's just grab this example. If I don't want to uglify my code with the do catch, and I don't really care if it fails, I'll keep it all in line, right? I won't do if let. I'll just have let, and then I'll just keep going on with the rest of the process in the class or whatever the code that I'm doing. If I'm relying on this, well, this will be an optional, right? So then maybe I'll go print result, and let's pretend this is a string that I've got back out at the end of this. Uppercase. So I'll use it as an optional if I can get away with that throughout the rest of it. If I don't care, like if I'm not going to present an error to the user or anything like that. Usually when I'm using these do catches, a lot of the time I'll show an error to the user, because a lot of the functions that throw are quite important. Some of them aren't, and when they're not, I just use the little question mark. Why would you want a failable initializer? I love failable initializers. These are good. Yeah, you put a little question mark in front of the parentheses, and you can return nil in. Yeah, you can return nil inside the initializer, which is great. This cleans up. So you can set you can say it needs to have at least this many characters, which is great. This is a good example. I don't think I could think of a much better example in this way, but it's also not great in the sense that it's not giving you a reason why it failed. Right? You would probably want an error message to show or to throw or something and say, hey, password count is incorrect, so that you can present that to the user and say, hey, you need to have at least this many characters, rather than it just come back nil and then you just like, oh, I don't know what happened. We can try that out with 2 example employees. it doesn't. We haven't got any print statements or anything yet, so I'm not typing anything in here. Cool. When is typecasting useful in Swift? Typecasting lets us tell Swift that an object it thinks is type A is actually type B, which is helpful when working with protocols and class inheritance. There are some types that you can just switch between them quite easily. And it can also work if you need to. So like if you're doing inheritance and stuff, right? And you've got a class or something at the top level, you create an object with that. No, you got an object that's lower in the inheritance hierarchy, right? So it's inherited from something further up, but the function only takes the class that's further up. When you get that item back, you can actually just like it'll come through as being maybe we do a little quick thing. My class. There we go. Subclass. My class, and then let's say you've got a little function that takes my class, which is my class, and it returns my class. Right, it does something in here. Does something, and then in here you've got you want to create a let's call it an object. That's kind of what it is, and this is the subclass, right? This and then you come down here, you're like, all right, let's do takes, and we go object. This works. What we got? Oh, I'm going to do a return my class. Let's pretend it does something to it, right? And then we return, and this is great because it will return. It passes in this, which is the subclass, and we get this item back. But if we print the modified, let's say modified item object. So everyone probably already knows where I'm going with this. We should probably put this is gonna get way too complex. Cannot override. No initializers. Yeah, we've got to add those there. This is going to be. This is getting beyond the example I wanted to make. So on here, we only have access to property 1, right? Because we've created object subclass. It's gone in to my class and it's come out as my class. So this is done like a cast, right? It's cast. So anything that is a subclass of my class can go through into this function. And a subclass is a subclass of my class. Confusing. But because of that, we've only got access to this property now. We can't go object.property2, right? We don't have access to that anymore. What have I done here? So to get access to that again, we have to cast, right? So we have to go, where is it? Modified object. See, we don't have property 2, we only got property 1 because it thinks it's this, even though it's actually this. So we need to go as, we can do this forced as subclass. And what I can do is we've got to wrap this. I know we're going to go through this in a minute with Thingo, and then we've got access to the property 2. Yeah. Anyway, that was my little example. Let's see what example we get in here. Which is basically the same, right? I've used the default values for each property, so we don't need to write initializer. Excellent. We can create an instance of each of those and add them to the same array. Yes, they're both inherit from person, but they're both different. And this means we can call name on anything in that. I did this earlier. I did this earlier. We won't write this out. I did another example of this when we were talking about protocols. Oh my gosh, are we done? Are we doing a review? Understanding Swift. Answer the most common questions people have while learning Swift, provided details and hands-on answers plus links and more. It works great alongside free 100 Days of Swift series, but you can also read it directly. What's the difference between... Wait, what have I done? What's this link? Table of contents. We've gone back. Have we gone back? Oh, thank you. Looping, functions, closures, structs, classes, protocols, optionals. We're done, right? What's this review? I think we need to... Bonus, find the Swifty words. Download... I made a word search to help you test your knowledge of the most useful terms. Oh, I can't do the bonus stuff. Show your progress. Yeah, okay. Oh, okay. Yeah, can't wait to start the SwiftUI. Yeah, I am getting tired. All right, days 16 to 24. Okay, so I'm going to skip past 15, I guess, because there wasn't much to do in that. Let's open this. Excellent. So these, yeah, okay. Right. So does this mean we need to set up a new project? Give me a second. Let me change this. Day 16. Okay. Now that you've mastered the basics of Swift language, it's time to start applying your skills to some real code in our first project. Project is a check sharing app that calculates how much please check. Okay, cool. All right, let's just let's project. I'll do this on the other screen. I just gotta work out. Today you have 7 topics to work through, and you'll meet 7 topics in one day, and you'll meet form, navigation, view, state, and more. Okay. Oh gosh, intro. All right. Hands-on introduction to the techniques you'll be learning, step-by-step guide to build a project. Cool. All the projects building is through. Okay. Understand the basic structure of SwiftUI app. What are we doing? How do we create a new one? Does it tell us how to create a new one? And inside so see the following files in place. When you create a new SwiftUI app, you get a selection of files, maybe 20 lines of code. Okay, app. Okay. 100. Let's call this 100 days of SwiftUI. I'm just going to keep using the same project, I think. What we got? Let me keep that over there. We might have to tighten this up a little bit. So I've got an ultra wide monitor, but I can't pull it further out. You won't see it. Can we do this all on one screen? Maybe we cheat a little bit, and if it says like, you know, save a bit of time by just really like getting through this quick. We don't need to worry about the structure. Yeah, we got all that. That looks pretty good. It's a little bit different. Keep going. Fourth text. Yeah, I want to build these projects. I think this will where we might pick up some speed, hopefully. You can create a basic form just by wrapping the default text view like this. Yeah, so let's get rid of this image, and then we just change this to form. Yeah, there we go. Okay. You can remove the padding too. Yeah, we don't need that anymore. You can kind of see, what if I change it to, doesn't make much difference. Okay, keep going. And we can keep doing the same thing. Give some extra rows. Cool. Oh, is it going to get us to do a for each, a loop? Oh yeah, that's right. It will say you can't have any more than like 10 or something, 11 things. If you want to have 11 things in form group, you should do a group. Yeah, why not? Can I? Is this a thing that's going to let me do? No, you can only embed one. Can you only embed one? Yeah, it's only let me do one. Group. That's okay. Cool, and this will this should compile now without issue. Okay, we can do sections. Let's copy that, throw that down there. We've got 2 sections, cool. And then oh yeah, you can put title in here too. So a little bit of text in the section. That's cool. I want to ask you about core data. How you usually set up in this course. I feel Paul did do it in a very weird way. I'm not sure yet. I'll have to. I mean, as far as he did it in a weird way, I'll have to see that for myself when I get to it. But I kind of use like Apple's approach. So when you set up a new project with core data already set up, I just use that. So maybe take a look at that. Go create a new project, select the box for core data. Maybe he sets it up so that like it's a blank project and says this is how you add it into a project. That would make sense from an instructional point of view. How to add it to an existing project. That makes more sense. And maybe that's why it's a little bit weird. Adding a navigation bar. Adding a navigation bar. Oh, we can do that easily. Let's just grab all this. You can embed in. Come on. Doesn't matter. VStack works fine. Navigation. What have we got here? Form section. Navigation view. Yeah. So this is out of date a little bit now. Like you can still use it, but everyone's using navigation stack these days. As of iOS 16. So this is still relevant if you need to target iOS 15 and 14, which most people do. And we can set up navigation. Yeah, so we can do, come on, is this? So what we need to add here is, yeah, there's our little navigation view, and it sort of moves up when we scroll. And this scrolling functionality comes from the form. Okay, we get scrolling from the form. Navigation bar. Title display mode, and we want to go inline. Yeah, we can do that. And then it just pins it up to the top. That's great. The weird thing is, this is what I was talking about before when SwiftUI is a little bit tricky, because if you add navigation title to the navigation itself, it doesn't work, but it lets you do that, which in my opinion is very dumb. It shouldn't let you do that. It should say, hey, don't add. It's because this returns view, right? And this is a modifier on view. So there'll be an extension somewhere in Apple's code that has, a navigation bar title display mode can be on anything. I get why they should all like this is incorrect. This is text. We got view. The form is a view as well. It'd be nice if they were typed in some way so that you can get an error when you try and do these sort of things, that it doesn't work. But I guess in some cases, maybe you want a navigation stack inside a navigation stack, and it would be important to be able to have that on there. I don't know what the solution is, but I think it's silly that people new to it can add this stuff in and have it just not work. I still use navigation view. What's the difference? Yeah, right. Yeah. So just, that was a reaction to what I was saying. Yeah, exactly. It's weird. You can do all sorts of stuff with different views. Setting a background color on a form. I don't even think this works. Does this work? I know it doesn't work on lists. No, so you can't even set a background color on a form. Bit silly, right? But you can do it like there. That works. Instead, I think the new API, row background. Does this work? Okay, well this works on list. Oh, list row background. Can we do form row? No, we can't. Okay, so yeah, silly stuff. It lets you put it there, but you can't. It doesn't work. Okay, so I still use navigation. What's the difference? At this very moment, it gives you some extras, but there's not really a big difference. You can still use navigation view. If you want a stack, you just say navigation view style, and then you throw stack in there, and that'll give you a stack navigation view. It's just an updated. If you went through all your apps now and changed it, I don't think you'd see much of a difference. It makes it easier to do like the whole split view screen stuff as well. I think they revamped that a little bit. Okay, next. Oh, next page. Modifying program state. We're at project 1, part 1. Yeah, this is going to be tricky to create form, navigation bar. Show your progress. Is this one day? Day 16. Okay, this isn't too bad. I can get through this pretty quick. Oh, my dog's going off. I can get through this pretty quick, I think. If I don't stop to explain things. What do we got here? Modifying program state. Oh yeah, cool. So all this will go away. Let's go with let's do a button. Tap count. What do we got? Need that in here, and then we got to go this tap, which we don't have yet. I know. What's wrong? What have I done wrong? Oh, it's not mutable. You have to mark that as mutable to make that work. Yeah. But we're not doing that, are we? We're going to change this to state. That's what we're doing. Cool. Come on, give me a button. Now we keep tapping. Anytime this value changes, because we marked it as state, it will redraw the view. Or it redraws... I think it redraws the entire view. Yeah. Anything in this body. This can be on. Cool. Well, we can mark them as private. Cool. Add private access to the control of these properties like this. I can't really see how... I guess it makes sense because if you were to call content view, you can pass through a value if you make it private so that can't happen. Binding state to user interface controls. Bindings. Yes. Oh, cool. Okay, let's go with form. Right. Text field. Enter your name. If anything, out of this exercise, I'm hoping that I'll get faster at writing code. Kind of forcing myself to do it here. And then we've got the var name up here, which will end up being a state, I'm sure. It's empty. And then we need to pass through, text. And we use this little, so this will fail, right? This should fail. Yeah, I'm not gonna bother with the example of. Come on. Build. Excellent. What else are we doing down here? We've got a name, text name. Yeah. Yes, text. Your name is. Let's copy that and put that here. I think we can get away with copying stuff a little bit now because we're kind of like building projects. And then let's do your name is, start typing, and look at that, it updates. Excellent. All right, next, creating views in a loop. This is a form. I wonder why we went with form instead of a list. Nicer formatting, I guess. 0. 100. This will fail, right? Text row number. Oh, this works fine. Oh, it's smart enough to know you don't need an ID because it's a number. If it was a string or something, yeah, that makes sense. Because for each passes a closure, we can use shorthand syntax for the parameter name, like this. Like what? Oh yeah, that's true. I kind of avoid that when in SwiftUI. I like to have the name here because a lot of the time I do something with it, right? Or I do something else with it. Like I'll make changes to it, or have multiple uses. Like I might have a for each with another for each or something in there. It's good to have the names in that case. Okay, keep going. For each is particularly useful when working with SwiftUI's picker view, which lets us show various options for users to select from. Cool, let's do that. Navigation stack form. Oh yeah, the biggest major thing I hate about SwiftUI. I love it, but this is the thing I hate about it is the amount of all these. That sucks. UIKit doesn't have that. I mean, you still do it in UIKit, but it doesn't have that as a problem. Selected students. Let's just copy that. And up here we go. Oh, let's do private var selected student. And we go equals. That's extra space is annoying me. Okay, that's students. Do we get to do enums? I wonder. Oh yeah, of course it's wrong. And then in here, yeah, we've got for each student's ID. He'll explain why we need the ID. What is it? Self. Is it self? Yep. And then in here we need to go text, and we'll just go $0. Come on, let's do it. Picker. Tap. Yep. How cool is that? This looks really good in a form. That's why he's gone with form. Yeah, that's awesome. Okay. Let's keep going. All right, we got another one here. What is this? When you're ready. Oh, okay, clean slate. All right, let's do it. Let's just copy this. I think that's the intention. Reading text from the user with text field. Modifying, binding, creating views in a loop. We just did that. Are we up to 17? I just want to double check. Wait. Reading text from the user with text field. Is that this one? Reading text from the user with text field. I caught it just in time. So we're up to day 17. Day 17. Okay. We're almost a fifth of the way there, and we are 5 hours in. So 25 hours. On out is how long until I finish. It is getting so warm in here. I can't open the door because my wife's in the other room. I'm streaming, so what can I do? Let me check the temperature outside. Maybe I can open a window. No, it's warm. Oh gosh. If it gets really bad, I will have to stop early, I think, and go sit in the air conditioning. Hello, focus. Thank you. Okay. Okay. All right, what do we got? Start by adding these 3 properties to our content view struct. I'm going to grab these like this because this is going to take way too long to type out. Of course, I mess it up. Of course, some people prefer to leave a different percentage of tips, so we're going to let them select. That's a good idea. Excellent. These will not change. They are lets. And then we'll just build this up. We'll go form, section, text field, and amount, and the text check amount. Yeah, we can use numbers in here, can't we? Can we? No, we can't. I didn't think we would be able to. What have we got? This isn't going to work. Yeah, that's what I thought, and that's okay. The problem is SwiftUI likes text field to be... So we need to use a number formatter. Yes. Oh, yes. Excellent. Format. Oh, where's my code completion? At some point, might have to restart Xcode because it will drop completion at some, you know. Text field, what have we got? What's wrong? What are you complaining about? Better solution, ask iOS. Is it summer now in Australia? Yes, very much so. It is absolutely summer. What have I done wrong here? Check amount. Currency code. This might be... Hold up. Format. This API may have changed. Hang on a second. Check amount. Let's go text field. Text field. Let's see what we've got in here. I think we've got formatter. That's the one we're looking for, right? Formatter. Formatter. Sorry, everyone. I'm gonna work out what this is because it's a bit text field. Come on, it's a bit out of date. Title, key, value, formatter. I don't think currency is a thing on there. I think what do we got? I don't think this works. Let's just grab this and see. Yeah, we can't use that anymore. This does not work. I wonder if this... Can we report it? Unless someone can see I'm doing something wrong, right? Because this is formatter. I think we need to go... Oh, I think what we need to do... Formatter is a I think this is a protocol, right? It's an abstract class, so this is inherited, so we can't just use formatter directly. I think we have to go number formatter. Or, you know, number formatter then currency. So number formatter. Oh, wow, how do we do this? I'm going to just do a bit of a search for this. Give me 1 second. Currency text field in SwiftUI. What have we got? No. Okay, what is this? This is a bit of a slowdown, isn't it? Maybe I've just done something wrong here, right? Is this working? What did I do wrong before? This is fine. I thought it would be, but... Let me see what the heck I was doing wrong before. Nope. Oh, it's gone because I undid. Hang on a minute. Let me see if I missed it. I'm just a moron. Format. There it is, right there. Yeah. Look, it's right here. I missed it. I was like, oh, let's go formatter. I'll grab this. It's right there. You know what? I'm going to try your code anyway. I know we got it and there's a delay, but I'm going to try your code anyway. You missed. No, your code doesn't work. No. Doesn't matter. But now I'm unsure of myself. Maybe your code's fine and I'm just doing something wrong. Oh well, we got something happening here, okay? Wow, that was brutal. Alright, we gotta pick up some speed. And it wants us to do sections. Yeah. So the next one is, so we got a mount. Demonstrate this, we could add a second section with views. That does almost exactly the same thing as our text field. It asks if you are to format the number as a currency using the system default or USD if nothing else is available. Main is text, just take the format. Oh, yeah. That's okay. Yeah, need text field, yep. Okay, that's all good. So what do we got here? We got form, section. Okay, so is it telling us to fill that in? Yeah, and we do want this format here. Yeah, I don't know what I was doing wrong before because I had this layout before, but I was thinking maybe did I have text before instead of text field? I don't know. Yeah, and we want to do the keyboard type. Makes it a bit easier for people to type in numbers. And I think, does it say anything here? Our text field has two-way binding to the check amount property. Yes. Currency code deprecated in iOS 16 renamed currency.identifier. Yeah, let's fix that. Do another run through. What we got? There we go. It's a little bit messier though. So identifier is a little bit longer. Yeah, okay. Yeah, so this gets the currency that the user's device is set to. Okay, that's why we're doing that. I think for the purpose of this, keep things a little bit cleaner. Let's just go straight with USD. When a state probably changes, yeah. So this is all a bit of a recap. I think what we'll do is type this into No, I added format first, and then I changed it to formatter because format wasn't working for me. I have a feeling like maybe I had a typo in format. Like maybe I had two T's or something. I don't know. The value was spelled incorrectly. Because yeah, the format wasn't working for me, and I went through this. I was like, oh, this is. I picked formatter and didn't even see that format was there. Yeah. Oh, we'll just use the same currency. Can you tell I've never used this API before? I hope it's not that obvious. Format, currency, code. Alright, we've done something wrong here again. Oh, check amount. Check amount. Text. There we go. And they're both the same. Yeah, awesome. Because I think what's going to happen is we'll make changes here. Yeah. And the other one will update. That looks good. Okay, I think we're on to the next section. We've got decimal pad. Yep. Okay, creating pickers in a form. Where are we at? As far as day 16 goes. Creating views in a loop. We're up to day 17. Pickers in a form. Okay, so we've got 3 more to do for this day. Alright. And then we can move on. Section. So this is the amounts one, and we're going to add another picker in here. Number of. I'm hoping we can do most of these projects just in, like, without running it on a sim. That'd be really cool. Number of people. For each 2 100. It's interesting that he likes to put the gaps on these. I don't do that. Okie dokie. Selection. We do, yeah, we do a little picker. I guess maybe they'd be 100 people. Hopefully spot several things. A new row that says number of people. Yeah. Number of people. For each 2 to 100. Well, when creating the picker, we use the for each view like this. This counts for 2 to 500 creating rows. What that means is our 0th row, the first one that's created, contains 2 people. Yeah, so although it's a bit brain bending, the fact that our UI shows 4 people rather than 2 people isn't a bug, but there's still a large bug in our code. What does tapping on the row do? Nothing. If you create a picker by itself outside the form. What have we done here? I also show a spinning wheel of options here though. We've told you, yep. What does SwiftUI wants to do, which is why it's added the gray closure indicator. On the right edge of the row is show a new view with the options from our picker. Oh, we didn't get that. I think, did we mess up? If we... No? Maybe the default behavior's changed. I could be wrong. Oh yeah, here we go. What SwiftUI wants to do, which is always added the greatest collision indicator at the right edge of the row. So directly before the form, add navigation view, and after the form's closing brace, you should look like this. This is, oh wow. Cool. If you run the program again, you'll see a large gray space at the top. Almost. Host giving the room a place title. We'll do that in a moment. First, try tapping on the number of people writing. You should see a new screen slide in. No, we don't. I think we need to set to do this to make that work. The navigation link. Yeah, so we have to explicitly set that here. And then we get the big list that it was talking about. Yeah. Okay. That's so nice that it's automatic too. Like as soon as you tap one, it just jumps back. Like how nice is that? Nice little interaction. Okay, navigation title. Let's do it on the form here. Navigation title. We split. Excellent. Done. Next, adding segmented control for tip percentages. Yes, let's do that. It's another picker. Yes, it is. In the middle of those two sections. Another picker. Tip per percentage. Selection. Tip percentage. Cool. That's for each tip percentages. Excellent. ID. It's funny they got to put this in there now, because before when you're just iterating over just regular numbers, it looks like Swift handles that for you. The ID. Like look at this. It's got numbers here, and it handles it for you just fine. You don't need to worry about placing ID, but here you do, even though there's a set of numbers up here. I think the main reason is because it knows that these are all going to be unique. 2 to 100. Like it goes for the range, and it's like, well, yeah, this particular format, it's like there's not going to be a repeat, and the ID, there could be repeats in here. Text. Oh, we can do a little picky pick. Excellent. Oh, these are in the wrong order. Pick a style. Segmented. Excellent. That should go to the end of the picker's closing brace like this. Yes, this is what we did. Amount, number, percentages, section, pick a style. What we got here? Oh yeah, let's add a little text. How much tip do you want to leave? That looks all right. This is how it looks in code. What we got? Oh yeah, we're gonna do a header. I can add that here though, because I really don't want to like. This is more code than required. I usually just use this if I'm doing like a V stack or H stack or something. I've got multiple things going into the header, right? How much tip do you want to leave? So I just throw it up here, and then we delete that. How much tip do you want to leave? And we got this little header up here, and it's all uppercase. Calculating the total per person. All right, so then we got one more, and then we're done with today. Total per person. Yeah, we're going to calculate that here. Cool. So let's start replacing calculate total per person with here. Yep. And we're going to wrap it in a double by the looks of it, because we need to... Oh, I wonder why we're wrapping in a double, because we're going to be calculating it against other doubles. So we need to change the integer to a double. I noticed that the converter is only a double because it needs to be used alongside check amount. Yeah. For the same reason, we also need to convert our tip percentage to a double. Tip selection. I'm gonna have to go get some lunch soon, hey. I don't even think I've got some snacks. prepared for today, but I'm really hungry. Like I'm feeling like I need something more substantial than that. All right. Replace return 0 with in the property with this. Yep. Tip value equals check amount divided by 100 times tip selection. Yep. Let grand total equal check amount plus tip value. And then the next one is let amount per person equal grand total / a people count. I think that's correct. And then we just return. Let's just return this. Save us a line. Okay. If you follow everything correctly, you should look like this. Yes, yes, yes. Replace this section, check amount. Where we go down here? This one here. With this. So we go total. Total per person. 11 people. Let's put some money in here. So we say $10. Split between 11 people. Oh yeah, that's really good. Okay, cool. This works well. I definitely need to go eat and maybe have a little walking. Yes. Yes, I do. I don't want to stop the stream though, so I want to like maybe come back and have a sit, and maybe I can do a little bit of a eat while we have a chat or something, right? Be a nice break. This all works well. Hiding the keyboard. Let's hide the keyboard. We're using focus state. Yes, excellent. Focus state, private. Are we going to use an enum for this? Probably not. Probably don't need to. Mount is focused. That's correct. Now we can attach that to our text field. Yes. So down here, underneath the keyboard, I think. Focused. We want the condition, and yeah, we go amount is focused. And then add this new modifier to your form below the existing. Yeah, so all the way down here we go toolbar. Toolbar item group. I haven't used the group before. Placement keyboard. Button. Done. Amount is focused equals false. Yeah, I like this implementation of it actually. It's kind of nice. We can see that the keyboard doesn't show in this preview, I don't think. I don't know how, if there's a way to make it do that, but you can see the toolbar here gets stuck to the top of the keyboard, which is super good. I'm actually going to use this to replace some code in one of my clients' apps, because at the moment we use like a dependency to make this, put buttons on the toolbar. Now you can just put like left and right buttons on there if you need to. If anyone's experienced with that watching, that there's like a dependency that everyone used in UIKit to add a toolbar above the keyboard. This just essentially replaces it. Tapping done should remove focus off this though, so this isn't working, right? Yes, you could. Yes. Hang on. What do we got going on here? We got placement above the keyboard. Focus. Maybe I need to drop this here. I wonder if it doesn't work in the previews. Do we have to? I really don't want to run this in the sim. Let's see. Focus. You need to attach this to a text field so that when the text field is focused, focus true, otherwise false. Modify. Text field. We did spell this wrong. That's okay. I'm going to assume that it's just a limitation of the previews. We split wrap up. I think we're done with this day. Add a header to the third section saying amount per person. Okay, let's do that. We got to do these challenges. It's all uppercase, doesn't matter. Okay, add another section showing the total amount for the check. Okay, we can do that. Section. Just when the view load, don't use physical keyboard. Then the virtual will appear. Yeah, but that's in the... Is that in the previews though? I know that's on the sim. Because as soon as I select it, it pops open. None of the shortcuts for showing or hiding the keyboard work in here, so I assume this is a preview limitation. We got text. This is the total. Total per person. Wait, didn't we already do this? Hang on, add another section showing the total amount for the check, i.e. the original amount plus tip value. Oh, I'm an idiot. All right, so we go the original amount plus the tip value. So the original amount is check amount. I'm just gonna do the calculation here, right? Check amount plus the tip value. Oh my gosh. Tip percentage is 20, so it's plus check amount Can we do this? This isn't going to work. Tip percentage, which needs to be modified, I think. This is taking a lot longer to compile. Oh, right. We need to do double. I might have to divide this by 100 as well. So if we go 10, 20%, this is correct. I think I did that, right? That looks pretty good. Change the tip percentage picker to show a new screen rather than using segmented control. And give it a wider range of options, everything from 0 to 100%. Tip, use the range 0 to 101 for your range rather than a fixed array. Okay. So I think what they want us to do is like 101. Like this, I suppose. I think that's good. We can also, I was going to do something else a little bit fancy here, like, but I don't think this for each can do it. Like have a modulo and just like if it's a multiple of 10 or something, just do it in 10 or 5% increments. But I think this works fine. Yeah, cool. I think we're good. Let's move on. Guess the flag, introduction. So we are done with project 1 part 3. Hold up. Have I skipped again? Wait. A second, though you have been using advanced features in... No. Project 1, Part 3. If you're just building your first SwiftUI app, yep, and all is well, you were surprised by how easy it was. Okay, so we're on day 18. Cool. Hiding the keyboard. Oh no, I think we've already done this, haven't we? Wrap up. This doesn't link. This doesn't link to day 18. Okay. This just jumps straight to... Is that right? This jumps straight to part 2. We've done this. Hiding the keyboard. We did that. Day 18 has stuff that we haven't seen yet. But this is jumping to the next project. Interesting. That's okay. Second, though you have been using advanced features, in fact, without realizing you've actually been using all the most advanced features Swift has to offer, we've actually been using closures all the time. Yeah, just look at the code like this. Yeah, I'm looking at it. Format percent. Cool. Did you know that $0 in there? That's shorthand syntax for closure parameters because we're inside a closure. Today you should work through the wrap-up chapter for Project 1, completing its review, then work through all of 3 of its challenges. Oh, we did that. Oh yeah, collapse. Excellent. SwiftUI allows no more than 10 child views. Review all Swift... Oh, okay. Oh, cool. So we got a little review we can do. I hope I didn't miss any of those earlier. I feel like I may have done... What's this Swift... Find the Swifty words. No, yeah, okay. So we looked at that. Okay, a little quiz. Question 1 out of 12. Okay, cool. Which of these statements are true? Click to show. Click to show. Okay. SwiftUI allows no more than 10 child views inside each parent. Yeah, that's true. All SwiftUI views must inherit from the content view. No. Okay, continue. Formatters let us control the way numbers are shown inside text views. Yes, we should always force a currency code on the user. No. Let's go. What? Continue? SwiftUI views cannot contain computer properties. It's not true. Segmented controls are created using pick of views. Yes. Forms can scroll. Yes. The navigation... I'm going to get thrown if this says which statements are false. Because I'm not reading the top section. The navigation bar view lets us... No, there is no navigation bar view. Forms can scroll. Yes, correct. The keyboard type modifier lets us change the keyboard that is shown with text field. Yes, all form sections must have titles. No, they don't. Continue. When creating a text field, we need to provide some placeholder text. Pickers are always shown as wheels in iOS. No, not always. We can declare a two-way binding using the @ symbol, @name, for example. That's all SwiftUI views must have a body property. Yes. Oh, what's going on with me? Sometimes it's not getting the little hand. Okay, so we can send a string to the navigation title modifier to place a title at the top of our navigation view. Okay, the nil coalescing operator ensures the value is nil before being used. First one. That doesn't make sense. If we want to modify a property, we need to use a SwiftUI property wrapper such as @property. No. If we want to modify a property, we need to use a SwiftUI property wrapper such as state. Correct. There we go. For each, views let us loop over ranges and arrays. Yes. For each, views can't loop over more than 10 items because SwiftUI... Oh, I almost clicked the wrong one. Whenever a state property changes, Swift re-invokes our body property. Yeah. That's what I said earlier. Apple recommends state properties should use public access. Oh, okay. We always need to bind text. Do you know what's weird? Whenever I see a quiz that's like 11 out of 12, I think that if I finish the 11th one, I'm done. But that's not... Yeah, it's not... Oh no, wait, I didn't mean to click that. Oh, it doesn't matter. We always need to bind text fields to strings. Yes, I think so. SwiftUI's views aren't included in our app if we send it. Wait, what? Hang on a sec. SwiftUI's previews aren't included. Oh, that's the correct option. Yeah, I didn't read that properly. Okay, so we always need to bind text fields to strings. No, we don't, because we can use numbers. We did that before. We used numbers, and that's how we got the format. What a dumb mistake. Almost got them all, except for the last one. Okay. So let's go for... Where are we at? Where are we at? Day 18. Okay. This has nothing else. It doesn't go with anything else except... Okay, cool. So this means we're up to day 19, which we completed. We completed the challenge, right? Didn't we? Temperature conversion. Oh, this is different. Oh, okay. This is like a whole app we got to build. All right, let's do it. This will take a little bit. I might need to get a little snack, and I'm out of water, and I can open up my door and let some cold air in. Okay, so what we need to do, your challenge. This is 19. This will be day 19, yeah. Just double check. Yes, challenge day 19. I have a feeling I'm only going to make it to like 50. Where are we at? Almost 6 hours of this stream. Gosh. Temperature conversion app. Which units you choose down to you, but you could choose one of these. Fahrenheit Kelvin, length conversion, meters, kilometers. I'm going to go with length, maybe. Time? No, time's a good one. Volume? No, yeah, okay, so if you were going for length conversion, you might have segment control for meters. Okay, so if you choose, so we're making a source unit of feet for output unit, then enter 10, you'd see, okay. Got it, I know exactly what we're doing here. All right, so we're gonna go with time. Let's go hours. I find hours probably a bit more interesting, and because it's sort of in the middle, you can convert it to days. We will go with, let's go with double. I don't want to deal with that because we got 60 seconds and all that sort of stuff. That's gonna be a pain. Let's not do double. Because if you go double, you have to do the conversion between like 0 to 100 or whatever fractions you're gonna break it up into. So let's just go with 0 to start. We're going to go with a navigation. No, let's just go straight out with a form. Being lazy today. I'm not gonna do the thing where the picker goes to another screen, right? In here we will have a section which will be our input. So we'll have text fields. In here we're gonna pass in time, input, and hours, and we'll go format. Do we get date time? I have a feeling this isn't going to work out, is it? Oh, we need to also have, yeah, sorry, that's a bit silly. Let's go with the proper format thing down here so I can get the order correct. This is the one we want. So we got value. No, this is wrong. This is what we need. Let's call it hours. And then here we go, format, value, format, date time, And what issue is it having now? We've got int to expect every time binding date format start. Oh, got it. Okay, we're not using that then. We're going to just go with a number. Yeah, we'll just go with number. Our input. Let's do that. Cool. And then we're going to have another section. Convert. Let's just go with convert to, right? And then in here we've got a picker. And up here we'll have our little array, which is like we get extra fancy, right? So we could have an enum. We'll call it time. Sure. Case iterable, and then we have we'll have seconds, minutes, minutes, hours. Oh, we won't have hours. We'll have days. Yeah. Cool. What do we got? And we go time value, all cases. Get rid of that. I think we need to do an ID, which will be raw value. I don't know if we've got access to that. I think this probably define task priority and minute. Okay, anyway, it doesn't matter. So yeah, we need to set up string must be in front. That's okay, we can do that. There is a method to this. Training closure pass parameter type does not accept the closure. What are we doing wrong here? Okay, hang on. Picker, title. Oh, we need a selection in there. Oh, I work. I'm an idiot again. This is what I'm trying to do, like straight from my mind. For each. This is what we need to do. So for each time, all cases. We literally just did this. Let's get rid of that because we're going to use the other syntax. This one here, right? Remove that. Throw that down in there. Up here, we've got to take this away. And then the picker is going to have title selection is time value, and we set it to this needs to be conversion, sorry, and we'll start it out as minutes, and then in here we've got the selection will be conversion content, which is what we've got under here already. So let's see if this will build. The initializer requires confirm string protocol. So what we can do is just set this to raw value for now. Because it's a string, it should be fine in that text item. Yeah. Okay, so cool. So we can make changes here now. Kind of. What's going on? If I make a change, nothing's happening. Do you have the correct? What have I done wrong? It's not sticking. Conversion, conversion. State, minutes. Is that because of... Oh, if I keep running into stuff like this, I'm not gonna... There's no way. Oh, I know why. I know why. Don't worry about me. Because this is getting set. Yeah, so, okay. Give me something that knows that matches the call. It's making me do raw value. This should work. If we set this to a string, I think that will work. I think that's our problem, right? Yeah, that's the issue. How do I make this work with an enum again? Oh, I think let's give this a go. The display. I could use the ID. That's okay. We can make this work. Let's just keep going. Losing out time here. So let's go another section. This will give us our results, yeah? And this is just going to be text, and it'll be... I'm just going to... Oh, you know what? Let's go with integer. Since the hours are integers, we should be able to get... Days is not going to work because it will be a fraction, so we'll work that out when we get to it, right? So result, and then we've got format number. Cool. Okay, so what we got to do here is time. So we do a. So the idea is that we do a switch, right, on the conversion, but we can't do that. So we need to go if let. We go guard let switch. Oh, we go guard let yeah, switch value. Oh, let's call it time value. These are all messed up, but it's fine. And what we want to do is go time value, raw value, and then we pass through the conversion, right? Else we return, I'll just say -1, and then we'll know that something's gone wrong, yeah? And then after this, what we can do is make use of the time value. So we go switch and we go time value, and then we go case, and we go minutes, case days, case dot seconds. For minutes and seconds, we could almost put these together. We won't do that. So minutes, we need to return time input in hours divided by, no, times 60. And then we do the same thing again for seconds. Times 60 times 60. And then for days, we return time input hours divided by, so this will just round off to whatever day. I'm just going to go with that just so we can move on, right? So what we need to do is 24, yeah? So if it's 24, we should get 1. If it's less than that, we should almost get 0. It'll round to some value. Okay, so if I add like 5, we've got seconds selected. If we go minutes, 300. If we go days, 0. If I go 24 for days, we get 1. If I go 48, which is about as long as this stream's going to go for, we got 2 days. And then we've got, like, if we say, if we want to go like, this is obviously broken. But if we go like 1 hour, we've got 60 minutes. And there's 3,600 seconds in an hour. I'm going to call that finish, right? Like we segmented control for, oh no, we need segmented control for the picker. All right, so let's just do that. Picker style, segmented, seconds, minutes, days. So 24 hours, minutes, days. Are we all okay with that? Or is it, it's a little bit unsatisfying. Text field we're using a number, yeah, a text field showing the result of the conversion. A text view, yeah. So if you choose source, you know everything. Tips. Look, I'm gonna say done. I'm gonna say done. So project 2, part 1, day 20. All right. Let's remove all this. All this. All this. All right. Day 20. Gosh. Oh, man. I'm gonna have to set a deadline, I think. Otherwise, we'll go 2 more hours. Okay, I'll do the full 8. We'll go 2 more hours. We'll see how far I get. Maybe someone else can do the challenge and get further or something, right? I'd watch that stream. I do need to get a drink though, so I'll be back in a sec. Feel free to think of any questions for me to come back to if you want. I'll be back. Okay. So, I'm just gonna have a snack. I'm gonna mute while I do it. Oh man, that camera. It's not usually this bad. So, I mentioned earlier in the stream I was baking bread, but I let it sit for too long overnight. It's a little bit flat, but it's tasty. So, anyway, I'm gonna eat this. Ask any questions if you got them. I'm gonna just have a quick snack and then we'll get back into it. We're up to day 20. Welcome back. It's good to be back. I bet this isn't what you signed up for. My dog wants to come in because he knows I got food. What about geometry reader? I couldn't understand it. I don't understand it either. I try not to use it wherever possible. Like if I get into a situation where it looks like I'm gonna have to use it, I'll do everything I can to not use it. It behaves differently to any other view. It's almost like a Z-stack in a way, right? But all it lets you do is like read the measurements of the size of the views. Oh, I think I know what's the problem with my camera. I think it focuses on whatever's in the center of the screen, right? Not set up to faces. I don't know. Maybe I'm wrong. Okay. Anyway, yeah. Only use it if you absolutely have to. It's a bit weird. And I think it's expensive. Could be wrong, but it seems like things slow down a bit when I'm using geometry readers. I left my drink out there. I'll be back in a second. So one really big benefit of me leaving that sourdough out all night, it tastes really good. It's very sour. It just doesn't look great. It tastes amazing. Yes, I read that also. It's expensive. Okay, well, there you go. He probably won't leave me alone now for a while. See how we go. Okay. Project 2. Consolidation. Last few days we covered some of the fundamentals. Review what you've learned. I hope we don't have to redo everything I just did. I thought I had to get up and go get him away, but he's left. Okay. Here we go. All right. Oh, guess the flag. No, he's back. He's come back. He's at the door. And we end on showing alert messages. All right. Let's remember that. Introduction. You're going to need to download some files for this project, which you can do from GitHub. Oh, man. SwiftUI. Okay, cool. All right, let's see how we go. Pretty quick. All right, once you have those, go ahead and create a new app project. Next code called Guess the Flag. No, we'll just reuse what we got. Okay, iOS 15 or later. As before, we're going to be starting a new overview of the various. Okay, so cool. Using stacks to arrange views. Okay, let's just pull this in a little bit. Okay, when we return some view from our body, SwiftUI expects to receive back some kind of view that can be displayed on the screen. That might be a navigation view, a form, text. Okay, cool. Yep, so this is what we're going to try now. Our default template looks like this. Yep, returns precisely one kind of view, which is a text view. Cool, if we want to return two views, this color code won't work. Yeah, so unless you do one. Why have we got two of these? Oh, we got two of these because we've put in two views, right? If you use SwiftUI Canvas and Xcode, you'll now see two screens appear. Yep. So for VStack, a vertical stack of views, the next two views will be placed above each other like this. Yeah. And it's probably going to get us to do the same thing, but with their H stack, right? God, I'll give him a taste of that. Let him join. He can come in, but he thinks I've got food. I'll grab him. But he won't sit still. Trust me. Come out. Come on. There he is. He's a very naughty boy. Jump down, buddy. Oh, and I've got another one. I have two of them. And she makes no noise. So it's him that's very loud all day long. Barks at everything. Yeah, go comfy. Go sit. Excellent. All right, V stack. Yeah, so we stacked the hello. You okay? Yeah, he's alright. He now knows that I have no food. Spacing. Yeah, we can set spacing. I use this all the time. Most of the time I use it to set it to 0 because I want to do like maybe manual padding and stuff in between these. Excellent. Alignment. Let's do the alignment. Annoying that it adds that content thing. It's not smart enough yet to detect that you've already got content set. Opposite personality, yeah. They are complete opposites. I haven't heard her cry once, except like when she gets hurt. You know, when a dog squeaks when they get hurt or something. She does that, but she doesn't like sit there and cry like if she's hungry like he does. Spacing 20. Yeah. Oh, what do we got here? Wait. Alongside VStack, we have HStack. Oh, okay, let's do it. Oh, you know what we should do? We should copy this text because this is going to show us what the alignment does. So then we get rid of this. It'll center it, and then we add it back. And we can also do trailing. Right aligns it. Pretty good. They should know how to code, I assume. Oh. I've had these dogs for probably as long as I've been coding. Like, obviously, I've been coding longer than they've been around, but it's almost the same amount of time. Yeah, they're both of them almost 9 now. But no, they don't know how to code. I've been practicing, like trying the, the dog with the buttons and stuff. We got like some buttons. We were teaching him to do it. He's pretty clever. She's not, but he's starting to work all that sort of stuff out with the buttons, so he can talk to us and tell us what he actually wants, which is really good. And it's good exercise for him. Good brain exercises. HStack. Spacing. 20. This is inside a stack. Yeah, so we got them side by side. That's great. Let's keep going. Let's go VStack. Get rid of that. And we can do a spacer. Push this to the top of the screen. Excellent. We can do a spacer again. And we do 2 of these. So it puts it in the center, and then we can kind of get like a, I don't know, top half, I guess we call it. Z-stack, that will stack everything on top of it. And spaces don't do anything in Z-stacks. I think, are they full? Let's just go, we can check. This is a little cool thing. We can go color. We can see the Z-stack is here. Like only applies to that, I guess. The Z-stack will shrink, it seems, to fit its contents, I guess. Cool. Z-stack alignment. It doesn't have the concept of spacing because views overlap, but does have alignment. So if you stack one large thing and one small thing inside your Z-stack, you can make both views align to the top like this. Draws the contents from top to bottom, back to front. This means that you have an image, then some text. Z-stack will draw them in that order, placing the text on top of the image. Try placing several hundred stacks inside a single vertical stack. Can you make a 3x3 grid? Fine. 3x3 grid. Oops. Three by three grid. There you go. All done. All right. Colors and frames. I'm gonna forget what we're up to. Oh, is dog's button thing real? How they get used to it? Frame with infinity height and width will fill the place, right? Yes, it will. Yeah, if you add, no, not always. That's another thing with SwiftUI. Yeah, you go, you want to set the frame to infinity or something like that. Most cases, yes, it will. But if it's wrapped by another view that will shrink, I think. I'm not going to say what the circumstance is where that doesn't work because I remember running into that issue once or twice and not being able to work out why. So I don't know the answer to it, but sometimes, yeah, it doesn't work. Sometimes it'll still squish it up, and I don't know the circumstances under why. For the Z-stack, yeah, that'll work for that too. It works for all. It's supposed to work for all other views, but sometimes it does not. Frame with Oh, the dogs button thing. How they get used to it? Yeah, there's a whole like training thing you have to do. You put the buttons near the items in the house that you want them to associate them with. Like if your dog's going outside, you want to press the button before you take them outside every single time. And you do that for like a good couple of weeks, and then you start like teaching them to press the button, like put food on it, and they touch it with his paw and stuff, and every time he does that, he gets a treat. And then eventually he associates outside with the button near the door, and then eventually you move them closer together into one spot in the house, so you got all the buttons in one spot, and you just start with like 2 buttons. So like outside's a good one, maybe play is another good one to start with. You probably don't want to start with food because they'll just spam that thing, it'll be broken. But yeah, they get he's always been pretty good at telling us what he wants anyway, just with his particular body language. Like if he doesn't have any water, he'll come and get us, and he comes and gets us different to like barking, or like he'll come up to us and then run away essentially, and then come up and run away again over to the dog water. That's only ever happened twice, and he taught himself how to do that. The first time he was a little puppy and he ran out of water one day, and he just came and told us, and then it was like a couple of years later he did it again, and since then he hasn't run out of water. We made sure he hasn't. But yeah, sometimes it's a bit of a hot day and he'll just get through the whole thing pretty quickly. It's a fairly good range of functional render colors and manages to be both simple and powerful, a difficult combination, but one they really pull off. Try this out. Let's create a Z stack with a single text label. I might have to close my door. Your content. Yeah, if we want to put something behind the text, we need to place it above the Z stack. Yes. Or we can do a background. Red. Yes. So that goes behind as well. Might have done what you expected, but there's a good chance it was a surprise. Only the text view had a background color, even though we've asked the whole Z stack to have it. In fact, there's no difference between that code and this. Oh, okay, here we go. If you want to fill in the red, a whole area behind the text, you should place the color into the Z stack. Yeah, so you can do cool stuff like this. And then is it going to get us to do... Ignore safe area, so we can do the whole thing. Colors automatically take up all the space available, but you can also use the frame modifier to ask for specific sizes. Yeah, so we can set it to 200 by 200. Awesome. You can also specify minimum and maximum widths and heights. If I set... Yeah, so it'll still stick to that same size. It was just a little experiment there. Minimum and maximum widths. Yeah, so this is the infinity thing you're talking about, which is pretty cool. So here we've got the width will fill as much space as it possibly can, and the minimum is set to 200. Yeah. So if we resize this screen, like it goes into a smaller device or something like that, that's less than 200. It will not drop below that. The max height is 200. Okay. Okay, if you need something specific, you can create custom colors. So let's go with that. Throw that up there. Yellow. How much space is white depends on your device, but yes, ignore safe area, which is what we had before. We can do that, I guess, on the Z stack, right? Yeah. And we go back to color red. Look at that. It's similar to what we had here when I placed ignores up there. Okay, here we go. It's critically important that no important content be placed outside the safe area because it might be hard, not possible. Some views, such as list, allow content to scroll outside the safe area, but then add extra insets so the user can scroll things into view. Yeah. If your content is decorative, like our background color here, then extending outside the safe area is okay. Okay, so what are we doing here? Z stack. We go V stack. Spacing 0. Color red. color blue. Alright, text your content. Foreground color, secondary. Yeah, padding. Background, ultra I was about to mention that there's this extra thing we can do here with this material. It's funny that it's almost like he's reading my mind. That's pretty good. Yeah. Gradients. Gradients. All right, we've got 2 more. Showing alert messages, buttons, and images. I really enjoyed talking to you, and thanks for your advices. I'm going to sleep. Yes. You should have gone to sleep a long time ago. I haven't slept yet. I will follow you on Twitter. Oh, thank you. That's very kind. Let's do these gradients. It was good talking to you. It's always nice having a chat that interacts with you. It's great. Gradient. Oh, yeah. Colors. We put an array of colors. So we go white, black. Start point, top and bottom. Excellent. So what do we got here? Inner gradient type. The inner gradient type used, I think the inner linear used here there can be provided with gradient stops, which lets you specify both the color and how far along the gradient. Yeah. We can specify that a gradient should be white from the start up to 45% of the available space, and then black. Oh, okay, yeah. So you set the locations. I'm gonna copy that. That's a lot to write in. We got stops. That's the white one, and then the black one will be, instead of 45, it's 55. Whoops, black. Did I mess this up? Oh yes, I did. 0 point. There we go. This will create a much sharper gradient. It will be compressed into a small space in the center. Swift knows we're creating gradient stops here, so as a shortcut we can just write init rather than gradient.stop. Can we? We gotta do a dot. And that works fine. Excellent. As an alternative, radial gradients move outwards in a circle. Yeah, let's do a radial gradient. And we've got blue and black. We can add more. We can go red. It's pretty cool. And the last gradient type is called angular gradient, although you might have heard it referred to elsewhere as a conic or conical gradient. This gradient colors around a circle rather than radiant outwards and creates some beautiful effects. Can it? This is my least favorite gradient. You have to like... Oh, this one's not too bad. When you got that hard line there, it doesn't work. But if you can cycle through colors, it does. It works well. Okay, excuse me. Buttons and images. Let's do a button. Delete selection. Print. Now deleting. If we tap this, if we were running this in the simulator, we would get a print, but we are not, so we don't get that. So what we could do is set, we'll just get through this, and because this will come in handy later. So we got button delete, action, execute, delete. Yeah, so we can replace this here with this code, and then we can run a function, right? Which is execute delete. And then we run the print. Again, it's the same thing as before, but it's not going to do anything. Okay, there's a few different ways we can customize the way buttons look. First, we can attach a role to the button, which iOS can use to adjust its appearance both visually and for screen readers. For example, we could say that our delete button has destructive role like this. Ooh, We got an action on the end. Yeah. All right, so let's just go roll destructive, and I think it will color it red. Yeah, excellent. And you can set it for like cancel type. Yeah, cancel default, sort of things. Okay, so we've got second, we can use one of the built-in styles for buttons, bordered and bordered prominent. These can be used by themselves or in combination with a role. Bordered prominent. Okay, so let's grab this and take a look at it. We got bordered, destructive. Yeah, these all work fine. Yeah, how cool, right? Bordered, destructive, bordered prominent. So this has got nothing going on. This has got two. So the second one's got destructive and bordered. And bordered prominent. So the prominent makes the background fill in. It's kind of cool. If you want to customize colors, use for border button, use the tint. Yes. Otherwise, if you use the tint on the others, I believe it changes all the color, which is like, this is so cool that it knows to do like opacity on that. Pretty neat. We just keep going. Yeah. They behave as you would expect. Okay, if you want something completely custom, you can pass a custom label using the second trailing closer. This is how I do all my buttons. It's pretty rare that I just use the built-in, like just pass a string to them and let them handle their own design. The reason for that is because a lot of the stuff I work with has custom designs from clients, and it's like, it's actually kind of frustrating that they don't want to use Apple's UI elements, but I understand why as well. Like I do the same in my own apps. But it is a lot of extra code. Like instead of just passing a string, you got to do all this sort of stuff, add padding. And in some cases, I still got to put the corner radius back on too. Like they'll have a custom radius that they want that's not like Apple style. Oh well. SwiftUI has a dedicated image type for handling pictures in your apps. Yes, won't really allow for users who have enabled the screen reader. This is for images that don't convey additional important information. These are things that I'm so glad that the accessibility stuff is throughout this course. It's important to think about, even if you're working for a company and they're like, this isn't something that because there's a lot of them will say, let's get the app out first and then worry about accessibility later. But then they never do, which is a shame because Apple has made it much easier to make these things work. And I'm hoping that developers, well, potential or new developers who are upcoming, pay special attention to the accessibility stuff, because a lot of the ones out there now don't. So when I'm working on a project, I'll try and do accessibility things as much as possible, even if the client hasn't like asked for it. So I'll make use of it where I can. Just a nice little extra treat for people who go and use their apps, and you know, they can feel like they've been taken care of. Because the long form of buttons can have any kind of views inside them, you can use images like this. Yes, system name. So this will give us the pencil icon from SF Symbols, which is an app you can download on your Mac. SF Symbols. And then labels. So these labels are interesting. I have a love-hate relationship with these. They're so simple, but I still haven't worked out how to like swap the order of these, and they behave differently depending on what platform they're on, I think. If you want both text and image at the same time, so if you have a dedicated type called label, yes, that will show both pencil. Hopefully he says how to switch it. No, I don't know if you can flip labels. Showing alert messages. Let's go. If something important happens, a common way of notifying the user is using an alert, a pop-up window that contains a title message and one of two buttons, depending on what you need. But think about it. When should an alert be shown and how? Yes, so we have to use the state to do that. And generally it's just a Boolean, but you could set it on a type being set, right? Like a value. So instead of using a bool, you could have, I don't know, a string that gets set, and then you can present when that string is not nil. Content view, yeah. We go body, we go button. Or we can actually see a button working, hopefully, in this preview, showing alert equals true. And we can say toggle on that. I'm assuming we're going to get to that at some point. Ignore the fact that I've got this in the VStack and he doesn't. So title will be important message is presented, will be our showing alert. Actions. We'll just put, yeah, we'll just throw this in there. Okay, let's run this. Show alert. Important message. Okay. Okay, here we go. All right, I might have to, definitely gonna have to close my door. Give me 1 second. There's too much swearing going on outside, I think. Just a little bit. All right, take a look at the alert modifier. We have alert important message isn't presented. Yes, the first part is the alert, which is straightforward. Now look at the button. Yeah, this is empty closure, meaning that we aren't assigning any functionality to run when the button is pressed. That doesn't matter though, because any button inside an alert will automatically dismiss the alert. That closure is there to let us add any extra functionality beyond just dismissing the alert. I didn't know that. I think, like any time I've ever added buttons and stuff to an alert, I think I've done stuff like showing alert equals false, and then had my other code in there. So it's good to know that like any button will dismiss it. It makes sense that would be the case. If you're going to design a whole new API, like a whole new framework like SwiftUI, those are the little things you can take care of. You should, if you can take care of them, you should. So it's great that they did that. You can add more buttons to your alert. Let's give this a go. Show alert. Cancel, delete. Yeah, destructive and cancel. Excellent. And yeah, once again, both of them. And then on delete, you would run like deletion code, which would be this here. We can put that in there. Which won't print anything, obviously. No. All right, and finally, you can add message text to go alongside your title with a second trailing closure like this. Yes, I think there are other ways to do this too. There's a few different methods, I think. Please read this. So we go show alert again. We go, there's our little message there. Please read this. Excellent. So we're all done there. Stacking up buttons is the next thing, which is day 21, I believe. Showing alert messages. Yeah. So we can get rid of this. Let's go day 21. And let's change it here, day 21. Right, let's keep going. What do we got? Stacking up buttons. Let's just move this over here. So we've got 4 going on. Okay, hopefully this is nice and quick. All right, next we need 2 properties to store our game data, an array of the okay, so we're going to start our app by building the basic UI structure, which will be 2 levels. Okay, so this is the flag guessing app, yeah? And we need countries. What the? Estonia, France, Germany, Ireland, Italy. Oh man, you know what we should have done? We can make this. There are so many here. Hang on a minute. Hang on a minute. Because he got us to download. Got us to download some project files. So see how we got all these flags? Okay, you don't know what I'm thinking. It's in my head. I gotta say something. So I've made an app like this in the past, not with SwiftUI, UIKit, and I actually used emojis for the flags. Because in order to generate the emoji flags, you have to use a country ID, and you can get the country IDs from the OS. Because it has all the country IDs in there for like the time zones and stuff like that, right? So you could get a list of them. Then you can use those to generate the emoji flags, and then you don't need to add images to your app. And then if you just, and you get the list automatically as an array, right? So you don't even need to write out the array. We'll go with this flow first, and then if I feel like it, we'll fix things up. Not fix things up. This is perfect. I'm just saying. We could reduce the code a little bit and have more options. All right. I don't want to look. I'm just going to copy this one. It's too much for me to type out. The correct answer int rand. I think I will just start copying code in from now on, because it's getting to the point where this is taking me forever. Like I said early on, I've got 5 minutes per day if I work off an 8-hour day, and I should be well over halfway by now. with you know, if I was doing it within 5 minutes. Okay. What have we got? Germany. Excellent. Below there, we want to have our tappable flag buttons, and while we could just add them to the same VStack, we can actually create a second VStack so that we have more control of the spacing. Okay. The VStack we just created above holds two text views. There's no spacing, but the flags are going to have 30 points of spacing between them, so it looks better. So stop adding this for each loop directly below the end of VStack. Okay. I'm hoping that do we drop these into another? No. Okay, for each. Yeah, let's copy this in. Like I said, we got to go for it. Got to get some more done. Flag was tapped. What do we got? Image, countries, number. Okay, so this isn't coming through because we haven't got. We haven't got these set up, right? So we need to do that. Yeah, let me see if I'm supposed to open up this other project. Oh, weird. Okay, hang on. I'm in the wrong one. SwiftUI. Project 2. Is this all pre-filled already? This is all finished. Yeah, this is a finished project. That's not what we want to do. So what we want, we just want the assets. So these are already set up and named, so I'm just going to dump them in here, yeah? That's okay, isn't it? That's not, you know, speeds things up a little bit. Let's drop that. Okay, here we go. What have we got? So your code should look like this. Yes, we have our images coming in. That's great. And they are buttons. You can see that they change. Interesting. We had it update, it changed, and then it stopped changing. Weird. Okay, so what do we got? Start by, okay. So here we go. I'm starting to lose it. Just so everyone knows. Starting to lose focus here. I never, like, even on an 8-hour day, we're at almost 7 hours. An 8-hour day, I have multiple breaks. I go for a walk. Sometimes I go for the gym. Go to the gym during lunch. This is pretty intense amount of work. Not what I'm used to. Start pointing Z stack around your outer V stack like this. Okay, so why are we doing this? That's enough to give you a basic idea of our user interface. Already you'll see it doesn't look great. Some flags have white in them, which blends into the background. Got it. So we're adding this Z stack so we can add a background. That makes sense. And we want to go color blue. Ignore safe area. Okay. And then we got foreground color white for tap the flag of. Yeah. And this one here too. Excellent. The design is not going to set the model out, but it's a solid start. Cool. Next, showing the player's score with an alert. Cool. We got our countries. Yes. As you see, the shuffled. Yes, let's shuffle. Nice and easy to randomize the array. As you can see, the shuffle method automatically takes care of randomizing the array order for us. Now for the more interesting part. When a flag has been tapped, what should we do? We need to replace the flag was tapped. Code this one here. Cool, so showing score. Let's... oh my gosh, private var showing score is false. Let's just copy these out. Title, flag taps. Let's reuse this one. I'll copy across its contents. I'll go do some typing. And then flag tapped is up here. I assume flag tapped and the number is the number. And so what we do is if the number is equal to the correct answer, the title will pop up, the alert will pop up saying correct. If it's wrong, it'll pop up saying wrong, showing score true. So we show it. So what we need to do is ask question. I'm assuming we're going to run this code when we tap a button in the alert that shows up, right? Countries, shuffle. Correct answer. This is something I've been messed up before. Shuffle and shuffled. Shuffled returns a new array, and shuffle, I think. What have I done? Is it gonna ask me to change? Okay, cool. We add state. I was like, hang on a sec, you can't just shuffle. Shuffled returns a new array. Shuffle will change, will shuffle in place. Where are we at? Int random. Two. Okay, ask question, correct answer, and we need to change the correct answer. I'm just going to think through this real quick. We got... trying to think about how I would have usually done this. Basically the same. Does this mean a correct answer will always be in the top? And 0, 1, 2, that's 3, 0. Anyway, let's keep going. We've got the alert. Okay, cool. Time for the alert. We can put it on the Z stack. Yes. Alert. Come on, give me title, which is score title is presented. Showing score actions. Let's just grab this button out of there. Button, continue, ask question. Yep, and the message. Let's grab the text. I think that's good. Yeah, there are 3 question marks that should hold a score value. We complete that part soon. Oh yeah, I guess we gotta add another value up here to keep track of our score. So the flag of Italy, let's tap this, correct. Great, and it refreshes, it gives you a new one. Because the button in the alert asks the next question. Estonia, correct. France, let's pick Germany's flag on purpose. This is on purpose, people. Score is wrong. The score, it's wrong. Excellent. That's what we wanted. And I'll ask another one anyway. Maybe I should, like, you know, not do that if it's... Doesn't matter. France. France. Ireland. Yep. UK. Okay. Cool. Okay, cool. Alright, so next, styling our flags. Where are we at? We got to styling our flags. Almost done. Upgrading. So we're gonna go for another. I'm gonna go for one more hour, and I'm to call it a day. I'm out of it. Upgrading our design. That's styling our flags, upgrading our design. That's where we're at next. Okay, so we got so find this line. Yeah, so let's place a solid blue background color with a linear. So yeah, the game works. So that doesn't look great. Unfortunately, we can make a few small tweaks look better. Replace it with the gradient. I love that idea. Let's do that. Yeah, that looks better. I still ignore the safe area, ensuring the background goes edge to edge. Yes. And we'll set some fonts. So we want to go this on tap the flag. So let's throw that down there. Tap the flag of. I feel like it could be a little bit larger. Put the modifiers directly after text countries. Tap flag of Ireland. Yeah. Okay. Large title is the largest built-in font size iOS offers us, and we'll make the scales up or down depending on what's setting the... Yes, so what you can do is you can come over here and you can say, let's do dynamic type, and you can scroll this little... Oh, I'm in the way. Here we go. So let's pop open this. You can kind of change this, and then the font size will change. This is how you test it in the previews. Yeah? Pretty cool. Back to large. Next we have, okay, we do clip shapes. There are 4 built-in shapes: a Swift, rectangle, round, rectangle. I think it wants us to do this on the flag image. Is that correct? There are 4 built-in shapes. Making an image modify like this. And finally, we want to apply a shadow. Yes. Let's throw this on our flags, so we should see them update. Cool. Capsule's fine, I guess. Shadow. We've got a shadow around our... Yep. Yeah, okay, cool. So this is it here. With SwiftUI has so many modifiers, help us adjust the way fonts and images are rendered. They all do exactly one thing, so it's common to stack them up as you can see above. Cool. Upgrading our design. Keep going. So what do we got? Previously I showed how we can make very precise gradient stops locations. Well, if we create 2 stops that are identical to each other, then that gradient goes away entirely. The color just switches from one to the other directly. Let's try it out with our design. Oh, we're going radial now. All right, let's replace this code. Oh, interesting. This is useful. This isn't something I've done before. This is so useful. I didn't know about this. So in the past, I'll just like draw shape. I'll have a red background and then just draw a circle and then offset it. But this is useful. I'll go to try and remember that. I don't think I'm making any long-term memories anymore. After today, so it may not stay in there. So let's go. So we can send in toned down versions of those same colors to get something looking more harmonious, shades that are more common in flags. Ooh, let's replace. Okay, it's not too bad. Not as vibrant though. Right now we have a VStack with spacing of 30. If we change it to 15, oh yeah, squash it down a bit. Why? Well, because we're going to make that whole area into a visual element in our UI, making it colored, rounded rectangle so that parts of the game stands out on the screen. Cool. To do that, add these modifiers to the end of the same stack, of the same VStack. Got it. So this VStack here, we got to add some modifiers down here. Okay, cool. I think we're going to add some more padding, right? That looks a little weird. Next step to add is the title before our main box and a score placeholder after. This means another VStack around what we have so far because the existing is where we apply the material effect. So wrap your current VStack in a new one with the title at the top. Oh my gosh. I think we can just click this, click here, and we can go embed in VStack. And then we can just go text, guess the flag. I'm going to grab this, dump that over there, guess the flag. Cool, cool. So come on, there's actually a small shortcut. Large, title, bold. Good, good. That adds a new title at the top. We also just slot the score label at the bottom of that VStack like this. Oh my gosh! All right, let's realign everything for a second here. I think this is correct. That's where I wanted it to go. Foreground style, secondary. Okay, as for the white tap of the flag of, we can have that use the iOS vibrancy effect. So we need to use this foreground style for that. Guess the flag, tap the flag of. Change its foreground color. Got it. Yeah, you can see that's kind of like the color from behind that shines through a little bit. You can see that. Oh, no, it's very small. Let's fix that. Let's make the font bigger. You see that? Pretty cool. Okay. All right. Keep going. There are 4 spaces I'd like you to add. One directly before the guess the flag. I think I know what's happening here. So we want to do one, yes, 2 directly before the score text. Score. Spacer. Yes, so it pushes that to the bottom. And one directly after the score text. Got it. And now all that remains is to add a little padding around the outermost VStack with this. The outermost. I really wish these were doing this header thing, so you can kind of like line up stuff. Like that's an oversight to me. To make it work for function names, but not stuff inside them. Here we go. Looks a bit better, hey. That's nice. Guess the flag wrap up. Challenge. Oh, here we go. Add a state property to show the user score. We can do that. We go private var score int starts out at 0. When someone chooses the wrong flag, tell them their mistake in your alert message. Something like wrong. There's flag of France, for example. Make the game show only 8 questions, at which point they see a final alert judging their score and restart the game. Okay. Modify when they get answer wrong, display it in the alert score label. Okay. So we scroll down. Correct, wrong. We go score minus equals 1. Oh, plus score minus equals 1. Cool. And then the score needs to be passed through to the, what is it here? We'll just pass that in like that. Score. Make the game only show 8 questions, at which point they see a final alert judging their score and can restart the game. Question count equals 0. And then down here, I guess we go flag tapped. We want to ask 8 questions. So what we'll do is we'll increment here when we ask. Question count plus equals 1. And then when we show an alert, where do we go? Something like, or someone, is it make the game show only 8 questions, at which point they see a final alert judging their score and can restart the game. If is equal to 8, else restart, and we say ask question, and okay, we gotta do this, I think. Ask question, and then in here we also need to say question count equals 0, right? And score equals 0. So this is the restart. We reset everything. So let's pick some. We go correct. Score is 1. Excellent. Score 1 updates down there. Nigeria. Let's pick US. Okay, so we've got score is 0. It's back to 0. That's 2. It's 2. 3, 4, 5, 6, 7, 8. This is should be the last one. And we say restart. Everything's back to 0. Perfect. We finished. We're done. View modifiers and introduction. Oh, part 3. We're up to day 22. Day 22. If I can get to day 25, I'll be happy. Gosh, last night when I was looking through these, I was like, yeah, this isn't going to be possible because I'd never seen these before. I made this challenge for myself without even looking into it, which is silly. But last night when I went through, I was like, if I can get 50, I'll be happy. Now today, I'm just like, if I can get to 25, oh gosh. There's lots to do. All right. Let's just double check, make sure this goes to the correct place. So we got day 22. Guess the flag wrap up. Review for project. Guess the flag. Okay. Hang on a minute. Did we already do this? Oh, we already did this. Oh, okay. Oops. We skipped a day. We didn't skip it, as in I didn't write it down over here. So let's just fix that up. So day 23. Is that correct? Project 3, part 1. Views and modify. Oh, this is huge. I do all this in one day. Goodness. Oh, what's happened? Okay. Why does SwiftUI use structs for views? Oh, these are all informational. This is great. Yes, we're gonna get through this quicker, I hope. When you're just starting out the SwiftUI, you get this code. Okay, so what we can do is we can delete all this. Alright, we finished our... let's reset this back to where it was. I should have thrown this under Git source control, and then I can just do like discard changes. Hello. All right. We've got when you're just starting up SwiftUI, you get this code. Yes. It's common to then modify that text view with the background color and expect it to fill the screen. However, that doesn't happen. Instead, we go small. Yes. Now, right now, at least there's something behind our content view called a... Let me say this clear as I can. For SwiftUI developers, there is nothing behind our view. You shouldn't try to make that white space turn red with weird hacks or workarounds, and you certainly shouldn't try to reach outside of SwiftUI to do it. Oh my gosh, thank you. Thank you for saying this. So many people, you'll ask questions on like Stack Overflow, and they're like, oh, you know what you should do? You should just change the appearance of UI table view or something if you have issues with your list not working. It's like, no, don't do that. How do I make what's behind the view turn red? Yeah. Instead, you should try to get in the mindset that there is nothing behind our view, that what you see is all we have. Once you're in that mindset, it's the correct solution. Yeah, so because we have a UI hosting controller, it is the bridge between UIKit and SwiftUI. However, if you start trying to modify that view, you find that your code no longer works on Apple's other platforms, and in fact might stop working entirely on iOS at some point in the future. Especially if you want to, if you want this to work on Mac OS, like if you start messing with UI, UI is iOS. Mac OS has like NS view and stuff, whereas iOS has a UI view. So if you start like doing this and moving out of like if you start using UI color as well in your SwiftUI, you'll find that if you once we want to go over to Mac OS, you're just gonna have problems because UI color doesn't exist on Mac OS. So you want to try and stick with SwiftUI as much as possible. Right now, at least there is something behind our content view called a UI hosting controller. It is, yeah, we read that. Once you're interested in that mindset, the correct solution is to make the text view take up more space to allow it to fill the screen rather than being sized precisely around its content. Yeah, frame infinity. We did that earlier. So we had this setup similar to this, right? Infinity and infinity for both of these. And that makes the text view fill the size. So if we comment that out, we just get the background around the text itself. I use max width, max height. Yeah. So why modifier order matters? Yes. Let's grab this. So this is a little learning. Yep. So we've got background red, frame height 200 by 200. So this is setting the background red to red, and it's setting the size of it is based on the size of the button at this point of execution. At this point. And then the frame is changed. So the new frame that we're getting with 200 by 200, that's around here somewhere. That's white now. That's going to be white. So all we need to do is switch this around, and then, you know, we're making the 200 by 200 red. Yeah. It's basically the same here. What have we got? Let's keep going. Oh yeah, it changes the type. Will be. This means that the order of your modifiers matter. If we rewrite our code, apply the background. I wonder what happens if we do this. I half expected this to print out. Doesn't matter. Oh, why? Come on, let's go back. I keep clicking on the sponsored link down there. Look at that. All this padding, color padding gives us this cool little rainbow view. Okay, what does SwiftUI use? Some view for its view type. Why does? Where are we at? Halfway through. All right. Yeah. And then how much more we got? We've got 23, 24, 25. Yeah, milestone. We'll try and make it to 25. Okay, let's go through this. The second difference is important because of the way SwiftUI builds up its data using modified content. Previously, I showed you this code. Yep. That creates a simple button that makes it print its exact Swift type. And gives some long output with a couple of instances. Yeah, modified content. The view protocol has an associated type attached to it, which is SwiftUI way of saying that view by itself doesn't mean anything. We need to say exactly what kind of view it is. It effectively has a hole in it in a similar way to how Swift doesn't let us say this variable is an array. And instead requires that we say what's in the array. This variable is a string array. So while it's not allowed to write something like, so while it's not allowed, oh yeah, wait, some view, yeah, got it. It's perfectly legal right to write a view like this. Yes, returning view makes no sense because Swift wants to know what's inside the view. It has a big hole that must be filled. On the other hand, returning text is fine because we filled the hole. Swift knows what the view is. Yeah, now let's return to our code from earlier. Oh yeah, we've already got that. What SomeView lets us do is say this will be a view such as button or text, but I don't want to say what. So the hole that view has will be filled by a real view object, but we aren't required to write out the exact long type. How does VStack work? Web forms view protocol, but how does it fill the, what kind of content does it have? Hole, if it can contain lots of different things inside. What happens if we send back two views directly from our body property? This is where view builder and stuff comes in, I'm pretty sure. Yeah, view builder. Excellent. Of course, how SwiftUI interprets multiple views going back without a stack around them isn't specifically defined anywhere, but as you'll learn later, that's actually helpful. Conditional modifiers. Okay, a few more to go. What have we got here? Let's grab this. Give me one sec. I will be back in a moment. Just gotta get some more water. Okay. Here we go. I put a hat on. The beanie was getting a bit warm. Give me a second. Notifications. Oh, all right. I feel like I'm going to disappoint so many people. I really did try. I really tried to get. It's so terrible that I couldn't even make it halfway. Here we go. This code flips the text. Can we change? Yeah, that's better. Changes the color. I won't do it quick. You can't see it then. Cool. And we got a little ternary in there, which we learnt earlier today. All right. So this kind of code might look the same, but it's actually less efficient. Yes. Early on with SwiftUI, you could do like changes using this ternary stuff. If and else did not work in the first, I think it was the first version or something. You couldn't have if else in there. You had to. They all had to be views, and then we got some more clever stuff come in. But yeah, like the switching between this, and it can like sort of like, I think I remember when it did come in, it was kind of like a bit messy with animations. Because you're like swapping out an entire view. This is a little bit different. The same view's there. It's got the same ID as it did before. And then like you can animate the change in color. Anyway, environment modifiers. Let's keep going. Okay, what we got? Let's throw this in there. Let's see what we get. Excellent. All title. Yeah, so if you set... what do we got? Environment modifiers. I guess, yeah. So for example, if we have 4 text views in VStack and we want them all the same font modifier, we could apply the modifier to the VStack directly and have that change apply to all 4 text views. Yeah, I use this all the time. It's awesome. It keeps your code much cleaner, and then it's just like, yeah. From coding perspective, these modifiers are used exactly the same way as regular modifiers. However, they behave slightly different because if any of those child views override the same modifier, the child's version takes priority, which is so cool. So if we grab this and we dump that in there with a large font tile, this one's big, but this does not override everything inside. I think there's some other layout engines that don't work like this, right? It's kind of the opposite way around. Anything on the outside overrides anything on the inside. Okay, let's go again. So the font is an environment modifier, which means the Gryffindor text. However, this applies a blur effect to the VStack, then attempts to disable blurring on one of the text views. This will not work, yeah. It'll all remain blurry. Blur is a regular modifier, so any blurs applied to a child views are added to the VStack. Blur rather than replacing it, which is another great benefit, right? So like you could have another good example is like shadow, and we want to do like, you probably can't see that. No, you're not going to be able to see that at all. If I go, you can see that one. All the others will have like a radius of 5. This one I've just added heaps on there, so you can see that. And in fact, adding more of these makes this one darker. You can see how it adds to it. So if I add some more, you'll see Gryffindor get darker as well. Yeah. Okay, next, views as properties. What do we got here? Views as properties, almost through this. Okay. Let's replace this. Okay, here we go. There are lots of ways to make it easy to use complex view hierarchies in SwiftUI, and one option is to use properties. To create a view as a property of your own view, then, well, hang on. To create a view as a property of your own view, then use that property inside your layouts. Okay. For example, we could create two text views like this as properties and then use them inside a VStack. Yes. You know, I actually quite like the look of this. should do this more often. Usually I'll you just use this directly in there, but I do like this. You can even apply modifiers directly to those properties as they're being used like this. Well, that makes sense. Just drop these in there. 2 different colors. Can you do that in a function though? I wonder. Creating views as properties. Swift doesn't let us create one stored property that refers to other stored properties because it would cause problems when the object is created. This means trying to create a text field bound to a local property will cause problems. Yeah. However, you can create computed properties if you want like this. Yep. So we can swap this out. And it should be, yeah, it's the same thing going on there. This is often a great way to carve up your complex views in smaller chunks, but be careful. Unlike the body property, Swift won't automatically apply the view builder attribute here. So if you want to send multiple views back, you have 3 options. First, you can place them in a stack like this. Yeah. Or a group. If you don't want them to be stacked, they'll just come back as separate, I guess, in a way. Third option is add a view builder. Yeah, which is what I do a lot, but I won't do it every single time. Like I wouldn't do it for this case where we've got a single item here. Only when I've got multiple coming back. A lot of the time I'll use this format if I'm doing like lots of if else. Well, if something else statements. And then at that point, that's when you kind of need to use a view builder. And then because it gets rid of that logic, you don't have it sitting up in here in the main body, if else statements. Of all of them, I prefer to use view builder because it mimics the way body works. However, I'm also worried when I see folks cram lots of functionality into their properties. It's usually a sign that their views are getting a bit too complex. Yeah, and to be broken up. Speaking of which, let's tackle that next. Yeah, so the idea that I had with like removing if else statements and some logic from here and putting it in there only works to a certain extent, right? You don't want to keep just, okay, let's just put everything in here. At that point, once this gets too big, you kind of just want to move this into its own view, right? You just go another struct, you go motto 1, and then just put everything in there, and then remove it from this file and stick it in a different file. View composition, where are we at? View composition, we've got 2 more. Okay, let's copy this. I'm typing all that out. We got first, second. All right. For example, so if I'm copy and pasting a lot of this, just so we can see how it looks, I'm going to read some more of this text, right? I'm not just going to copy paste and then scroll down here next. I feel like that's, a little bit cheating a little bit. So they have large fonts and padding, foreground, background colors, plus a capsule shape. Yeah. You can see all that here. I think these are all identical. Yes, they are. Because those 2 text views are identical apart from their text, it says it right here, we can wrap them up in a new custom view like this. So we can grab this whole thing, capsule text. You can also make modifiers a similar way. And then, yeah, we'll grab these and drop that down. We just call capsule text directly and it gives us a text with these modifiers applied. And it looks identical. Of course, we can also store some modifiers in the view and customize. Yes, so we can use this to give ourselves different colors. Any second now. What's going on? Don't worry about performance issues here. It's extremely efficient to break up SwiftUI views in this way. What's going on here? Why are these colors working? Wait, foreground color. Well, that should be yellow. What? Hold up a second. That's not how that's supposed to work, right? Is this a bug? Wait up a minute. This is a bug, right? So what I'm looking at here, this is here, and I'm setting the foreground color again up here, but it's set to white. It's stuck on white. If I comment that out, it works. Oh, hold on. Oh, thank you. Oh man. I don't know. I feel like this should be overridden by this. Alright, okay. Let's keep going. Custom modifiers. Alright. Okay, SwiftUI gives us a range of built-in modifiers such as font, background, clip shape. However, it's also possible to create custom modifiers that do something specific. Yes, I don't use these very often. I probably should use them more. So this is our own modifier, and this will let us go like, if you create an extension on Vue, you can add this as another modifier to your function. What is this, title? Does it take anything? It doesn't seem to. So then we go self view modifier, and then you pass this through. That's right, title. And then this will give you like access to this result of called modifiers unused. Oh, I gotta what have I done wrong? Doesn't matter. Let's keep going. So we've got let's use a text modifier. Yeah, so up here we can call it directly using this modifier title, which is what we've done. We've got here, but because we got an extension on Vue, what we could do is just go title, and that should give us the same outcome. But what have I got? Type 0. I think I need to. Oh, duh. There we go. Some Vue, and that fixes the problem. And so yeah, if you do an extension on Vue, he'll probably go into that. Yeah, that's right there. Modifier title. Man, I gotta look ahead. Oh, you don't even need self there. You can just go like that. Cool. And it's exactly the same thing. Yeah, and you get your own little custom named modifier, title style. Excellent. So what else we got? Watermark, custom modifier. Let's throw this in there. With that in place, we can now add a watermark to any view like this. Color. Let's do it. There's a little watermark down there. Oh, yeah. Excellent. Often folks wonder when it's better to add custom view modifier versus just adding a new method to Vue, and it really comes down to one main reason. Custom view modifiers can have their own stored properties, whereas extensions to Vue cannot. Yes, that makes sense. It's pretty good. Especially if like you want to toggle on things, like you have a button or something. Custom containers. Custom modifiers. Huge chunk of learning, but you can for more. It's optional, so complete this if you have the time. Custom containers. We don't have the time. Where are we up to next? We have, I think, day 24. All right. Project 3, part 2. Let's take a look at this. This is massive. Views and modifiers, wrap up, review for project 3, views and modifiers. Excellent. So let's take a look through this. This is the wrap up. I don't think we need to do much in here. So we've got, go back to project 1 and use a conditional modifier to change the total amount. We can't do this because I just deleted all that code not long ago, right? Use a conditional modifier to change the total amount of text view to red. Total amount of text view to red if the user selects a 0% tip. All right, hang on. I guess what we can do, if we go back to project 1, do we have red in here? Do we have red? Because what I could do is just modify the one he's given us. Has he already done that? No, he hasn't. Excellent. We can do this. Go back to project 1. Use the conditional modifier to change the total amount of text view to red if the user selects 0% tip. We can do that. Where we go? Total amount text view. Total amount. Total per person. Total amount was another thing that it asked us to add during a challenge, and so I don't have access to that code anymore. I'm not going to redo it. So what we'll do is we'll add it to this, right? So we'll go we add so I'm guessing this will be the background, and then what we can do is selected. What is it? Tip percentage. Yeah, tip percentage is equal to 0. We'll go set it to red. Otherwise, set it to, I don't know, clear. And let's see what happens, what we get. 0, we got red. How much tip do you want to leave? And I guess I'm going to call that done. So go back to project 2. Okay, project 2. Guess the flag. Project 2. And replace the image view used for flags with a new flag image view that renders one flag image using the specified set of modifiers we had. Yeah, we can do that. That's it's easy. Struct flag image. Oops. View, and we need a body, and we can add the body in there, and then we go up and we find our image flag. So we go flag image and we call it number, I guess. Is that right? No, we need to pass through country's number. That's what we need to pass through. We need to pass through a country. So let's grab these. Countries is a string, right? So we can make this work. Come down here, we drop this down here, and we go country, and then we go let country string country. And I think this will be correct. If we run this, see what we get. And it all works fine. Excellent, excellent, excellent. Okay, so create a custom view modifier and accompanying view extension that makes a view have a large blue font suitable for prominent titles in a view. Okay, we can do that. So let's change, guess the flag. Let's put a new tile mod equals view modifier. Sometimes I like to do a build so I get an error on purpose, so I can just hit fix. So I can remember what it is that's supposed to go in there. So we've got content. We go content dot, what is it? Makes a view have a large title. Navigation. No, we go font. Large title. Foreground color dot blue. And then we need to do a view extension, right? So we go extension, view, oops, and then we go function, title. This needs to return a view, and then we go modifier, title mod. Come back up here. We did this like not too long ago, but hey, we'll do it again. And then up here we've got guess the flag. We can remove this. And we just go title. Oh, yeah. Oh, we gotta rerun that. What am I doing wrong here? Some view. Keep forgetting that. Give me a blue, give me blue. Yeah, look at that, blue. Excellent. We have finished this. We are completed. Better rest introduction. I think There's another one here. Review for 3 project views modifiers. Okay, let's go through these questions real quick, and then I think I might have to leave. I might be done. I don't know. I've got some food I've got to eat. The order in which we apply modifiers affects the result we get. Yes. Oh, good thing I checked them. I didn't. I was correct in guessing that. Yeah, which statements are true. This button's a little bit weird. Okay, so SwiftUI views automatically stay inside the safe area unless we specify otherwise. We can create custom views but can't apply modifiers to them. Wrong. Okay, yeah, I'll continue. Breaking SwiftUI views and smaller views has little to no performance impact. Once a view has a background color applied, it can't be changed. Some keyword in some view signals an opaque return type. You can add no more than 5 modifiers to a given view. Changing state property of a view causes SwiftUI revoke the body property. Yeah. Yes. A view's body can return view rather than some view in exceptional circumstances. No, that's yeah. So if a VStack has a foreground color and some text inside, it also has a foreground color. The VStack's foreground color is used. Well, that's what we found. That's what we discovered, right? If a VStack has a yes, that is what we discovered. If a foreground color has and some text inside, it also has a foreground color. The VStack foreground color is used. No, the other one overrides. That's incorrect. So if a VStack has a foreground color and some text inside, also has a foreground color. Yeah. We must always return some view from a SwiftUI view body. No. We can use the ternary conditional operator to adjust the value sent into a modifier. Yeah, that's a weird one. SwiftUI views should be structs, not classes. That is correct. Structs cannot contain some view allows Swift to figure out exactly what view type is being returned. Yeah. So views cannot be used with computed properties. I'm getting all confused now. So the custom like double negatives and stuff. Custom view modifiers must conform to the view modifier protocol. Yes. View modifiers must return the same view structure they were given. I don't think so. Yeah. Be different views. Okay, SwiftUI lets us create our own custom view modifiers. Yes. View composition refers to making music with view. No. Last one. We can specify. I got the last one wrong in the previous quiz. We can specify a maximum width and height for a view. Specify the maximum width and height for a view. Yes. Sorry, I am just losing it. We got colors cannot be used as views. That is incorrect. We got them all correct. Yay. Okay. We got better rest. Oh, if that's a sign. That is a sign, if anything. Okay, so we've got finish that milestone project. What's under this consolidation 1 to 3? This is what we just did, right? What you learned, key points, challenge. Oh no, this is different. All right, got it. This is a completely new project. We don't move on to the next one yet. Okay, so we are up to day 25. Look, I'm gonna have to call it there. I'm not even coherent anymore after this. I've been at it full on, non-stop, almost no breaks. Went to the bathroom once, I think, and then I had a snack, had some bread. This is a definite fail. I don't think it's possible to get through them all. I have to set up new rules. I think if we want to just really like get through this challenge in a single day, you would have to just be like, I'm just copy and pasting anything, not learning. But throughout this process, I did learn a couple of things. I've been doing this for over 10 years now, iOS development in general, not Swift, because Swift hasn't been that long. But there are some things that I learned, even just in these first 25 days. So like if you're a pro, I reckon you should go through this and do one of them each day, even if you've been doing this for years, because there's some good information in here. It's really, really cool. And it's also fun at the same time. It doesn't feel like a chore. It's a shame that we had to skip over so much of the text though, because there was a lot of really good information in there. But you know what? That's like, I think I need to go sleep. I know it's only been 8 hours. It's nothing, but it's normal work days. Like I said before, I'll have an hour for lunch, right? Like I'll walk around, I'll get up from my desk, I'll stretch, I won't be like non-stop go go go. I'll have meetings spread out throughout the day. This has just been constant, and the talking is difficult to keep going for that long. So I'm gonna call it quits. I'm gonna take the fail. I'm gonna take the fail on this one. I think I'll continue though. I will do another stream where we continue from 25 onwards, and maybe do it in like 10 day chunks. Yeah, I don't know. If you want me to finish it, you got this far in the whole thing, then let me know, and I'll try and get through all 100 days. I think what I will do maybe at the end is like do the quiz. Maybe I'll do just a separate video just for the quiz at the end for going through all the questions. I think there's like 100 questions. Yeah, that'd be kind of fun to do on stream. Anyway, I'm out. Thank you so much for joining me on this. Thank you so much for all the support. I feel like I've disappointed a lot of people who subscribe just to see me do this. I don't know what you all expected. I think many of you knew this wasn't going to work out. I didn't know. I was the last person to know that this wasn't going to work out. But I tried. And you know what? It's okay to do that. It's okay to try. It's okay to fail. We learn from these things and we do better next time. I'm not as embarrassed as I thought I would be. Yeah, this is good. It's been fun. Good stuff, bro. Appreciate it. Thank you so much. Thank you. Next stream, I'll probably be talking about the electronics stuff. So we're going to build an app that can talk to our own electronic devices that we write code for. So I think I don't know if too many people have done that. I think that's rather niche. So it'll be kind of interesting. I think it'll be useful for some other folks who are into that sort of thing. If they want to make their own product, right? You want to invent your own product, you want to prototype it, and you want an app to go with it. I think it'd be good to continue that series. And then I've got a couple of more other ideas in the works I'll work on. But at the moment, I'm back to work full time. Weekends is about the only time I got off at the moment to work on video content. I will try streaming weekdays in the morning. Start the same time as this. Yeah, that's dope. Excellent. I already got the intro up. I think that goes for like an hour or so. It just goes over, if you already know stuff about ESP32s or Raspberry Pis and things like that, you can probably skip over it. The next one will have some actual coding and stuff. But yeah, I'll try and do streams weekdays. Today's a weekend because it's the only time I got off, but early mornings and stuff, for me anyway, in Melbourne. So anyway, enough rambling. Let's go. Talk to you all later. Thank you so much for joining me on this.